because unlike my spatula, it wouldn't just dissolve. And when I eventually felt that it looked good, I lowered in the quartz tube and I increased the gas flow. My goal was to get it to bubble as much as possible without splashing too much, and the idea was that the carry the hydrogen out of the metal. To a certain degree, this would also help mix the gold and aluminum, and when I felt that it was going at a steady rate, I covered it with some insulation. I then had to leave it like this to make sure that I got out as much of the hydrogen as possible, and based on what I read online, about 20 minutes seemed decent. So I basically just had to wait, and in the meantime, I went just our mold. This is because I had to make something that I could compare to the last one and to see if this process, it had been about 20 minutes, so I started blasting the mold with the torch. Then, when I eventually felt that it looked nice and hot, I gassing setup and going as fast as I could, I poured it all into the mold. After that, I waited for it to cool down, and when it got to around room temperature, I popped it out of the mold and I started cleaning it up. Almost immediately, it was already pretty clear that there was a major improvement, and even after very little sanding, it looked like most of the cracks were gone. I would only really be able to once it was all nice and shiny though, so I just kept on going, and many horribly painful hours later, I annealed it, and this was what I eventually had. Without even comparing to the other bar, this one was clearly way better, and what I was extremely happy to see was that it didn't seem to be riddled with a bunch of small holes. To actually know how much better it was, though, I was going to have to pull up a photo of the old one, and the moment that I saw it, the difference genuinely surprised me. It was actually somehow even uglier than I remembered, and it was pretty undeniable that the degassing had made a significant difference. I mean, if I really zoomed in, I could clearly see some very small holes, and it definitely wasn't perfect, but overall, I still thought that it was really nice, and I was very happy with how it turned out. The only thing that was still kind of off was the color, and just like the other bar, it was definitely more on the pink side. However, as I mentioned a couple times earlier, it turned out that this was all just an annoying lighting issue. This was actually something that really messed with my head for a while, and it's honestly sad how long I spent staring at little pieces of metal and trying to compare their colors. What really settled things for me, though, was getting that pendant from Li Hua, which allowed me to compare my stuff to some professionally produced purple gold. I also started using a polarizer for my camera, which would let me remove some of the reflections, and suddenly, it was very clear that they were the same color. To me, this really showed that it was all just lighting, and I think that my bar is just a lot shinier or something, which makes it generally appear brighter. Color aside, though, at this point, I finally had what I felt was a decent way to make the purple gold, and after months of going in circles, this was a huge relief. However, I of course wasn't quite done yet, and the last thing that I still had to do was make my ring, which was the entire reason why I started this project. The only concerning part was that I still wasn't entirely sure how to do this, and I was kind of worried that I'd end up in another horrible pit of trial and error. To try and avoid this, though, I decided to go with the simplest method that I could think of, and the first thing that I did was buy a ring sizer from Amazon. I then tested a bunch of them to see which one fit my finger the best, and this was extremely important. This is because, as we saw before, the purple gold was completely non-malleable, and this meant that any cast that I made had to be almost perfectly pre-sized. With that being said, when I eventually found one that I thought fit, I was able to make a super basic 3D design, and now I just had to turn this into a mold. With normal gold, there are a few common ways to do this, like with lost PLA casting, but I was worried that all of them would end up having issues with the purple gold. So instead, I decided the best idea was to just do it in a graphite mold, which I was now very familiar with, and I knew would probably work. The only tricky part was that I couldn't just buy a mold, and for it to perfectly fit my finger, it was gonna have to be custom made. In theory, I probably could have found someone online to do this for me, but instead I used this as an excuse to buy a CNC machine and to learn how to carve out my own graphite molds. This actually ended up being a lot of fun, even though it was sometimes a bit frustrating, and I can now make pretty much any graphite mold that I want. With that being said, for this project, all I had to do was make this super simple one, and with it now ready, I was finally able to try and make the ring. So again, I just quickly repurified all of the gold that wasn't used to make my big bar, and I remelted half of it in the furnace. I did this so I'd be able to get at least 2 attempts, and I was just hoping that 30 grams of gold and about 7 grams of aluminum would give enough volume for the degassing. I then let it sit there, and after about 15 minutes, I started blasting the mold with a torch, and I was eventually ready to try and pour it. I was honestly really concerned that I would either completely miss or that the metal wouldn't flow through the entire thing, but it turned out to be totally fine. All I had to do now was wait for it to cool down, except this part I was actually more concerned about because I knew that this was going to cause it to shrink. This was also a huge issue because this meant that the inner side of the ring would start contracting while the outer side of it would stretch. And since the purple gold had no real malleability or ductility, this would almost definitely cause it to break. To try and avoid this, I purposely angled the inner edges of the mold, hoping that as it contracted, it might pop itself out without cracking. At the same time, I genuinely believed that there was a narrow window of time where it was possible to manually remove it, and I just kept trying to pry it out. However, I apparently wasn't skilled enough, and it ended up just cracking itself in half. It just snapped. Ah! This was also really sad because the ring had actually molded super well, and now, unless I want to spend days repurifying everything again, I only had one last chance. So I just anxiously whipped together another batch, heated the mold red hot, and carefully poured everything in. This time, though, there somehow wasn't enough metal to fill the entire mold, and at first I was sad about this, but it actually turned out to be a good thing. This is because it prevented the ring from fully connecting, so as it contracted, it didn't just squeeze down on the middle part and snap itself, and I was actually able to get it out of the mold. Huh. Hmm. Huh. Hmm. What I had now wasn't exactly what I was expecting, and it kind of looked like a failed attempt, but at the same time, I felt that this different shape was kind of cool, and I decided to just go with it. I then spent the next couple of days sanding and grinding it, and this time I also used the Dremel, which made things a lot easier. The part that I actually had the most trouble with was just coming up with a design that I liked, and almost the entire time, I was really worried that it would turn out absolutely hideous. Eventually, though, I was able to make something that I felt I was happy with, so I polished it up as best I could and then annealed it, and this was the final result. It was honestly way nicer than I ever imagined it would be, and I kind of found it hard to believe that I had actually done it. I finally had my ring that was made entirely out of purple gold, and it was probably one of the only ones in existence. And after months of work, I think it was all worth it. What was also nice was that it wasn't nearly as fragile as I thought it would be, and even though I'm not going to test it, I don't think it would break if I dropped it. I also don't think that it would be a problem to casually wear it as long as I'm careful, and I would probably just have to avoid accidentally slamming it into things. With all that being said, though, when I first started this project, I was honestly really concerned that it would just be a total failure, especially because of all of the things that I had read online. However, it turned out that purple gold wasn't nearly as bad to work with as I thought, and with just a relatively simple setup, I definitely think that it's possible to make some nice jewelry. I also think that there's still a lot of room for improvement on the method that I used, and I already have a few ideas that I want to test out. For example, something that I really want to try is just using higher purity argon, which has less moisture in it, and I want to try swapping my quartz tubes for something like aluminum. I'm also kind of tempted to completely switch to a different degassing method like ultrasonic, and most importantly, I think there are definitely some better ways to cast and mold it. For now, though, I think I'm kind of tired of melting, casting, and instead I'm going to work on some more tasty projects like turning air into alcohol. Okay, so in the end, this was probably the most tedious and frustrating project that I ever worked on, and what made it even worse was that I somehow kept on losing gold. I honestly still have no idea where it went because I was really careful with everything, and I'm kind of convinced it got evaporated or something with the aluminum. Either way, though, I'm really happy that it's all finally done, and I want to give a big thanks to my patrons for making projects like this possible, and to Opera for sponsoring this video. I've been using Opera on desktop for a while now, and in my opinion, it's still the best browser that I've ever used. Not only is it really fast and intuitive and loaded with a bunch of extra features, it also just got an update to its Lucid mode, which I think is pretty cool. This is because with just a click of a button, it's possible to immediately enhance any video, and now with this update, it's also possible to manually adjust the sharpness, and there's also a button to easily see a before and after. Besides Lucid mode though, another feature that I like is this sidebar, which I think is really useful. This is because it lets me easily access all of the social media that I often use, like Messenger, WhatsApp, Instagram, and TikTok, and it even has an integrated music app where I can listen to things like Spotify and Apple Music. On top of all of this, they even have a built-in VPN service and an ad blocker, as well as some integrated AI tools. In particular, they have Aria, which is Opera's native and completely free AI service, and it's similar to ChatGPT, except with even more features. It's also totally optional whether or not you want to use Aria, and it would only be activated if you choose to opt in. Besides all of these tools, though, what I also really like is their Tab Island feature, which really helps me get all of my tabs under control, and this is especially useful when I'm doing research for a project. With that being said, though, I've been having a really nice time just using Opera in general, and I still think that it's worth giving it a try for just the sidebar alone. It's also, of course, completely free to use, and you can download it right now by clicking the link in the description. That's it. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here. This video has been sponsored by Brilliant. As far as I can remember, I've always been kind of fascinated by liquid nitrogen, which is just this weird foggy liquid that's so cold that it can freeze things to the point that they can shatter. For whatever reason, I've also always wanted to be able to make it myself, just like how I'd seen it done on channels like Applied Science and Veritasium. And in early 2020, I actually ended up reaching out to Veritasium and buying the cryo cooler that he used in his video. I also eventually got it going, where the first thing that I did was make some liquid air, which was technically about 80% nitrogen and nearly just as cold as pure liquid nitrogen. And at the time, I felt that this was good enough. However, in 2023, as I started working on more and more projects that were going to require liquid nitrogen, like the entire air series that I'm planning, where I turn air into things like alcohol, gasoline, and even a bomb, I started thinking about making it again. More specifically, I started thinking that it would be really cool if I could only use my own homemade liquid nitrogen for all of these projects and for all of my future projects in general. And I ended up getting really fixated on this idea. The only tricky part, though, was that for this idea to work, I would need to be able to quickly produce a lot of liquid nitrogen, which unfortunately wouldn't be possible with that cryo cooler that I bought years ago. It also turned out that any commercially available system that was able to do this was shockingly expensive, where even on Alibaba, the lowest price that I was able to get for a cheap Chinese system was for $24,000, which was way more than I was ever willing to pay. Instead of just immediately giving up on this idea, though, I started thinking that it had to be possible to build one for cheaper. At the same time, I also slowly convinced myself that this was something that I would actually be able to do, despite having basically no experience. And well, long story short, I decided to just go for it. So I just went ahead and got started. And the first thing that I did was search the internet for anything that I could find about making a massive liquid nitrogen generator. And unfortunately, I wasn't able to find anything. However, I was able to find several really useful videos of it being done on a smaller scale, where besides the ones that I mentioned earlier by Applied Science and Veritasium, some notable examples were this one by Ben and Builds, this one by the King of Random, and this one by I'm Smoother. As an honorable mention, I also want to point out this one by Hyperspace Pirate, which I didn't see at the time because it was posted shortly after I started this project, but I think it's really impressive, especially because it was done entirely from scratch using a bunch of old AC parts. With that being said, though, after seeing all of this, and after examining every commercially available liquid nitrogen making system that I could find, I was able to get a rough idea of what I had to do. I was also able to put together a rough plan of what I would need to build a massive one myself, where the first major component was going to be something called a membrane nitrogen generator that would allow me to generate pure nitrogen gas from air. The second would then be a massive cryo cooler that I could then use to liquefy this nitrogen gas. It would be a really big insulated dewar where I could then collect this liquid and ideally hold up to 100 liters of it. Along with all of this, there would also, of course, be a bunch of wires, hoses, and miscellaneous parts and accessories to make it all run. But at least for now, I felt that the best idea was to just focus on these three main components. And by focus, I mean that I had to somehow obtain them, which I knew was going to be both difficult and potentially super expensive. What did make things a lot easier, though, was that I actually already had a membrane nitrogen generator that I'd gotten from Veritasium when I bought his cryo cooler. The only tricky part was that I'd never tested it myself, and I wasn't entirely certain that it still worked, but it seemed perfect for what I wanted to do. It was also extremely convenient that I already had it, especially because even used, these things were apparently going for thousands of dollars. With that being said, though, this then meant that I really only had to get my hands on a massive cryo cooler and a huge dewar, where at first, I was actually tempted to try and build them myself. However, after thinking about this for a long time, I realized that this was a completely unrealistic idea, and if I wanted this project to even have a chance of succeeding, I was going to have to buy these parts pre built. I also decided to just keep searching online every day, where I was hoping that I would eventually find the parts that I needed and that they wouldn't be too expensive. It was then one painful month later when I stumbled onto this cryo cooler, which was normally meant to be used in an MRI machine, and I felt that it was my best option. This was because, as far as I could tell, it was one of the most powerful cryo coolers that I could reasonably get, and it was at least several times more powerful than the little one I got from Veritasium. As an added bonus, it was also theoretically capable of getting cold enough to make liquid helium, which is way colder than liquid nitrogen, and I started getting excited about the idea of using it for a future liquid helium project. There was one major downside, though, which was that it wasn't exactly cheap, and it was about $5,600. However, from what I could tell, this was still a really good price because, unlike every other one that I found, which was around the same price and heavily used or in unknown condition, this one was supposed to be brand new. In my opinion, this meant that there was a much higher chance that it would work, and that I was way less likely to be left with a giant and expensive piece of crap that may or may not be possible to repair. So I just went ahead and bought it, and only a few days later, I received this really big and heavy box. I then started opening it, and up until now, part of me was honestly a bit worried that this deal was too good to be true and that I might have gotten scammed, especially because the seller had just joined eBay and had zero feedback, except that thankfully wasn't the case. This was because inside of it, there was in fact a cryo cooler, and at this moment, I was both relieved and pretty excited.
Yes, it's real. It was not scammed. Or I hope. I still don't know if it works, but it does look new, and it's also very heavy.
But anyway, with this hopefully functional cryo cooler in hand, I was officially $5,600 deep into this potential disaster of a project, and what I had to do next was sink even more money into it. So I just hopped back onto eBay, where my goal now was to get the last major piece, which was the large doer. And while looking for the cryo cooler, I had actually found this one that seemed pretty ideal. This was because, just like the cryo cooler, it was apparently brand new, and it was at the very reasonable price of only around $1,100, which was extremely cheap for a doer this big. As an added bonus, it was also technically made for liquid helium, meaning that it was much better insulated than a typical liquid nitrogen doer, and at least in theory, it would pair super well with the cryo cooler and potentially allow me to make liquid helium in the future. The only downside with this doer was that it was apparently 30 years old, which really made me worry that it might have some major issues, and the seller provided no guarantees that it would actually work. This meant that just like the cryo cooler, there was a decent chance that it was just a complete piece of trash that could end up being a total waste of money. However, at the same time, it was only $1,100, which was way cheaper than anything else that I had found, and I decided to just go for it. It was then a few weeks later when I received this extremely large wooden box, which I quickly cracked open to reveal my beautiful duo. After that, I very carefully started taking apart the crate with the help of my favorite hammer, and once most of it was gone, I was able to use some 2x4s to very expertly unload it. I should also say that this probably wasn't the best way to unload it, but I felt that it was fine, and I did put a lot of effort into making sure that the doer wasn't damaged. But anyway, At this point, with the Dewar, cryocooler, and nitrogen membrane generator secured, I now had the three major components of the setup, which I thought was pretty exciting. The only unfortunate part was that I actually wasn't quite done buying equipment, and I still had one last but extremely important thing to get, which was a compressor to run the cryocooler. This was also something that I had no idea that I needed when I first started this project, and this was mostly because I didn't need one for the cryocooler that I got from Veritasium, and it also didn't seem to be needed in the applied science video. It turned out, though, that for those smaller cryocoolers, the compressor was just integrated, and for a massive one, like the one that I had just bought, I was going to need a dedicated external one, which, as far as I could tell, wasn't going to be cheap. In fact, it was looking like it was going to be by far the most expensive part of the setup, and after searching for a really long time, the best deal that I ended up coming across was for just over $10,000. In my opinion, this price was honestly kind of shocking, but at the same time, it was actually cheaper than pretty much everything else that I was able to find. And as far as I could tell, it seemed to be a pretty good price. Most importantly, though, it seemed to be in really good condition, and it claimed that it was taken from a working environment, so at least in theory, it shouldn't have had any major problems. However, just like everything else, there was, of course, no guarantee, and at this point, I was genuinely thinking about just bailing from this project. This was because it was a lot of money to spend on something that might not even work, and if I considered all of the other money that I had already spent, this would now put the project at nearly $17,000, which was way more than I ever expected to pay. At the same time, though, this was technically still over $7,000 less than the cheapest Chinese system that I was able to find, and moreover, I just hated the idea of quitting after already spending thousands of dollars and then being stuck with a useless cryocooler and a giant Dewar. So I decided to take a few days to think about what to do, where I knew pretty much the whole time that the smart decision was to probably just cut my losses, except long story short, I decided to just go for it. I then anxiously waited, and a couple of weeks later, this tiny little pallet arrived, and after slicing open all of the plastic and the packing stuff, I revealed the worst financial decision that I had ever made. In fact, unlike with the Dewar and the cryocooler, it was actually hard to feel excited at this moment, and looking back, I think what I felt was mostly regret. But with that being said, at this point, I now actually had all of the major components that I needed to make a huge liquid nitrogen generator, and with all of this, the first thing that I did was absolutely nothing. This was because every time that I even thought of starting this project, I was almost immediately overwhelmed with anxiety, mostly because I had basically no experience with any of this, but also because I was really afraid of finding out that I had just wasted a ridiculous amount of money on a bunch of non-functional crap. So, out of sheer avoidance, I ended up just letting it all sit around and collect dust until one day I randomly woke up and I felt that I was ready to see just how badly I'd screwed up. I then just went ahead and jumped right into it, and I still wasn't entirely sure where to start, but I felt that the best first step was to figure out how to mount the cryocooler to the Dewar. I also felt that the fastest way to do this was to just steal the design from someone else, and I spent a long time looking at the Chinese systems that I got a quote for, as well as any commercially available ones that I could get a photo or video of. Then, when I eventually felt that I had a decent understanding of what I had to do, I took a bunch of measurements on the top of the Dewar and around the cryocooler mounting ring, and I reached out to my friend Tommy to make a 3D model. He then quickly sent me back this, which I felt looked pretty good, And my basic idea was to get this made out of a giant slab of stainless steel and to mount it to the top of the dewar. With this in place, I figured that I could then attach the cryocooler through the giant hole in the middle, and in the other holes, I would then hopefully be able to add some very important things like my nitrogen gas input, as well as a pressure gauge and some safety valves. In my mind, this seemed like a decent design, and after a few last minute alterations and 3D printing it a few times to make sure that it fit the cryocooler and that it lined up with all the holes in the dewar, I had Tommy send it over to his friend to make it out of stainless steel. I then patiently waited, and eventually I received this nice little package from Husky Machining, and I quickly opened it up to reveal my beautiful plate.
That's nice.
The moment that I saw it, I was also both really impressed with how it turned out and excited that it finally seemed like this project was starting to move. I mean, that wasn't until I suddenly realized that I had accidentally screwed up the 3D model, where not only did I make all of the holes around the center way too big and not get them threaded, I also somehow didn't ask for nearly enough. So unfortunately, I was going to have to fix this, and I ended up spending the rest of the day drilling all of the extra holes, then tapping them to thread them, and adding inserts to make them the proper size. What also made things extra painful was that I tried to speed things up by using a drill to thread the holes, which was a terrible idea, and I ended up spending hours manually removing the broken tap. But either way, when I was eventually done with that, I was very happy with how the plate was looking, and what I had to do next, which will make a lot more sense in a minute, was build a small metal frame. This was also something that I thought would be really fast, except it ended up taking me almost an entire day, mostly because I'm kind of terrible at welding. When I was eventually done, though, what I ended up with was surprisingly nice, considering the disaster that went into making it, and I was pretty happy with how it turned out. But moving on, with my hopefully sturdy frame now built, I quickly dropped on my big steel plate, and I added 4 bolts to loosely hold it in place. Then after that, I added a mounting ring that came with the cryocooler, where I was very happy to see that all of the extra holes that I'd made actually lined up perfectly. And after tightening down all of the screws, I went and got my expensive and heavy cryocooler. I then very carefully lowered it in, and it was really satisfying, and it seemed to fit perfectly. It was also really nice to finally have it out of the box and sitting vertically like this, and at this point, I should probably say that the main purpose of this whole frame setup was to basically just be able to easily test out the cryocooler without having to involve that potentially broken dewar. The only unfortunate part with all of this, though, was that before I could even think about testing it out, I was first going to have to get that really expensive compressor going, where I was genuinely super afraid that it was going to be totally non-functional and that it was going to completely ruin this entire project. However, long story short, it only ended up being kind of non-functional, where to get it going, I did have to do a few things, like swap out this weird power socket on the front for a proper power cable, and repressurize the system to 200 psi using high purity helium gas by following a kind of long and painful procedure that I had found in its service manual. At the same time, I also ended up having to replace the crusty water fittings at the bottom so that I could attach this massive water chiller to cool the compressor, and I had to bring in this 480 volt 3-phase transformer to power the compressor, where both of these were originally meant for one of my air projects, and I had actually gotten the chiller for free. When I was eventually done all of that, though, I had what appeared to be a fully functional compressor, which was really relieving to say the least, and now I was finally able to get back to testing the cryocooler. And by that, I mean that it was finally time to see if it would actually work, or if it was in fact a giant piece of crap that may or may not even be fixable.
Laffy Taffy is smooth, creamy, and knows what cows hum.
Music.
The King Living Autumn Sale is on now. Save up to 50% on Australian design, award-winning furniture. So why buy ordinary furniture when you can come home to King? Hurry, sale on now.
Auto insurance all seems the same until you need it. With USAA, you can file claims, schedule repairs, and access roadside assistance right in the app. Scan for a quote or take your chances.
But with that being said, there was only one way to find out, so I just immediately got started, where the first thing that I did was connect a power cable. Then after that, I quickly added some gas fittings that I bought from the company that made the compressor, along with a helium line, and this was because the first thing that I was going to have to check was whether or not there was still any pressure in the cryo cooler. Where if there wasn't, then, well, at least according to the company that made it, this would likely mean that it had been infiltrated by air and moisture and that it probably wouldn't work. And I was honestly expecting the worst. However, I almost immediately heard a hissing sound when I opened the valve, telling me that even after 7 years, it was still under pressure and that somehow I had apparently gotten super lucky.
That's good.
With that confirmed, though, I then quickly refreshed the helium in it by following a procedure that was very similar to the one that I used for the compressor, and when I was eventually done, I quickly got rid of the special fittings. I then went and got some really long and big helium lines, which I was going to use to properly connect the compressor to the cryo cooler, and I bought them from the company that made the compressor. What was also very important about these helium lines was that they were pre-charged with 200 psi of helium gas, which matched the pressure of the compressor and the cryo cooler. This way, when they were attached, they wouldn't introduce any air or moisture, which would contaminate the system and ruin all of the cleanup work that I just did. But either way, with all of this in place, in theory, the system was now ready to go, and to see if the cryo cooler would actually work, all I had to do was turn on the compressor. So that was exactly what I did by just clicking the on button, and almost immediately, I was greeted with an interesting sound.
Okay.
This was also exactly what I was hoping for, because it was very similar to the cryo cooler sound that I heard in the background of some videos about MRI machines, and this was a very good sign that it was working properly. So far, though, it still seemed to be around room temperature, and to know whether or not it would actually get cold, I was just going to have to wait. So I just sat there and I patiently stared at it, and over the next 20 minutes, I could faintly see it turning white because frost was forming, which confirmed to me that it was definitely getting cold. This was then further confirmed when I tried touching it, and just by the sheer pain, I knew that it was down to at least negative 80 C or negative 112 Fahrenheit. However, this of course still wasn't even close to cold enough to make liquid nitrogen, and to help it out, I decided to insulate it a bit by adding a small dewar over the second stage of the cryo cooler. This part was also, in theory, the part that got the coldest, where it should have had no problem getting all the way down to near absolute zero, and I was really curious to see what would happen. More specifically, I really wanted to see if it could start liquefying the air around it, because if it could, This would prove that it was capable of making liquid nitrogen, which forms at around the same temperature. However, even after an hour, nothing was there, and I was honestly starting to get really worried. This was because it was very possible that the system was working well enough to get really cold and to freeze some moisture out of the air, but it was then failing to get cold enough to actually condense the air. Just for good measure, though, I decided to let it go for another 20 minutes, and I was honestly starting to really lose any hope until I noticed that there was actually a bunch of liquid air already in the dewar. So apparently, I was just super impatient, and it just took a while for the whole system to cool down. And when I looked closer, I was able to clearly see some drops of liquid air. I then let it sit like this, where I just slowly collected more and more. And in my opinion, this was extremely exciting, especially because it was doing it at a much faster rate than the small one I had gotten from Veritasium. What also made it even more amazing was that this second stage was supposed to have way less cooling power than the first stage, which meant that the true liquefying capacity of this system was probably at least several times more than what I was doing here. With that being said, though, I feel like at this point I should probably explain a bit about how this cryo cooler was even working and how it was getting so cold. I should also say that I think the general idea is relatively simple, where this cryo cooler setup was basically just a little refrigerator or heat pump system that exploits the fact that gas gets hot when it's compressed and cold when it expands. Where in this case, the compressor over here was compressing the helium gas that I filled it with, which was causing its pressure to spike by about 100 psi and for it to get really hot. However, it doesn't stay hot for very long because there's a cooling system in the compressor that allows this heat to be dumped into water and pulled away by the chiller. This is also very important because this then allows the system to push cool but high pressure helium through this gas line and into the cryocooler, where it's able to expand. This expansion then in turn causes the helium to get really cold, where it's able to quickly pull a bunch of heat from the cryocooler before getting pushed out into the return line. It then travels as a hot, lower pressure gas back to the compressor, where it gets compressed again, and the cycle is repeated over and over, where every time the cryocooler gets slightly colder and colder. In this case, though, I only needed it to get down to at least liquid nitrogen temperatures, but as I mentioned before, it's supposed to be able to get all the way down to near absolute zero, which I think is kind of insane. Also, I should say that this specific cryocooler that I'm using is a Gifford McMahon, or GM for short, and it's just one of the few common types of cryocoolers out there where they all kind of work in a somewhat similar way. But anyway, after collecting it for about 40 minutes, I had what looked like a pretty decent amount of liquid air, and I was really happy with how things were going. I also decided to do a quick and kind of crappy experiment where I just lit a piece of steel wool on fire, and then I tried pouring my liquid air onto it. For some reason, I thought that because it was such concentrated air, it would burn a lot better, and I guess maybe it did slightly, but it wasn't nearly as interesting as I was hoping it would be. With that being said, though, at this point, I was extremely excited because apparently most of my fears were completely unfounded, where both the compressor and cryocooler seemed to work perfectly. Now, the only remaining question was whether or not the dewar was actually functional, and well, long story short, as far as I could tell, it probably was. This was because when I connected my vacuum pump to it, I was actually able to pull a really strong vacuum in the space between the outer wall and the inner chamber. More specifically, I was able to go all the way down to at least 1 × 10⁻⁵ millibar, which was pretty much exactly what I was hoping for, and I was very happy when I saw this. This was because at this level of vacuum, there would be a very strong insulating effect around the inner chamber, which, at least in theory, would allow me to collect and hold liquid nitrogen in it without having almost any of it boil off. With that being said, though, what was more important than just pulling a vacuum was seeing if it could maintain one once I'd sealed it up and gotten rid of the pump. And well, it seemed to have no issue doing this. This told me that somehow, and by some sort of miracle, there weren't any leaks, which was honestly super surprising to me, especially considering how old this Dewar was. But either way, with the Dewar apparently good to go, this meant that I could finally start putting together the whole system. So that was what I immediately started doing, where the first step was to basically dismantle everything that I'd already put together and to reclaim the mounting disc. I then quickly got rid of that welded frame and I dragged over. It really turned out to be a huge pain because it was way heavier than I remembered it. After a short struggle, though, it was eventually in place, and I quickly leveled it with some shims because my floor is terrible and completely uneven. While I was leveling it, I also thankfully remembered that I had to clean the inside of the Dewar because it was filled with a bunch of dirt, along with a small dead lizard that had apparently made it here all the way from Florida. After carefully removing the lizard, though, and cleaning it out with a vacuum, I felt that it was looking pretty good, and what I had to do next was fully assemble the mounting plate. So I quickly got started with that by first dropping on a gasket that I printed out of TPU using my new 3D printer that was sent to me by Prusa. Then after that, I re-added the cryo cooler mounting ring along with all of its screws, and I tightened it down, and I started adding all of the other peripherals, where the first was some pressure relief valves. I then followed this up with an input for the nitrogen gas, along with a little pressure gauge assembly and a large tri-clamp fitting, and this will all hopefully make a lot more sense later on. With the plate now ready, though, I then quickly brought it over to the Dewar, and I carefully placed it on top, and I screwed it down tightly to seal it. It was also only at this moment that I realized that I completely forgot to put locker on all of the screws in the mounting ring, which was very important to quickly take them all out and properly seal them. With everything now securely in place, though, I then went and got the surprisingly heavy cryo cooler, which was around 50 pounds, and it was honestly a bit nerve-wracking to carry it up the ladder. I also didn't exactly feel super safe or comfortable having to lean over with it so that I could carry it into the plate, but thankfully, I was able to do it without any major disaster. With it loaded on, I then fastened it with some screws that I actually remembered to cover with thread locker this time, and with it securely in place, I was starting to get pretty excited. This was because so far, things actually seemed to be going together as I planned, and now there were just a few final things still left to do, like adding a large sight glass to that tri-clamp fitting from before. I also quickly lowered in a small strip of LED lights through a port on the cryo cooler, and together, these would allow me to see inside the Dewar while it was running, which I felt was very important. Then after that, I just quickly reattached the helium lines along with the power cable, and I carefully shoved a huge siphon tube assembly down the valve that was connected to the pressure gauge. This part was also especially important because it would allow me to actually take the liquid nitrogen out of the Dewar. I mean, assuming that I did end up making any. Moving on, though, at this point, the main part of the system was officially done, and the only thing that I still needed was a nitrogen source, where for that, I put together this cute little setup. At first, it also might look a bit complicated, but it actually wasn't too bad, where the main part of it was just my membrane nitrogen generator. This thing over here was then just an air compressor, which would be my main source of gas, And the basic idea was that it would push high pressure air into the nitrogen membrane, which was filled with a series of hollow polymer fibers. These polymer fibers were very special, though, because they were selectively permeable to oxygen and water vapor, where they would allow both of these gases to pass through their walls at a much faster rate than nitrogen. The result of this would then be a concentrating effect, where the nitrogen in the compressed air would slowly get more and more concentrated as it traveled up the tube, and the oxygen and water vapor would get rejected out of these holes at the bottom. In theory, it was also supposed to be possible to get the nitrogen concentration all the way up to nearly 100%, which was way better than the 78% that's in normal air. And in my opinion, it's really amazing that a simple looking tube can even do that. It was then just fed into a regulator to knock down the pressure, followed by a gas flow meter, which would tell me. What was also kind of funny was that up until this point, I'd actually never tested if the tube even worked. So I decided to quickly do that now by opening up the gas flow and by holding an oxygen meter to the end of it. I was happy to see that it quickly went down to a nice reading of 0, which told me that all of the oxygen was gone and that it should have been effectively 100% nitrogen. With that thankfully confirmed, I then went ahead and connected the flow meter to the nitrogen input on the setup, and at this point, it was finally ready. What I had now should have been a fully functional liquid nitrogen generator, and after spending probably way too much time, money, and effort on putting this all together, I could finally test it out, and I was feeling both excited and nervous.
Okay. Should be good.
With that being said, I then just went ahead and got started by first opening the valve on the siphon tube, followed by the nitrogen regulator. This then caused pure nitrogen gas to start flowing through the system, where the goal was to completely replace all of the air that was currently in the dewar. To monitor this, I also just occasionally checked the output with the oxygen meter, and when it eventually started reading 0%, I closed the siphon tube valve, but the nitrogen gas input open. This then caused the pressure in the dewar to slowly rise, where I let it pressurize just up to the rating of my lowest pressure relief valve, which was at around 1 psi. This, of course, wasn't actually very much pressure, but it should have been enough to keep out any air or moisture, and at this point, it should have been good to go. So I turned on the compressor.
And that's it.
Now, at least in theory, all I had to do was just leave it like this, and if it went anything like my earlier test, it would eventually start generating some liquid nitrogen. I also knew that this was going to take a while to happen, especially because this time, it was first going to have to cool down this huge dewar.
What do you get when you cross smooth, creamy, and hilarious?
Laffy Taffy.
Mommy, can I go?
Stop advertising your servers to archaeologists on site surveys. Start marketing to the right people by targeting industries and functions on LinkedIn ads.
However, despite knowing this, over the next few hours, I still slowly got more and more concerned when I didn't see anything condensing, and I genuinely started worrying that maybe the dewar was in fact trash, or that maybe I'd somehow messed up the cryo cooler or the compressor while I was putting it all back together. It turned out, though, that I was mostly just really impatient and freaking out for no reason because it wasn't too I started seeing the first drops of some beautiful liquid nitrogen. Yes! It's actually condensing it. Ugh. Then, only an hour later, it was basically raining liquid nitrogen in there, which was really exciting to see. And I thought that it was kind of satisfying to watch it all fall and crash on the bottom of the dewar. At the same time, though, I couldn't help but get kind of concerned when I noticed that none of it was collecting, and it seemed like it was all just instantly boiling off. What also really didn't help was that this didn't seem to change even after an hour of waiting, and this made me really worry again that the dewar might have actually been non-functional or something, where if that were the case, it would have never been able to collect anything. Long story short, though, I was again just really impatient because it wasn't too long after this that a pool of it started forming at the bottom, which was really relieving to see. Yes! It's finally collecting something! From there, this pool then grew relatively quickly, where only several hours later, I already had what looked like a decent amount, and at this point, I was feeling pretty excited. Wow. Okay, there's a good amount. I mean, it's going now. The only unfortunate part was that it wasn't too long after this when I looked over at the pressure gauge and I noticed that it was at 0 instead of 1, which told me that the cryocooler wasn't getting nearly enough gas. So I looked over at the nitrogen generator to see what was happening, and I noticed that the flow meter was apparently maxed out with a reading of nearly 6 liters per minute, which wasn't exactly ideal. This was because this nitrogen generator was only able to provide pure nitrogen at up to 4 liters per minute, and this meant that the gas coming over now was contaminated with oxygen and water. The exact level of contamination was also completely unknown, but as far as I could tell, it most likely wasn't that bad, and the nitrogen purity was still probably above 95%. In my opinion, this was something that I was able to tolerate for this first run, so I decided to just leave it like this. But in general, this was definitely something that I would have to address later on. With that being said, though, over the next day or so, the liquid level then just continued increasing, and it slowly got hazier and hazier because of the water making it past the nitrogen generator. I was then eventually able to fill the entire bottom part, which was really exciting because this should have been about 30 liters. And when this happened, I decided to turn everything off. This was mostly because at this point, it was pretty clear that the system did in fact work, but also it was because what I had now was more than enough for the one last and very important thing that I still had to test. This, of course, was to see if that siphon tube that I put in earlier would actually work, and whether or not I would actually be able to get any of this liquid nitrogen out of the dewar, where if I couldn't, then, well, it would kind of be a huge disaster. There was only one way to find out, though, so I just got started with it by first attaching this large insulated extraction hose that I'd gotten on eBay for a really good price. Then after that, I just cranked up the nitrogen flow even more, and I blocked the 1 psi relief valve, and the goal was to slowly increase the pressure inside the dewar. While I was waiting for it to increase, I also added a bowl, and I went and changed into some proper protection, which included some sealed boots and a face shield, because I was honestly a bit worried that this whole system might explode. This was because even though I was only going to be raising the pressure by maybe several psi, I had no idea if this dewar was actually rated to take any pressure at all. And when I had asked the company that made it, they didn't recommend it. More specifically, they said that they didn't necessarily design their dewars to have much more than maybe 5 psi in the reservoir, which really did not inspire confidence, especially with a second-hand 30-year-old Dewar. With that in mind, though, I then just let the pressure slowly climb, and when it eventually got to around 2 psi, I decided to try opening the siphon, and I was expecting to hear something or to see some cold vapor coming out, except literally nothing happened. This told me that the pressure was likely still too low, and that I was going to have to push it a little more, which I wasn't exactly excited about. I didn't really have a choice though, so I just closed the valve and I let it climb, and as it increased, I slowly got more and more nervous. Then, when it eventually got to a little over 4 without exploding, I felt that this had to be good enough, and I opened the valve again. This time, I was also instantly greeted with a kind of horrible whistling noise, which told me that the liquid nitrogen was actually moving up the siphon tube. Then, not too long after, I started seeing some nice and cold vapors coming out, and I was really hoping that I would soon get an amazing rush of liquid nitrogen that would just spray out the end of the hose. However, that unfortunately did not happen at all, and it wasn't nearly as impressive as I had imagined. I guess on the positive side, though, it was actually coming out, which told me that the siphon tube was working, and it did kind of speed up over the next few minutes. I was then eventually able to fill this entire bowl with liquid nitrogen, which was about 3.5 liters, and when I saw this, this was because finally, after working for what felt like forever on this project, I actually had a bunch of my own homemade liquid nitrogen sitting right in front of me. What also made things even more exciting was that this was only a fraction of what was still in the Dewar, and I felt that I had to celebrate this by freezing something, where the first thing that I came across was this old orange. I then patiently waited for it to fully solidify, and I spent the next several minutes having way too much fun smashing it and turning it into a crunchy orange dust. When I was eventually done celebrating, though, I quickly cleaned up my huge mess, and I started draining all of the remaining liquid nitrogen into an empty 30-liter Dewar. I was then able to completely empty out everything that I had made, which nearly filled this entire Dewar, and at this point, I was feeling pretty good about my setup. This was because overall, it clearly worked, and on top of that, I was actually able to make a decent amount of liquid nitrogen at a rate of about 0.58 liters an hour, or around 14 liters a day. This was also way better than I ever expected for my first run, where it was already kind of close to the 20 liters a day advertised by those Chinese systems, and honestly, I was really tempted to say this was good enough. However, at the same time, there were just way too many glaring problems that I couldn't let go of, like the fact that the liquid nitrogen was being heavily contaminated by oxygen and water vapor, and that the extraction system was almost comically slow. There were also some other major things that I really didn't like about the system in general, especially the fact that I still wasn't even close to maxing out the cryocooler, and I felt that I had to do some final fixes. So again, I ended up taking the whole thing apart, and I immediately started working on all of the random changes that I wanted to do. And after about a month of effort, this was what I ended up with, where for the most part, it still kind of looked the same. However, there were some pretty major upgrades, where the nitrogen generator was now massive, and everything on top of the Dewar was rearranged. Extra things were added. When I tested it out, it was also very obvious that it was way better than before, where the first thing that I noticed was that it was producing a lot more liquid nitrogen. In fact, it was actually making over 1 liter an hour, which was nearly twice as fast as it was before, and at this point, I was definitely maxing out the cryo cooler. At the same time, everything that I was making was crystal clear with no sign of fogging or haziness, and over a few days, I was actually able to collect nearly 100 liters of beautiful liquid nitrogen, which was the obscene amount that I only dreamed of making when I first started this project. I should also say that this was all only possible thanks to this completely new and massive nitrogen generator that I put together, which was able to output around 7 times more nitrogen gas than the old one. What was probably my favorite upgrade, though, was swapping out the simple sight glass for this new probe lens and phone setup, which, along with this new powerful flashlight at the back, allowed me to easily see inside and to record this way higher quality video. It also allowed me to easily monitor the liquid nitrogen level remotely from my computer, which may or may not be a bit overkill, but I found it to be pretty useful. There was just one kind of sad part with this whole new setup, though, which was that despite making the siphon tube way bigger and swapping the extraction hose to one with a much higher flow rate, it still didn't end up blasting out like the fire hose that I was hoping for. I mean, to be fair, it was definitely way faster than before, where I was actually able to fill this entire bowl in around 2 minutes, which was so much better than the nearly 12 minutes that it took last time. When I did a side-by-side comparing the two, the difference was also super obvious, and for the most part, I'm happy with how it is now. Overall, I was also very happy with how this entire project had turned out, and after transferring all of the liquid nitrogen to my 30-liter dewar, as well as to a new 60-liter dewar, I finally felt that I was done. This was because at this point, I had successfully put together a huge liquid nitrogen generator that actually outperformed the Chinese systems that I was originally looking at, and that at least technically did end up being cheaper. At the same time, it was also basically able to do everything that I wanted, and liters at a time, and there really wasn't much else that I wanted to change or fix. I mean, besides the slight problem that there did end up being a small leak in the dewar, which means that every time that I want to run the system, I'm going to have to run the vacuum pump at the same time. And while this is mostly just a minor inconvenience, I should probably try and fix this in the future. Until then, though, I'm just going to focus on the fact that from this point on, I can officially use only my own homemade liquid nitrogen for all of my future projects. In my opinion, this is also really exciting, especially because I have a bunch of really interesting projects lined up, like that entire Air series that I mentioned earlier, as well as a couple that I'm not ready to talk about yet.
It's so bright. What is this?
What I'm probably most excited about, though, is that this now puts me one step closer to my dream of recreating this superconductor demo that I did years ago, only things that I've made. At the time, only the superconductor and the ferrofluid were mine, but now I could add liquid nitrogen to the list, and this meant that the only things left to make were the glass dish and the magnet, both of which I'm currently working on. I'm also hoping that I'll be able to finish all of this by next year, and that it won't be too horribly expensive, but if it is, I should still be okay thanks to all of my amazing YouTube members and patrons, and because of Brilliant, the sponsor of this video. I've been using Brilliant for years now, and with tons of lessons in things like math, science, and computer science, I still think that it's one of the best ways to learn something new. All of their courses are fully interactive, which makes it feel a lot more like a game, and not like you're just watching a lecture or reading a textbook. On top of that, what's also really nice is that every course is chopped up into a bunch of smaller levels, which has allowed me to go through each one at my own pace, and this has been particularly helpful for me with some of their more complicated topics. For example, I just recently started their course on digital circuits, which covers everything from basic logic gates all the way to building simple computers, and I've found that being able to slow things down and take breaks has been really useful. Also, even though this is a complicated topic that I know very little about, it has still been a lot of fun, and I've still been able to progress, even when I only have 5 minutes here or there to work on it, which I think is really nice. But anyway, as I've said many times before, I personally really like Brilliant, and if you're looking for a fun and easy way to learn something new, I definitely recommend checking them out. Where right now you can actually start learning on Brilliant for free by going to brilliant.org/NiallRed, by scanning the QR code on screen, or by clicking on the link in the description. On top of this, Brilliant has also given all of our viewers 20% off an annual premium subscription, which will allow you to have unlimited daily access to everything they have to offer. But with that being said, I hope you enjoyed the video, and I hope to see you next time when I turn air into alcohol. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.
Introducing King Cinema, designed to be the most advanced seating experience. So why buy an ordinary sofa when you can come home to King? Hurry, sell on now.
Laffy Taffy is smooth, creamy, and knows what cows hum.
Music.
This video has been sponsored by Brilliant. As a kid, I was fascinated by things that were able to glow in the dark because to me, it was kind of like magic. It blew my mind that simple plastic toys and stickers could somehow collect and store light energy. I recently tried looking for some of the old glow toys that I had as a kid, especially a little dinosaur that was my favorite, but I think my mom gave them away years ago. This made me a bit sad, and I went online to try to find some replacements. I was able to find some that looked kind of similar, and I was about to get them, but then I realized it could actually be a lot more fun if I made them myself. At first, the idea of making something that glowed seemed almost impossible to me, and I assumed that it had to be super complicated and difficult. However, it turns out that at least it's surprisingly simple. One of the most common glow powders is just made from something called zinc sulfide, which is a relatively cheap and naturally occurring mineral. I really thought that there had to be some uncommon elements involved, but it was apparently possible with just generic zinc and sulfur. With a quick Google search, it was easy to find a lot of places that were selling the zinc sulfide glow powder. So to make my toys, I could have just bought some, mixed it into some plastic, and poured it all into a mold. But to me, that was almost the same as buying the pre-made glow toys, except with some added steps. What I wanted to do was make my own glow powder completely from scratch. To do this, I was going to have to make zinc sulfide, and I found that the easiest way was to burn a mixture of sulfur and zinc metal. So I went and got my zinc powder, and I added about 50 grams of it to a beaker, along with about 24 grams of sulfur. To mix them, I just kept pouring it back and forth between two beakers until the color looked like it was even. After that, it was pretty much good to go, and I started out by testing just a small amount of it. It was supposed to be possible to set it off by just touching it with a hot glass rod, but when I tried it, it didn't seem to work very well. I held it there for a bit, and it eventually kind of started working, but it almost immediately died out. I thought that maybe the glass rod just wasn't hot enough or something, so I tried it with some red hot metal. This didn't turn out to be a great method either, but after abandoning it for a bit, it did eventually work. These methods clearly weren't working very well, and I found that it was a lot better to just blast it with a blowtorch. This made it way easier to get started, but it didn't fix the major problem that this method sucked. Regardless of the way that it was ignited, it always sprayed the zinc sulfide everywhere. Sulfide was also really impure. I knew this just by looking at it because pure zinc sulfide is white, and this definitely wasn't some nice, clean, and white powder. The reason for this is that it's just not possible for these powders to react perfectly together, and in the presence of air, a bunch of it also reacts with the oxygen, and it just ends up being a mess. Now, to see if it worked, I shot it with a black light, which should cause it to light up. However, what I had here for just a few spots. I then turned off the light to see if it would glow, and there was absolutely nothing. But that actually didn't surprise me. Zinc sulfide on its own just isn't able to glow. To get it to glow, it has to be doped with a metal, and it's common to use things like copper or silver. The usual procedure is to first make the zinc sulfide, and then in a second step, infuse it with the metal. Here was really bad quality. If I tried to dope a metal into it, it would almost definitely end up being a complete failure, and it was also so impure that trying to clean it up wasn't really feasible either. I did see a few videos though, where before burning it, a small amount of copper metal was mixed into the zinc and sulfur, and it kind of seemed to work. I figured that I might as well try it out myself, and it was almost exactly the same thing that I just did. The only difference was that along with the zinc and sulfur, I also mixed in a small amount of powdered copper metal, like with a black light, and I think it's safe to say that it wasn't a huge success. I don't even know how it's possible, but it was somehow worse than before. Despite this, I was still hopeful that some of it might glow, but no. My results here were definitely a lot worse than some of the videos that I saw, but they also weren't very surprising. I honestly pretty much expected it to turn out this way, because to make some actually decent glow-in-the-dark zinc sulfide, it's unfortunately a lot harder than just mixing some things together and lighting them on fire. It's a much more difficult and finicky process where I'd first have to make some pure zinc sulfide and then carefully incorporate a metal like copper into its crystal structure. The biggest thing that makes this process so hard is that the zinc sulfide needs to be extremely pure, and even a very small amount of contamination from metals like iron can completely ruin the glow. So the first step was to make pure zinc sulfide, and the best way that I found to do this was to start with another zinc compound called zinc sulfate. The reason for this is that unlike the zinc sulfide is soluble in water, and it's much easier to purify. So the plan was to make some really pure zinc sulfate and then convert that directly into pure zinc sulfide. This whole purification part was based on a few videos that I saw here on YouTube, and it was pretty much the only decent method that I found. The guy was also apparently able to use the zinc sulfide that he made to make glow-in-the-dark powder, and it all looked pretty promising. Now, to get the zinc sulfate, it was thankfully really cheap and easy to find, and I was able to get a pound of it from Amazon for $13. A pound of it was way more than I was ever going to need, but I actually had a hard time finding anyone selling less than that. But either way, I now had my zinc sulfate, and the first thing that I had to do was clean it up. To get started, I added about half a liter of distilled water to a very clean beaker, and I turned on the stirring. I then added 125 grams of the zinc sulfate, and I cranked up the heating. After just a few minutes, it was already quite warm, and I quickly water. This was about 10 minutes later, and in theory, if this were pure zinc sulfate, it would have been both perfectly clear and colorless. This definitely wasn't what I had, and the zinc sulfate was obviously not the highest grade stuff. But that didn't really matter because regardless of how pure or impure it might have been, the cleanup was going to be the same. The first step to clean it was to add a very small amount of something called potassium permanganate. The moment that I added it, it all started turning brown, and this told me that it was definitely reacting with something. This is because normally potassium permanganate has a really strong purple color, and it only turns brown if it's getting degraded. Over the next few minutes, it turned almost black, and I pulled out some of it with a pipette to check the color. If there were even a tiny amount of the permanganate left, it would have been purple, or at least slightly pink, of yellow and brown. This told me that all the permanganate had probably reacted, and that I had to add some more. I then let it stir for about 10 minutes, and I waited to see if the color would disappear. What I was doing here was oxidizing a lot of the different metal contaminants that were in there, especially iron, and converting them into a form that was insoluble in water. This would cause them to separate out as a solid, and to get rid of them, I just have to filter them off. I think the major contaminant here was, like I just said, from iron, and I think that a lot of the dark brown, almost black stuff was just iron hydroxide. A lot of it, though, was also manganese dioxide, which formed as the permanganate reacted and broke down. As the permanganate degraded, it also unfortunately released potassium ions, which dissolved into the solution. This was adding a potassium impurity that wasn't there before, but this wasn't going to be an issue, and I'll talk more about that later on. After 10 minutes, I checked the color again, and it was still a bit purple. So the next thing to do was crank up the heat and to boil it for about an hour. This extra heat just made the permanganate even more aggressive, and it made sure that it would oxidize everything that it possibly could. When it was done, I took it off the hot plate and I put it into some ice water. While it was still hot, most of the oxides and the impurities were able to stay dissolved, but as it cooled, they all started to separate out. I let it sit there for a while, and when it got to just around room temperature, I poured it all into a coffee filter. This would get rid of all that solid junk, and in a bowl underneath, I collected all the liquid. When it was done, I had a solution of zinc sulfate with little to no iron, but it definitely wasn't pure yet. It was dark purple from all the permanganate that I had added, and there was still more metal contamination that I had to get rid of. So there was still a bunch of cleaning up to do. To do this, I put it all back into a beaker with a stir bar, turned on the stirring, and I dumped in 30 grams of powdered zinc metal. This was the exact same stuff that I had used before when burning it with the sulfur. What I was doing now was the complete opposite of the permanganate, where instead of oxidizing everything, I was trying to reduce it. To a certain degree, the zinc was trying to react with the permanganate, but because there wasn't any extra acid around, it was having a really hard time. To get it going, I could have added some acid, but I figured that the best thing to do was to instead add a small amount of hydrogen peroxide. This caused the rest of the permanganate to fall apart, and it all turned into more manganese dioxide, potassium hydroxide, oxygen gas, and water. Like before, the manganese dioxide all separated out, and later on, it would just get filtered off along with the zinc metal. The potassium hydroxide would dissolve into the solution though, and it would stay as an impurity. This would add on to all the potassium that was already there from the last step, but this shouldn't be a problem, and again, I'll talk about it more in a bit. I let it stir here for another 20 minutes, and this gave the zinc some time to attack the other metal impurities that might be there. For zinc sulfate, these usually tend to be things like copper, lead, nickel, cadmium, and cobalt. The zinc metal is able to react with these metal ions and reduce them back to their solid metallic form. This caused them to separate out, but because there was already so much zinc flying around, it wasn't possible to see much happening. When it was done, it looked almost the same, and I again filtered it using a coffee filter. It was able to trap almost everything, but the solution was still a bit cloudy. So I waited for it to be almost done, and then I passed it all through the same filter again. This time it was way better, but I could still see some stuff in it. While editing now and seeing it on video, I find it really hard to see, but in person, there was definitely still some metal dust or something else in there. So I decided to just cover the top and to wait for it to settle out overnight. This was the next day, and it's hard to see any difference at all, but it had all sank to the bottom. To get rid of it, I just poured the liquid into a new beaker, and that was pretty much it. What I had now was a very clean solution of zinc sulfate, and the only real contaminant should be from those potassium ions, which were all still there. Now what I had to do was convert this pure zinc sulfate into the zinc sulfide that I actually wanted. This was thankfully relatively easy to do, and I just had to bubble some hydrogen sulfide gas into the zinc sulfate. Unfortunately though, I didn't just have hydrogen sulfide gas sitting around ready to be used, and I was gonna have to make it myself. To do this, I had to go back to burning things like I did with the zinc and sulfur. However, instead of using zinc powder, I had to use iron. To prepare it, it was pretty much the exact same as before, except it was a different ratio between the iron and the sulfur. This mixture was also a lot more sensitive than the other one, and it could be easily set off by just touching it with a hot glass rod. I've done this reaction many times before, and it honestly has to be one of my favorites. I always find it oddly mesmerizing, and I really like the sound that it makes. It also generates a lot of heat, and you can sometimes feel it even from a few feet away. What was happening here was very similar to what we saw with the zinc, except this time, because it was with iron, it was making iron sulfide. This iron sulfide, unlike the zinc version, reacts really easily with acids, and I can make a lot of hydrogen sulfide gas by just dripping some acid on it. When it had cooled down, I used a small fork, and I broke it into some smaller pieces. I then weighed out about 100 grams of it, and I dumped it all into a flask. The flask was then loaded up with a stopper, an addition funnel, and a gas adapter, and I added some clamps. After that, I filled a gas wash bottle with water, and I connected it to the gas adapter. This way, all the hydrogen sulfide that was made in this flask would get pushed out through the gas adapter and then through some water, which would help clean it up a bit. The other end of this wash bottle was then linked to the upper portion of another wash bottle. For this one though, I didn't include any water or even the bottle itself. All the hydrogen sulfide that would be coming out here would instead be pumped directly into that pure zinc sulfate solution. At this point, I felt that things were pretty much good to go, so I poured some dilute hydrochloric acid into the addition funnel. Now to get things going, all I had to do was open the addition funnel. This let out some of the acid, which immediately started reacting and bubbling when it hit the iron sulfide. I could see it all bubbling through the wash bottle, which was not only cleaning it, but also helping me gauge making. Then after that, it was all getting pushed into the zinc sulfate solution. The moment that it touched it, it started reacting and forming zinc sulfide, which wasn't soluble in water. This caused it to separate out as some really fine particles, and it was also super white and not a dirty yellow like we saw before. It was also making sulfuric acid though, which was able to react with the zinc sulfide and turn it back into zinc sulfate. In the beginning, this wasn't really a problem, but the solution was slowly getting more and more acidic. Eventually, after reacting with probably less than 30% of the zinc sulfate, it would hit a point where there was too much acid. Then after that, any new zinc sulfide would just get turned back into the sulfate. So the reaction would eventually stop, but at that point, there would still be probably more than 70% of the zinc sulfate still just sitting there. Having a reaction shut down early like that is usually a bad thing, but in this case, it was totally fine. This was because any other metal impurities that might be there were also trying to react with the hydrogen sulfide. And if they did, a lot of them would also form insoluble sulfides and separate out along with the zinc sulfide. The largest impurity was from all that potassium that I mentioned earlier, but that actually wasn't an issue because potassium sulfide isn't stable. It was just breaking down again almost the moment that it formed, and it was basically just staying as potassium ions. The concern that I had was more for metal ions like manganese, cobalt, or copper, because those could easily form insoluble sulfides. This, of course, wouldn't be good, but by always keeping a lot of zinc around, it meant that the hydrogen sulfide was just always more likely to bump into a zinc than any of the impurities. So basically, from all this, I'll be getting less zinc sulfide in the end, but the stuff that I do get should be more pure.
Tostitos makes masa the traditional way, crafting the perfect crunch. Tradition matters.
With bugs, the struggle is real. That's why you need Zevo traps. Zevo works 24/7 to lure, catch, and kill 99.9% of bugs trapped for effortless protection. Zevo, people friendly, bug deadly.
You're home for the holidays, back in your old room.
Oh,
At least you can get a deal on new shorts for Dad. Something with a little more coverage. Leo's working hard, growing. Pampers is working hard, keeping him dry. Only Pampers Swaddlers has a Keep Dry liner to keep him comfortably dry. Pampers, behind every baby.
Every Monday and Tuesday, the NBA is on ABC and Peacock. 2 nights of NBA action. Every Monday and Tuesday on NBC and Peacock.
Now, as a quick point of safety, what I was doing here looked relatively simple and mundane, but it was actually quite dangerous, and I had to be very careful. This is because the toxicity of hydrogen sulfide gas is comparable to cyanide. Humans are really sensitive to its gross and rotten egg smell, which helps us avoid it, but we also get quickly desensitized to it. So if you're around it for a bit, you usually completely stop smelling it, even in potentially deadly concentrations. I was doing this in a really strong fume hood, which would keep me safe, and I also had test strips set up in the room to monitor if any of it was building up, but it was still something that made me a bit nervous. When all the iron sulfide was eventually used up, I considered the reaction done. Now, to separate all the zinc sulfide that I had made, I just had to do another filtration. This time, though, I didn't just use a coffee filter and do it by gravity, and I instead used a vacuum filter and a proper filter paper. After I pulled everything through, I also washed the zinc sulfide a few times with distilled water. I was eventually left with all this pasty-looking stuff, and I transferred it all to a bowl. I now had to completely dry it, and I just threw it into an oven at a low heat for a few hours. When it was done, it was really dry and crispy. I then quickly crushed it up a bit, and I put it all into a small bottle. I went ahead and weighed it, and it was only 15.5 grams, where in theory, I could have gotten about 68. However, this low yield was expected because I had chosen to make less of it in exchange for what was hopefully a higher purity. Now, what I wanted to do first with the zinc sulfide was to see if it were able to glow. So I turned off the lights and I shot it with some UV, and well, it did absolutely nothing. But that was pretty much what I expected, because as we saw earlier, it doesn't work with just zinc sulfide. For it to glow, it had to be doped with a metal, and I had a few different options. The most common ones are silver for blue light, manganese for a reddish orange, and copper for green. I felt that it was important for my glow toys to have that classic green color, so I had to go with copper. For the doping process, I had never really done it before, but based on another YouTube video that I saw, it seemed to be relatively straightforward. The first step was to make a very dilute solution of copper ions, and to do this, I needed a water-soluble copper compound. It seemed like everyone went with copper sulfate, so I did as well, and I found some supposedly pure stuff on Amazon. It said that it was 99.9% pure, and it also wasn't very expensive, and it arrived a few days later. Even though it said that it was pure, I assumed that I was going to have to clean it up, but when I opened it, it did look really pure. It was all still crystalline, and for almost any other project, I would have just used it immediately without any second thoughts. But for this one, as I've mentioned many times already, even an extremely small level of contamination from other metals like iron could completely ruin everything. I really wanted to just say screw it and use it right away, but there was a very real chance that it could destroy all the zinc sulfide that I just spent days making. But on the other side, I also didn't want to potentially waste time purifying it when it might be fine. So what I decided to do was try it on a small scale with only 2 grams of the zinc sulfide. If it worked and I was able to get it to glow, it would not only tell me that the copper sulfate was good enough, it would also tell me that I actually made pure zinc sulfide. To try this, I started by making a copper solution, and the amount of copper sulfate that I needed for this was so small that it made me laugh a bit. I bought this 1 kilo bottle for the project, but just one medium-sized crystal was gonna be way more than I needed. I dropped the crystal into a bottle, poured in 50 mils of distilled water, and turned on the stirring. The color of copper sulfate is very strong, and every time I've worked with it, I would get a solution with a really nice blue color. However, this time, what I was making was so dilute that by the time it had all dissolved, it didn't look like anything had changed. But either way, what I had now was a solution of copper sulfate with an insanely low concentration. The crystal that I used only weighed 38 milligrams, so in every milliliter here, there was less than a milligram. I then got a beaker, added the 2 grams of zinc sulfide, and poured in 20 mils of distilled water. I mixed this around for a couple minutes, and then I added just 2 mils of that copper solution that I just made. I mixed this again for a couple minutes, and then I added 4 mils of a dilute solution of ammonium chloride. The purpose of this ammonium chloride was to act as something called a flux, and I'll talk more about it in a few minutes. I swirled this all around a bit, and when I felt that it was ready, I turned on the hot plate. What I had to do now was slowly get rid of all the water without bringing it to a boil. An hour later, it looked like a nice and dry powder, and I figured it was done. What I had now should be some zinc sulfide powder that was evenly coated with only 1.5 milligrams of the copper sulfate. This was an insanely small amount, and it was why it was so important to remove all the impurities. I really had to have just copper here, and even a few milligrams of another metal would have been pretty bad. This powder, however, still won't glow because right now the copper was just physically sitting on the surface of the zinc sulfide. For it to glow, the copper needs to become part of the zinc sulfide crystal structure, and to do this, I had to use some fire. I loaded everything into a quartz tube, and it was important to use quartz here because a regular test tube would have just melted. Then just for fun, I tested it again with a UV light, but as expected, it did nothing. After that, I filled the tube with nitrogen gas, loosely covered the top with some plastic wrap, and I blasted it with a torch until it started glowing yellow. I then tried to keep it glowing like this for 10 minutes. I had a hard time finding much info about it, but it was at this step that the ammonium chloride that I had added was supposed to be helping. I only found one reference, but it said that in order for the copper to get incorporated into the zinc sulfide, there had to be chloride, bromide, or iodide ions present. Pure zinc sulfide and copper sulfate, though, wouldn't have any of these, so I had to add at least one of them. Ammonium chloride was used because it was an easy source of the chloride, but also because it breaks down really cleanly. Any extra ammonium chloride should just decompose into ammonia and hydrogen chloride gas, and it shouldn't leave anything behind. After firing it, I let it slowly cool back down to room temperature. As it did this, the crystalline structure of the zinc sulfide was changing, and it was hopefully incorporating the copper into it. When it was finally at room temperature, I was ready to test it with the UV again, but I was honestly quite nervous. I was really scared because if it didn't glow at all, I'd have absolutely no idea what to do. A total failure could be caused by so many things, like impure zinc sulfide, a bad doping process, impure copper sulfate, or even just metal contamination from my glassware. And going back and having to test and fix all these things would be an absolute nightmare. So I took a deep breath, turned on my light, and I was really happy to see that it was giving off a nice green color. This was a very good sign that it had worked, and it meant that the copper had, at least in some way, incorporated itself into the zinc sulfide. However, what I was seeing here was just something called fluorescence, where the light was being absorbed by the zinc sulfide, and the energy was almost immediately getting spit back out as green light. Fluorescence is extremely fast, and there's no storage of energy, so the moment the UV light was turned off, the green light looked like it disappeared. It all disappearing, though, wasn't necessarily a bad thing, because fluorescence isn't what makes things glow in the dark. For that, we need to have a different process going on called phosphorescence. When something's phosphorescent, some of the light energy that it absorbs kind of gets stored, and it takes a much longer time to re-emit it. This delay can be from seconds to as long as hours, and it's what causes things to glow after the light source is taken away. However, it's much weaker than fluorescence, and it's usually hard to see if all the lights are on. So, things were actually looking pretty good, and to see if it were phosphorescing, I had to get it as dark as possible. So I turned off all the lights, charged it up for a few seconds, and it actually worked. I mean, it wasn't exactly amazing, and it looked like it was dying pretty quickly, but I was still really happy to see this. Before this, I tried making it a few other ways, and they had all failed miserably, so it was pretty exciting to even have something that barely worked. So this little trial run was successful, but the quality wasn't exactly the best. Before going into this, I knew my results weren't going to be amazing, but this was unacceptably bad. It looked like a lot of the powder barely even glowed, or didn't at all, and the whole thing completely died within about a minute. It wasn't even that the camera wasn't picking it up or something, it was legitimately 100% dead. This one trial run, though, gave me a lot of insight into what I could fix, and I decided to do a second little trial and to change a few things. However, this can be very time consuming, and I decided to go with the much riskier shotgun method where I change multiple variables at the same time. It's riskier because if it works, then I saved a lot of time, but if it doesn't, I have absolutely no idea what happened. The powder before was a bit grainy and chunky, and I felt that this might have contributed to all those dead spots and the general unevenness. So the first thing that I did was throw it all into a small blender, and I let it run for a few minutes. After doing this, the powder was definitely a lot finer, but while I'm editing this now, I noticed that it kind of looks the same on camera. I then started the whole doping process, but I did it on a smaller scale this time, and I used 1 gram of the zinc sulfide instead of 2. I also didn't include any ammonium chloride, even though just before I said that it was important, and I'll explain why in a minute. The rest of the drying part was about the same, and I loaded it all into a clean quartz tube and filled it with nitrogen. A major issue with the other run was the complete inability to heat it evenly. So this time, I put it into this little paint can forge thing that I made for another video when I was refining gold jewelry. This let me use 2 torches at the same time and to heat the tube a lot more evenly. Now, based on what I said before about the ammonium chloride, it would be reasonable to assume that this step wouldn't work without it. However, in that same paper, it said that it was possible for it to still work if there was instead just a bit of zinc oxide present. I hadn't added any zinc oxide, but during this firing step, a small amount of it was definitely being made. I had added nitrogen to get the air out of the tube, but there was for sure still some oxygen in there that was reacting with the zinc sulfide. Also, nitrogen's lighter than air, and it was probably just floating out anyway, and some air was probably getting back in. So it was very possible that the zinc oxide was just being made on its own, and I didn't have to add anything. I really liked this idea of not having to add anything extra, and I was also a bit worried that the ammonium chloride that I used might have not been pure enough. So I figured I'd just try not adding it at all, and if it turned out to be a total failure, that would probably be the reason. I blasted it for 10 minutes like before, let it cool down to room temperature, and then dumped it all out. When I tested it, not only did it actually work, it also looked like it was better than before. So this shotgun method actually seemed to work out, and it didn't end up being a complete waste of time. I then did a side-by-side comparison with the first run, and this one was definitely better. It not only had a much brighter initial glow, it also lasted a lot longer. However, I still felt that it could be better, so I tried one last time to improve it. For this run, I did everything in the exact same way as the second one, except I heated it for just 5 minutes instead of 10. I wanted to try this because I thought that maybe the zinc sulfide was being exposed to a bit too much oxygen. It was good to be reacting some of it, but it was almost definitely bad if I were turning too much of it into the zinc oxide. The result of this was even better than before, and it was both brighter and able to last a lot longer. The camera didn't pick it up very well, but I could see that this one was still clearly glowing after the other two had completely died. At this point, I felt that the result was good enough, so I treated the rest of the zinc sulfide in the exact same way that I did for this third attempt. I was able to fire all of it in just 2 large batches, and once it had cooled to room temperature, I dumped it all into a bottle. After days of work, I was finally done making it, and I had a small amount of surprisingly decent glow powder. It was definitely still not as good as the stuff that you can buy, but honestly, it turned out way better than I expected. Now it was finally time to try and make some glow toys with it. And to do this, I just had to mix this powder into some plastic resin and then pour it into a mold. I still had a bunch of epoxy plastic mix from when I tried to make transparent wood a few years ago, and I figured that was fine to use here. For the mold, I went on Amazon to try and find something interesting. I wasn't initially planning to make dinosaurs to replace the ones that I had lost, but I ended up really liking this one. At first, this was the only one that I was going to get, but then I found this, and I just had to buy it. I don't really know why someone else would want it, but it's apparently used to make small decorations for cakes or something. I personally didn't think that it was the most attractive mold, especially to put on a cake that you were supposed to be eating, but maybe that's just me. But regardless of that, I was kind of excited about it because I could make some creepy glowing babies. Both the molds arrived a few days later, and I was ready to get started. The first thing I did was add 20 mils of part A of the epoxy, along with a random amount of the glow powder. I had no idea how much I actually had to add, but I added almost all of it because I wanted the glow to be as strong as possible. I mixed it all up, and then I ground it until it looked nice and even. After that, I pulled it all out, and I transferred it all to a beaker. I then added 40 mils of the part B of the epoxy, and I mixed it until it started to thicken. I then poured it all into the molds, and I let it sit overnight to completely harden. The next day, I popped them all out of the molds, and they looked like they turned out pretty well. Now to test them and see if they actually worked, I charged them up with my blacklight, and they were definitely glowing. My only issue was that the baby wasn't as creepy as I thought it would be, and it also looked like it had a beard for some reason. But besides that, I was really happy with how everything had turned out. These glow toys seemed to be as good as the ones that I had as a kid, and you could see them pretty clearly in the dark for at least several minutes. However, I should mention that since I was a kid, glow-in-the-dark technology has improved a lot, and there's now something that's much better than zinc sulfide. For a long time, zinc sulfide was the only thing available, but now we have strontium aluminates, which can glow 10 times brighter for 10 times longer. The major downside to them is that they're much more expensive, and as far as I know, I think they're a bit more difficult to make. I do plan to try to make it eventually, but for now, I'm happy with these zinc sulfide based toys, which are kind of crappy, but also very nostalgic. Now, it might not seem like it, but this project was really time consuming, and it took me over a month to put it all together. Normally, I try to post one video per month, but this kind of messed up the schedule, and I ended up completely missing April. What I'm very thankful for, though, is that because this video is sponsored by Brilliant, I didn't have to stress too much about having to post something, and I was able to take all the time that I needed. The last time that I spoke about Brilliant was a few months ago, and since then, I've been using it pretty regularly. Brilliant offers a lot of mini courses in things like physics, chemistry, and logic, and they do it in a way that I think is fun. All their lessons are interactive, but what I like the most is that they're concise and they don't overwhelm you with too much information. The courses are also chopped up into many small sections, so there isn't a huge time commitment. I have a few courses that I'm working on, and I'm still progressing, even when I just go on randomly whenever I get the chance. But with all that being said, I really do like Brilliant, and if you're interested in learning something new, I definitely recommend trying them out. They also have a totally free version that you can use to sample the courses. If you like it, you can then get the premium, which offers a lot more materials and features. Also, if you use my personalized link, brilliant.org/NiallRed, they're offering 20% off on premium for the first 200 signups. But anyway, I hope you guys enjoyed this video, which ended up being way longer than expected, and I'll see you on the next one. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.
Dry, brittle hair? New Pantene Damage Repair formulas are infused with provitamins, argan, and jojoba oils to repair weak inner hair bonds for stronger, healthier hair. Without the $90 price tag, it's intensive care for your hair. Pantene.
This video has been sponsored by Opera. It was almost 2 years ago when I saw this video by Steve Mould, where he showed something that I'd never seen before called the atomic trampoline. He also showed how it worked by just getting a regular ball bearing and by dropping it from about 1.5 feet. And honestly, it was pretty lame. I'm just kidding though, and that was exactly what he expected to happen. And this was because this cylinder was just made of some generic stainless steel. This, on the other hand, was the actual atomic trampoline, and for the most part, it was basically the same thing. However, what made it a lot more interesting was that it had this extra layer of special metal on top, and when he dropped the ball onto it, the difference was almost unbelievable. It just kept on bouncing, almost like it was never going to stop, and it just didn't make sense to me how this kind of generic-looking piece of metal was able to make such a huge difference. Steve quickly cleared up a lot of this confusion, though, by explaining that it was made using a relatively new and unique type of material called amorphous metal or metallic glass, which was very different than normal metal. He then wanted to talk a lot more about it and why it was so bouncy, but the whole time, the only thing that I could think of was that I really wanted to buy one of these atomic trampolines. The only problem was that, according to Steve and hours of my own research, a setup like this was now impossible to buy and Steve was only able to get this one by borrowing it from another channel called Grand Illusions. When I found this out, I was honestly pretty disappointed, and I still don't really know why nobody makes them anymore. What I do know, though, is that not being able to buy one kind of made me want one even more, and at this point, it was pretty clear that there was only going to be one way for me to get an atomic trampoline, and I was going to have to try and make one myself. The only tricky part was that I still didn't entirely know what metallic glass was, and I definitely had absolutely no idea how to make it, but for some reason, I felt that I could do it. I decided to just go for it. So I just jumped right into working on it, and I felt that the best and most important first step was to figure out how a disc of metallic glass is typically made. However, even after hours of searching on Google and reading anything that seemed remotely relevant, I wasn't able to find much of anything. This is because, as far as I could tell, there was basically no information about specifically making a disc, and I was only able to find generic industrial methods that showed how to make things like ribbon. On the bright side, though, all of this research still wasn't a complete waste of time because I was able to find a lot of interesting information about metallic glass in general. For example, there are apparently an insane number of metallic glasses where each of them have completely different compositions, and they all vary in their physical properties like density, elasticity, and hardness. This also meant that they all likely varied in their level of bounciness, and because of this, I almost definitely couldn't just make a disc of it using the easiest recipe that I could find. In my mind, if I wanted it to bounce just as well as it did in the video, I was going to have to make the exact same metallic glass. So I went back to Steve's video, and this time I listened to it much more carefully, and it was around the 7-minute mark that he thankfully said exactly what it was made of, and that it contained
zirconium, beryllium, titanium, copper, and nickel.
With a bit more research, I was then able to find that this composition in particular was called Vitraloy 1, and it was actually one of the first commercially viable and mass-produced metallic glasses. Its exact composition was also conveniently listed on Wikipedia, and it was apparently 41.2% zirconium, 22.5% beryllium, 13.8% titanium, 12.5% copper, and 10% nickel. At this point, I now knew exactly what I had to make, which I felt was some good progress, but what was honestly kind of scaring me was the fact that it contained beryllium. This is because in general, beryllium is known to be toxic and horrible, and when I looked it up, it said that breathing in its dust or fumes could cause permanent scars to develop in the lungs. This in turn could then apparently lead to something called chronic beryllium disease, or berylliosis, which is an incurable and potentially fatal lung disease. It really sounded like it was basically just the asbestos of metals, and what made it even worse was that apparently just one single exposure could potentially lead to berylliosis. Overall, this all honestly sounded pretty terrifying, and at first, it kind of made me want to just abandon the entire project. However, after thinking about it for a while and reading a lot of stuff about beryllium in general, I started thinking that it was actually possible for me to work with it safely, and I would just have to follow two very important rules. Number one, make as little beryllium dust and vapor as possible, and number two, absolutely don't breathe in any of it. In general, rule 2 was actually relatively easy, and all I needed was some good ventilation and maybe a mask, but rule 1 was a bit trickier, and it would severely limit the ways that I could make the disc. This because minimizing dust would mean that I wouldn't be able to shape the metallic glass like normal metal by grinding, cutting, or machining it, and instead, I was going to have to somehow directly make pretty much the exact disc that I wanted. In my mind, this left me with only one real way, which would be to melt all of the ingredients together and to pour them into some sort of mold, and at first, this seemed relatively simple. However, when I looked into things a bit more, I realized that there were a couple small details that were going to make this process way more difficult. The first was that all of the ingredients were sensitive to oxygen, and this meant that I could only melt them with absolutely no air present. Then the second was that to form metallic glass, the molten metal had to be cooled as fast as possible, and this meant that the mold that I used had to have some sort of cooling system. Altogether, this definitely wasn't ideal, but I still felt that it was doable, and at this point, I was fully committed to the project. So I immediately dove right into planning it, and the first thing that I did was reach out to Steve Mold to get the exact dimensions of his disc, and he was nice enough to help me out. I then spent the next few weeks trying to come up with a setup that I thought would work, and my first idea was to do something similar to when I made purple gold. This because to do that, all I needed was a simple furnace with a crucible, and with a small tube shooting in some inert argon gas, I was able to easily protect all of the molten metal from air. I was also able to quickly pour it all out into a graphite mold, and even though it was extremely reactive, it only seemed to get slightly oxidized on the surface. In my mind, this basically solved pretty much my entire problem with air, and I figured that for the cooling part, the only thing that I would have to do differently was pour it into a perfectly sized little disc mold and to quickly cool it using something like a computer heatsink. What was also nice and extremely important was that it was very easy for me to do all of this in one of my fume hoods, which would completely protect me from the scary beryllium. Overall, I really felt that this solved pretty much all of my issues, and I was actually very close to testing it out until I randomly stumbled onto this paper that I'd somehow never seen before, which explicitly talked about making discs of metallic glass. They also included a photo of something that they made, and it was pretty much exactly what I wanted. And what was especially nice was that they explained exactly how they did it. Specifically, they said that all of the ingredients were arc melted together and then suction cast using water-cooled copper molds under a purified argon atmosphere. At first, a lot of these words honestly didn't mean very much to me, but with a bit more searching, I found that at least on a lab scale, this seemed to be a somewhat common way to make metallic glass. It also seemed like the main part of the setup was this thing called an arc melter, and with even more searching on Google, I was able to find a bunch of photos. I then took a closer look at what appeared to be the simplest one, except what kind of concerned me was that I honestly had no idea what I was looking at. After examining it a bit more, though, I realized that it was actually a lot simpler than I thought, and it was basically just a standard welding setup with some extra parts. This was especially highlighted by the fact that it was powered by a common welding power supply, and that the positive output was connected to a standard tungsten welding electrode. There were, of course, some major differences, though, and the first was that the other wire, which is normally attached to the thing that's getting welded, was instead attached to a water-cooled copper crucible. Then on top of this, all of it was enclosed in a glass or metal shell and filled with an inert gas like argon, which would completely protect it from air. With this setup, it was also apparently possible to liquefy almost any metal, and I found this really cool demo of one on YouTube. The moment that it was turned on, it immediately released some blindingly bright light, and this is because a plasma was being generated between the electrode and the copper crucible. This plasma was then so hot that it was able to almost instantly liquefy any metal that it touched, and it honestly kind of blew my mind how fast it was able to melt it. With that being said, though, after seeing this, I almost immediately wanted one, mostly because it looked really cool, but also because it really did seem like an arc melter would be both the easiest and safest way to work with the metallic glass. What I also think made it even more enticing was that with a slightly larger one like this, it was apparently possible to incorporate a custom mold into the water-cooled copper crucible. This would then allow me to directly suction cast the molten metal into the exact disc that I wanted, and at the same time, it would also cool it extremely quickly, which was very important. And at this point, I was pretty much fully committed to getting an arc melter. The only problem was that just by looking at it, I knew that it was going to be expensive, and after talking to someone on Alibaba for over a week, the final quote that I got was $14,000. This was way more than the close to $0 that I would have had to spend on my other setup, and the number honestly kind of shocked me. It was clearly the much better and safer option though, and on top of this, they confirmed that it was no problem to make a disc mold with the exact dimensions that Steve had given me.
Nationwide is so much more than a great insurance company. They're one of America's largest financial services companies. Like how I'm more than just Peyton Manning. I'm also motivating Manning. When I say insurance, you say financial services. Insurance. Financial services. Insurance. Financial services. Now when I say nationwide, you say is both. Nationwide. Nationwide. For your insurance and financial needs, Nationwide is on your side.
Nationwide Investment Services Corporation, member FINRA, Columbus, Ohio.
So I decided to just go for it, and after a few months of patiently waiting, I eventually received this large wooden box. I then spent the next 15 minutes taking everything apart, and I got rid of all the packaging, and I was very happy to see that I now had everything that I needed. More specifically, I had the power supply, a water chiller, and a vacuum pump, and of course, the space-age looking arc melter. Now, all I had to do was put it all together by first plugging in the wires from the electrode and the crucible to the power supply, then by connecting the chiller to all of the blue water lines, and lastly, by attaching the vacuum pump to this little pipe sticking out on the side. I also went and got my argon tank and I attached it to this part at the top, and when I was done, I felt that it was looking pretty good. I then opened it up to check out the copper crucible, and I was really happy to see that it was exactly what I had asked for. In the middle, there was the custom mold, which I will talk more about later, and around it, there were 4 small rounded wells, which I could use to melt metal. There were also 2 custom ones with an exact diameter of 44 millimeters, and I had made these just in case the mold somehow totally failed. This way, I would at least have something to potentially fall back on, and like the mold, I'll talk more about them later on. Either way, with it all assembled, it was finally time to test it out, and I was pretty excited. I was also kind of tempted to just immediately try making some metallic glass, but at the same time, I knew that it was an absolutely horrible idea to do my first attempt with beryllium. I mean, it definitely made a lot more sense to first actually learn how to use it before working with something dangerous. So instead, I decided to start out with some iron, which I felt would be similar to the metallic glass because it would also have a high melting point, and when it was molten, it would be sensitive to air. I also just happened to have all of this high purity iron, which was perfect for this, and I loaded up one of the small wells. I then lowered down the main chamber and I clamped it shut, and I turned on the vacuum pump to pull out all of the air. To monitor this, I just looked at the pressure gauge, and when I eventually saw that it stopped going down, I closed the vacuum and I opened the valve to the argon. This caused the argon gas to rush in and for the pressure to increase again, and when it eventually got back to around 0, I turned off the gas and I flipped back on the vacuum. I then repeated this exact same process 3 more times, and when I was done, I closed both the vacuum and the argon valve. All of these cyclings should have then left me with a chamber that had effectively no oxygen or moisture in it and only inert argon, and I was nearly ready to start blasting the iron. The only thing left to do was to flip on the power supply and to quickly do a horrible job setting up a camera to look inside, and at this point, I just had to click the pedal on the floor to make it go. So I quickly lined up the electrode above the iron, and I was honestly a bit nervous, but I just went ahead and clicked it, and the whole thing immediately lit up. Within a fraction of a second, the argon between the electrode and the crucible had been turned into a plasma, and I don't know why I was so surprised that it was working.
It's working!
The only problem was that it seemed to be struggling to melt the iron, and this was because the power supply was still at its lowest setting. I started it like this because I wanted to start safe, but clearly it needed more power to generate a hotter plasma, and I quickly ramped it up. As I did this, it immediately got a lot brighter, and not long after, there was thankfully some molten iron. This was actually really impressive, considering that iron melts at around 1500 C or 2800 Fahrenheit, and to do this in seconds was kind of insane. What I thought was even more impressive, though, was that in less than a minute later, it had completely liquefied, and I had an absolutely ripping hot blob of iron. It also didn't seem to have any oxides forming, which told me that the inert atmosphere was working, and overall, I was very happy with my purchase. I mean, it really was just as cool as I had imagined, and even if I completely failed to make the metallic glass, I had absolutely no regrets.
Okay, that's really cool.
But with that being said, the iron wasn't going to get any more liquidy, so I stopped blasting it and I let it cool down. Then, several minutes later, when I felt that it was ready, I popped open the chamber and I saw my beautiful little blob of iron metal. I was also really happy to see that it didn't look like it got oxidized at all, but it was surrounded by a bunch of black junk, which I think is just carbon. I then took a closer look at it, and when I flipped it over, I noticed that the bottom side wasn't properly melted. I really thought that I had avoided this by absolutely blasting it, but clearly the cold copper really did its job, and the stuff at the bottom would probably always struggle to melt. But moving on, the machine clearly worked, and now the only other thing that I had to do before working with the scary beryllium was test the mold. Up until now, I also never explained how this mold even worked, but thankfully, it was supposed to be pretty simple. The basic idea was that the mold itself was made from two separate pieces that were just sitting snugly in the crucible, and between these two pieces, there was a cavity in the shape of a disc, which had a diameter of exactly 44 millimeters and a width of 3.5 millimeters. Then, according to the manual, to fill this with metal, all I had to do was melt some metal on top of the mold, which apparently wouldn't fall through the hole, until I opened the vacuum valve. This was then supposed to pull a vacuum through the hole in the bottom, which would cause the metal on the top to get quickly sucked in, and once it was full, the cold crucible would cause it to almost instantly freeze. After that, I just had to pull the entire mold out of the crucible and open the two halves, and this would leave me with, at least theoretically, a near perfect disc of metal. In my mind, this all seemed relatively simple and straightforward, and to get things going, I just loaded a bunch more iron onto the mold. I then sealed the chamber and cycled it like before, and I blasted it until it was completely molten. Now, to turn this red-hot metal into a hopefully beautiful disc, I apparently just had to quickly open this valve on the side and pull a vacuum. I then expected to see all of the metal to just quickly get sucked into the mold, except, well, absolutely nothing happened. It just sat there with seemingly no intention of going into the hole, even with the vacuum on full blast. I then spent the next several minutes trying a bunch of different things to make it work, like increasing the power and blasting it directly in the center above the hole, but it didn't seem to make a difference. I also tried it again using a lot less iron, and I heated it for a lot longer, which I was hoping would help it melt at the bottom and magically fix everything, except that still totally failed. So using this mold apparently wasn't quite as easy as I assumed, and in a desperate attempt to figure out what was going on, I ended up spending the next few days trying a bunch of random things. I also ended up trying it with lower melting point metals like aluminum and tin to see if that would make a difference. And with those, I was actually able to get some to go into the mold, but the result was always trash. Many more repeated failures then eventually pushed me to the point where I started thinking that there was actually something wrong with the mold. And I was honestly getting pretty close to just giving up.
This is just not the way to do it.
However, I then decided to try it one last time, doing something different, and I'm really glad that I did, because to my surprise, it actually seemed to work. Almost all of the metal was sucked into the mold, and when I popped it out and opened it up, I was shocked to see a nearly perfect disc. Oh my God. It worked! That's perfect. It's actually perfect. It's a nice little disc. Wow. I then attempted it a couple more times, doing the exact same thing to make sure that it wasn't just a fluke, and it worked every time. This, of course, told me that the mold wasn't broken or something, and it was kind of just poorly designed and super finicky. What I mean by this is that for it to work, I found that I had to use a specific amount of metal, heat it for a certain amount of time, and open the vacuum valve at a particular speed. If I didn't do all three of these things properly, it would usually fail, where the metal would either refuse to go in, or only a very small amount would, and in the worst cases, most of it would just get sucked out the bottom of the mold. But with that being said, my mold crisis was now apparently solved, and at this point, I was confident that I could actually do it with beryllium, and it was time to try making some metallic glass. So I went and got all of the metals that I would need for this, which, as I mentioned earlier, was zirconium, beryllium, titanium, copper, and nickel. All of these were also the highest purity that I was able to find, and besides the beryllium, which was the lowest at 99.5% pure, all of the others were at least 99.9. But moving on, with all of these metals in hand, what I had to do next was measure them out and to get the exact amounts that I would need for that Vitroloi 1 recipe. I also decided to start out with the beryllium, which was going to be a bit more difficult because it could only be handled in the fume hood, and when I felt that I was ready, I cracked open the bag. I then made sure to handle it as carefully as possible so that any dust that was let off would be kept at a minimum, and I quickly found a piece that I liked. I then gently placed it on the scale, and the goal here was to try and measure out exactly 1.34 grams. With such large chunks, this wasn't really going to be possible, but eventually I was able to get 1.348 grams, which was close enough, and I sealed it all in a vial. I then spent the next 20 minutes measuring out 5 more vials of the beryllium, which would give me a total of 6 separate attempts at making the metallic glass, and I felt that this would be more than enough. This meant that at this point, I was done picking through all of the dusty beryllium, and what I had to do next was the extremely fun part, where I got to load the masses of these 6 samples into a fresh Excel sheet. From there, I was able to do a bunch of calculations, where the first one was to convert all of the molar percentages in the recipe to mass percentages, and when I was eventually done several minutes later, I had the final amounts of each metal. What was also essential to confirm was that the total mass of each run added up to around 40 grams, which would give me a volume of about 6.6 milliliters. This is because, as I mentioned earlier, the amount of metal was very important, and at least based on the tin, I found that this was the ideal amount. But either way, with these numbers in hand, I ended up spending the next hour measuring out all of the other metals, which was honestly a lot more tedious than I thought. This was mostly just because there was a lot of them, but also because I had to use bolt cutters to carefully shave off small amounts of the pellets to get to the exact measurements. Eventually, though, I was able to finish measuring everything out, where this was what I would be using for run 1, and I thought that it was kind of interesting to see it laid out like this. It was also kind of satisfying to see the other 25 vials that I would be using for the rest of the runs, and at this point, I was almost ready to make some metallic glass. The only other thing that I still had to do was move the entire arc melter to my fume hood, which was honestly kind of a huge pain, and to also add a HEPA filter to this part here, which would trap any beryllium dust or vapor that might get pulled out by the pump. Also, while I was at it, I decided to add a two-way valve to the argon input at the top, which I should have done from the beginning, and I replaced the power supply with one that I had found on Amazon because the original one was kind of a piece of crap. With all of this in place, though, I was finally ready to try making some bouncy metal, and after months of preparation and waiting, I was very excited to say the least.
Does the thought of big roller coasters and bigger hair in Dollywood get your heart beating faster? Or maybe your 10-gallon size travel ambitions have you heading for Texas's Big Bend National Park? Or some small town and small state charm in Little Compton, Rhode Island might be more your speed. For adventures of all sizes, choose Allianz Travel Insurance to protect you, your trip, and your peace of mind.
So I just immediately got started, and the first thing that I had to do was add all of the metals to the copper crucible, which you might have noticed was different than the one before. This is because I'd swapped out the one with the mold for this one that instead had a huge well in the center, and that would actually be able to hold all of the loose metal pellets. To a small well in the back, I also added a bunch of extra titanium pellets, which was very important, and I'll explain why in a bit. With everything loaded up, though, I then closed the chamber and I started clearing it from air, just like I had done many times before, and while I was doing this, I kept the fume hood glass as low as possible. I had also hooked up the vacuum pump to another foot pedal, and I moved the argon valve really close to the opening of the fume hood, which allowed me to do all of this while being completely protected. Right now, this was probably a bit overkill, but it wouldn't be later on, and to prevent any possible screw-ups, I decided to just do it like this every time the chamber had to be cleared. When I was eventually done, though, I was ready to start melting stuff, and I flipped on the new power supply. I then started blasting the titanium at the back, and this wasn't something that I had done before, but with the metallic glass, this was very important. This is because even though the argon that I was using was 99.999% pure, it probably still contained a very small amount of moisture, carbon dioxide, and oxygen, which could all react with my metallic glass and potentially contaminate it. So I was of course going to have to do something to try and get rid of them, and thankfully this was supposed to be easy to do by just melting some titanium, except unfortunately, I was going to have to do this every single time. With that being said, though, I was now finally ready to try combining all of the metals and to melt the scary beryllium, and I would be lying if I said that I wasn't at least a bit nervous. I was also kind of assuming that this whole process would be relatively clean and nice, especially after melting the titanium, but I was almost immediately proven wrong. Right away, there was a bunch of smoke that was being let off, which I thought was interesting, considering that the metals were supposed to be super pure. However, I assumed that it was probably just from some minor impurity, and I was hoping that it wouldn't get too much worse. Except it apparently did. I mean, it really looked like the ball of beryllium had just exploded and released a whole bunch of toxic dust and smoke, and this was definitely something that I did not like. This wasn't too surprising, though, considering that the beryllium was the least pure metal out of them all, and I should say that despite all of this nasty smoke, I still felt that things were going okay. But anyway, what I had now was a really hot and kind of crusty looking blob of potentially metallic glass, and in an ideal world, this melting step would have now been done. Unfortunately, though, the world that we live in is far from ideal, and in this case, there was probably still a bunch of unmelted metal at the bottom, which I was going to have to deal with using this convenient tool that was built into the machine. At least according to the manual, it was supposed to allow me to easily flip over the metal. However, I quickly realized that this was going to be extremely frustrating. After 5 minutes, though, I was eventually able to flip it, and on the bottom, it was possible to see the outline of all the pellets that clearly didn't melt, and I just immediately started blasting it. It then all quickly started melting again and getting much more evenly mixed, and what was nice was that it didn't seem to let off nearly as much smoke. What was less nice, though, was that according to every source that I had read, to get a good uniform mixture of the metals, I was going to have to flip it at least 3 more times. This definitely wasn't ideal, but I also really didn't have a choice, and when I was eventually done, over 20 minutes later, I had a nice blob of red-hot metal. Now, all I had to do was just let it sit there and wait for it to cool down, and for the cold crucible to quickly pull away its heat. At the same time, though, I felt that it was a good idea to watch it very closely and to see exactly how long it took to solidify. This is because in general, when making metallic glass, getting it to freeze as fast as possible was extremely important, and with the Vitraloy 1, this was going to have to happen in less than a few minutes. This way, there wouldn't be enough time for any of the metal atoms to crystallize or to form any ordered structure before solidifying. Instead, at least in theory, they should all get locked in a random and amorphous state, and this is supposed to form a metal with very different properties that's commonly referred to as a metallic glass. With that being said, though, at this point, it looked like it had completely solidified, and considering that it had only taken about a minute, I was relatively confident that this was metallic glass, and that I now had a beautiful blob of bouncy metal. Before drawing any real conclusions, though, I was first going to have to get it out of this beryllium-riddled chamber, and with this setup, it was thankfully pretty easy. All I had to do was lower the glass as low as possible, and to pull out all of the dust by turning on the vacuum pump and trapping it in that little filter. I then refilled it with argon, and I repeated this cycle a few times just to make sure that there was absolutely nothing left. After that, I flipped the two-way valve, which opened it to air and equalized the pressure, and now I was able to safely open it. So I carefully flipped up both of the clamps, and I slowly lifted the chamber to reveal my beautiful chunk of hopefully metallic glass. I then removed it from the crucible using some tongs, and I wiped it down with some wet paper towel to remove any toxic residues, and I took a closer look. What immediately stood out to me, though, and what honestly kind of surprised me, was that at least in this form, it didn't seem like it was anything super special. It really didn't feel any different than normal metal, and I mean, I know that I was holding it with tongs, but still, with a density somewhat similar to pure iron, it kind of just felt like one of those iron blobs that I'd made earlier. I, of course, couldn't just judge it by how it felt, though, and I was going to have to be a bit more scientific, and I was going to have to do an actual test. So I went and got one of my ball bearings, which are normally used to just shoot from a slingshot, and when I dropped it, I was pleasantly surprised by what I saw. I mean, it obviously wasn't even close to as good as what Steve Mold had, but it definitely seemed like it was abnormally bouncy, and I thought that it made a really interesting sound. There was something about it that just sounded springy to me, and I felt that this was a really good sign. To be absolutely sure that this was anything special, though, I of course had to compare it to some regular metal, and I decided to just use one of the blobs of iron. Then all I had to do was drop the ball bearing, and I was honestly a bit worried that it would end up bouncing just as well, and that what I had made was actually trash, except it was almost laughably bad. It wasn't even close to anything that I would say even resembled a bounce, and this told me that I was definitely on the right track. At the same time, I also felt that turning what I had into a proper flat disc and that giving it a solid base to sit on would make it significantly bouncier, and that was of course what I had to try next. Before moving on though, I was first going to have to finish melting the 5 other runs that I had prepared, and I did my best to do this as fast as I could. However, despite this, it was still a very long and tedious process, and what made it even worse was that runs 3 and 6 apparently had beryllium that was even more explodey, and it looked like the beryllium was sprayed everywhere. It also filled the entire chamber with so much smoke that it was almost impossible to see anything, and this was quite unfortunate to say the least. On the bright side though, the other runs seemed to be totally normal and not even make that much smoke, and I also ended up seeing something that I thought was really interesting. More specifically, this was during run 4, when I had accidentally touched it before it had fully solidified, and this caused a small amount of it to get pulled away as a little string of goo. And this wasn't like any other metal I had ever seen. In my opinion, it was a lot more like melted plastic or molten glass, and I felt that this was another really good sign that I had actually made metallic glass. But anyway, when I was eventually done 4 hours later, I had 6 beautiful blobs of metal, and I was feeling pretty hopeful. I also did a quick ball bearing test to confirm that they were all bouncy, and at least from this, they all seemed to be about the same. Okay. The only sad part was that when I weighed them all, the ones that were extra explodey had lost way too much mass, and this told me that most of the beryllium had probably just been sprayed around the chamber, and I wasn't going to be able to use them. However, I didn't think that this was a huge issue, because even without them, I would still have 4 attempts to make the discs, and I felt that this was more than enough. With all that being said though, at this point, it was getting really late and I was completely exhausted, and I decided to come back to it the next day. When I returned in the morning, I was really motivated to get started, and the first thing that I did was swap out the crucible for the one with the mold. I then dropped in some fresh titanium, and onto the mold, I added the metallic glass that I had made in the very first run. After that, I closed everything up, quickly did all of the argon cyclings, and melted the titanium, and I was ready to go. So I just started blasting it using the same technique that I had successfully used on the tin, and when I felt that it was hot enough, I carefully opened the vacuum to the mold. This then caused almost all of the metal to get quickly sucked in, only leaving behind a small bead at the top, and I was genuinely shocked that it had actually worked on my first try. Huh, okay. So apparently, all of my practice had paid off, and now, inside the mold, there should have been a nice and hopefully perfect disc of metallic glass. So the only thing left to do was to get it out, and to do that, I quickly cycled it with the gas, and I flipped open the chamber. Then to release the mold, I added some screws, and with a makeshift piece of metal, I was able to carefully pull out the entire thing. With this in hand, the only thing left to do was open it up, and inside of it, I was expecting to see a nice and beautiful disc, but I was immediately disappointed. This is because what I got instead was an ugly piece of crap that somehow didn't even fill the entire mold, and what bothered me even more was that it seemed like it was pulled in very weirdly, which caused this gap to form in the middle. On top of this, there was a lot of metal that was definitely getting sucked out the bottom, as evidenced by the tail, and what was also really bad was that it looked like even if the button at the top had gone into the mold, it would have only barely been able to fill it. Overall, this was a little sad to say the least, but at the same time, I wasn't too worried because I, of course, still had a few more attempts, and I felt that they would be more than enough to succeed at least once. However, apparently, they were not, and while the next attempt was technically better, the one after that was an absolute disaster where almost all of the metal had gone right through the mold. This left me with only one last try, and at this point, I felt that it was pretty clear that I was going to have to do something different, so I decided to cut off some of the extra stuff from all of the failed attempts, which really did feel like trying to cut glass. Oh. I then combined all of it together, and I was hoping that with all of the extra metal, it would actually fill the mold, except it was the complete opposite, and I was never able to get any to go in. All that I ended up with was this huge and kind of useless chunk that I couldn't cut or break apart because of the beryllium, and at this point, I couldn't help but feel pretty frustrated with how things were going. I mean, it was probably a bit naive to think that it was all just going to magically work, especially because the vitrolloy had completely different properties than the tin, which probably required a different technique, and I had never even worked with it. But still, after all of these failed attempts, I couldn't help but kind of lose any faith that the mold was actually going to work or be remotely reliable, and I really did not have the motivation to spend another entire day measuring out all of the metals and then doing all of the melting and flipping, only for it to just probably fail again. Despite all of this, though, there was still some hope, and I hadn't completely given up yet, because there was still one last thing that I had to try, which was that special 44mm well that I had mentioned earlier. I had made these just in case this exact scenario happened, where the mold completely let me down, and in my mind, they were so simple that there was no way they wouldn't work. However, long story short, it again ended up being a complete disappointment, and this is because it didn't at all spread out into a thin layer like I was hoping it would, and instead it just sat there as a ridiculously thick blob. I then just kind of said screw it, and I decided to keep adding metal until I got a full disc, which ended up taking all of the metal that I had, and when I was eventually done, I was left with this horrifically ugly monstrosity. I mean, on the bright side, unlike all of the other attempts, it was actually a full disc, and there was part of me that wanted to just accept this as my final result and call it a day, but I knew deep down that it was complete trash. There was also no way for me to fix it without a ridiculous amount of grinding or machining, and it was at this point that I basically just gave up. Over the next few weeks, though, I couldn't stop thinking about it, even while I was working on other projects, and inevitably, I ended up with a bunch of ideas that I really wanted to try. For some reason, I was also feeling really confident that I could actually get the mold to work properly and consistently, and I decided to just jump right back into the project, and I started weighing out the metals. This time, though, I was very careful to only choose the beryllium balls and none of the shards, which seemed to be more explodey, and I also weighed out 30% more of everything. This is because I felt that 30% more metal would be the perfect amount, and that it would be just enough to compensate for all the metal that was getting shot out the bottom, while simultaneously not being so much that it would refuse to go into the mold. I'm not sure why, but I was also feeling weirdly optimistic, so I decided to only give myself 4 attempts, and with all of the metals ready, I did all of the same melting and flipping steps. When I was eventually done, I had these 4 beautiful blobs of metallic glass, which pretty much looked exactly the same as the ones from earlier, except they were 30% bigger, and I loaded the first one onto the mold. I then did all of the typical gas cyclings and titanium melting, and after hours of tedious work, it was finally time to see if any of my new ideas were actually good, or if it would all end in another complete failure, and I just started blasting the metal. As usual, this caused it to all quickly melt, and now, the first major thing that I was going to do differently was to just keep blasting it for a ridiculous amount of time. This is because I found out that unlike normal metal, metallic glass is significantly worse at conducting heat, and it was very likely that it just took a lot longer for the entire thing to fully liquefy. So I decided to heat it for no less than a minute at near max power, and when I felt that it looked good, I moved the electrode to the middle, and I continued blasting it there for another 10 seconds. This would just really make sure that it was fully liquid above the hole, and then after that, the only thing left to do was open the vacuum valve. I also had to do this slowly and very carefully, which I felt would help prevent the metal from just blasting through the mold, and almost right away, it all started getting sucked in. Then not long after, it started looking very similar to my other attempts, where there was just a small bead left at the top. The only difference this time was that the bead looked like it was slightly bigger, which kind of implied that it didn't all go in, but at the same time, I did start with a lot more metal, which made it hard to tell. Either way, I then let it cool, cycled the gas, and popped it out, and part of me was mentally preparing for what was probably another miserable failure. However, that absolutely was not the case, and inside of the mold was what looked like a near perfect disc.
Oh my God, it actually worked.
I mean, it still had some issues, but it was way nicer than any other attempt, and I really couldn't have asked for anything better.
Yes. Yes. That is good.
So clearly, getting the optimal amount of metal was very important, and just using a slightly different technique had apparently made a huge difference, and I was both extremely excited and relieved.
The King Living Autumn Sale is on now. Save up to 50% on Australian design award-winning furniture. So why buy ordinary furniture when you can come home to King? Hurry, sale on now.
Where regular brushes miss, Oral-B Electric hits for 100% clean teeth.
Oh, right. Halloween. Almost forgot. Oh, Mommy. Hi there. Ooh. Oh, that's kind of fun.
With that being said, I then went ahead and did the exact same thing for all of the other ones, and a couple of them were still a bit finicky, but in the end, I was actually able to make 3 more discs. Like the first one though, none of them were quite perfect, and they all had some slight defects, and on the surface of them, they all looked like they had some weird ripples. However, from what I could tell, this was extremely minor, and it only seemed to be visible because they were so shiny, and overall, I still felt that they were more than good enough. But moving on, now that I actually had it in disc form, what I of course had to do next was test out my theory from earlier and to see if it was bouncier. So I went and got my stainless steel base, which had been made by my friend Justin, who runs the channel The Thought Emporium, and he was able to machine it to the exact same dimensions as Steve's. I then carefully placed my disc on top of it, and I went and got my ball bearing. And for what felt like the millionth time, I was overcome with disappointment. This is because somehow it seemed to be only barely bouncy, and it was apparently even worse than that huge piece of trash that I had made earlier. At first, this kind of surprised me, and I started thinking that I probably just screwed up measuring or mixing the metals, but at the same time, I knew that something was off because of the sound that it was making. Every time the ball hit it, it was making a clinking sound instead of the bouncy one that I had heard earlier. And in my opinion, this had to be happening because the disc wasn't perfectly flat. This was probably causing it to slightly pivot and to get slammed into the base every time it was hit. And it was very possible that this was absorbing enough energy to completely ruin the bounce. It also thankfully seemed like it was a relatively easy thing to fix, and the obvious answer was to just glue it down. Before I could do that, though, I was first going to have to clean it up a bit by cutting off all of the extra stuff with some bolt cutters and by shaving down the nubs with some wet sandpaper. I also had to very lightly sand down the side that I was going to glue so that it would stick better, and I did make a bit of dust doing this, but it was also completely unavoidable. When I eventually felt that it was looking good, though, I shot a bunch of super glue onto the steel base, and I quickly squished on the disc. I also slid it around to make sure that everything was covered with glue, and I honestly did a pretty horrible job, and the glue is dripping everywhere. However, regardless of that, I still felt that things were going pretty well, and after waiting a day for it to fully cure, I quickly cleaned it up. I then carefully slid some acrylic tubing over it, which I was able to find on eBay, and now it was time to see if the glue had magically fixed everything. So again, I went and got a ball bearing, and I nervously hovered it above the tube, and well, it did somehow magically fix everything. I mean, it definitely seemed like it was bouncing just like in Steve's video, and thankfully, it was no longer making that clinking sound. The new sound that it was making was definitely more bouncy, and it was much louder than I expected, and at this point, I was still genuinely surprised that it was actually working.
It actually works. That is really cool.
It's actually amazing. But with that being said, I was now super happy and relieved that the glue had worked. And at this point, there was only one thing still left to do, and that was to get all of the other discs onto a steel base. So I quickly cleaned them up, just like the first one, and I glued each of them to a fresh steel cylinder that I had made using a service called Proto Labs Network. This gave me a total of 4 nice looking little setups, and with all of the extra stuff that I had to cut off, I was actually able to make a 5th one. I then gave all of them their own tube, and now I was finally able to do what I dreamed of when I started this project, and I tested them all at the same time. This was honestly mostly just for fun, but I was also really curious to see if there would be any difference, and I wasn't surprised to see that there was. I mean, I think the metallic glass itself was mostly fine, and I think the main difference just came down to the quality of the disc surface. For example, the third one had by far the crappiest surface, followed by the fourth, where both of them had little bumps and divots that I was hoping wouldn't be a problem, but they consistently performed the worst. In theory, though, I think that this could all be easily fixed by just grinding and repolishing the surface, but as of right now, I don't really have a way to do that safely. At the same time, I'm also more than happy with numbers 1, 2, and 5, which seem to perform almost just as well as Steve's, and that's more than enough for me. This is because it allows me to keep one for myself, give one to Steve, which I promised I would do in a comment on his video, and to also give one away to you guys. If you want a chance to get it, there are also no real requirements, and you don't need to subscribe or comment or do anything like that. All you need to do is send a nice email to giveaway@nilered.ca, and after a week, I'll have the winner randomly picked. And just as a point of safety, because I don't think I said it in the video, the metallic glass in this disc form is totally safe as long as you don't break it apart or try to sand it or grind it. But with that being said, in the end, this project turned out to be a lot trickier than I thought, especially with the whole mold setup, and I'm glad that it actually worked out. What's also nice is that it gave me a huge interest in metallic glass in general, and I plan to do some more videos on it in the future. For now, though, I think I'm done working with nasty and toxic beryllium, and I'm going to try focusing on some even more dangerous projects, like making nuclear-powered glow toys. Alright, so this idea is something that I've been wanting to do for years, ever since I made regular glow toys, and I think I'm pretty close to being able to do it. There are still just a few things to work out, though, to make sure that it's all done safely, and it may or may not end up being really expensive. So, this is why, as usual, I'm extremely thankful for all of my supporters on Patreon and for my YouTube members for making projects like this possible, and of course, for the sponsor of this video, Opera. I've been using Opera on desktop for a while now, and in my opinion, it's still my favorite browser. This is because it's both really fast and intuitive, and it's loaded with a bunch of extra features, and it also just got new updates to its native browser AI called Aria. One of the biggest updates is that you can now access Aria without even using the sidebar, and it's possible to open it by just hitting Control/ or Command/. Another nice update is that if I then hit Tab, I can enter Page Context Mode, which is a neat tool that uses Aria to extract information and to summarize text on any page. Also, something that I want to add is that it's totally optional whether or not you use Aria, and it would only be activated if you choose to turn it on. Besides Aria, though, they have loads of other features, like their tab islands, which has really helped me get all of my tabs under control, especially when I'm doing research for a project. What's also super convenient is that they even have a free built-in VPN service and ad blocker, as well as this sidebar, which I think is really useful. This is because it lets me easily access all of the social media that I often use, like Messenger, WhatsApp, Instagram, and TikTok, and it even has an integrated music app where I can listen to things like Spotify or Apple Music. On top of all of this, they also have something called Lucid Mode, which I think is pretty cool, because with just a click of a button, it's possible to immediately enhance any video. With that being said, though, I've been having a really nice time just using Opera in general, and I still think that it's worth giving it a try for just the sidebar alone. It's also, of course, completely free to use, and you can download it right now by clicking the link in the description. That's it. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.
Introducing the new Jeep Grand Wagoneer with room for the whole family.
And room to make a family. That's right. This baby was named the best car to have sex in by a real website.
Beautiful.
Disney Zootopia 2 in theaters November 26th.
This video has been sponsored by Nebula. Over the years, I've made a lot of videos where I turn completely inedible things into food, and some of my favorite transformations have been things like turning plastic gloves into hot sauce and paint thinner into cherry soda. Something that I've been always wanting to do, though, is to try and turn styrofoam into cinnamon candy, and just like all of my other transformations, this might not immediately make sense. However, at least in theory, it should be possible, and this is because styrofoam is made from a plastic known as polystyrene, which in turn is built from a bunch of smaller molecules known just as styrene. On its own, styrene is kind of an interesting chemical, but what I think is more interesting is that it looks surprisingly similar to this, which is the naturally occurring chemical that gives cinnamon its smell and flavor. The only difference is that the cinnamon flavor, known as cinnamaldehyde, has this small little part at the top, but other than that, it's pretty much the same, and it's really weird that such a small change can make it go from being a potential carcinogen to tasting like cinnamon. But either way, the moment that I saw this, I felt that it had to be possible to turn one into the other, and the plan that I came up with in my head was relatively simple. All I had to do was get some styrofoam and somehow break it down back into styrene, use some chemistry to turn it into cinnamon flavor, and then use that to make some hopefully tasty cinnamon candy. The only unfortunate part was that doing this in real life was going to be a lot more difficult, and I wasn't even sure if it would work, but as usual, I figured there was only one way to find out. But anyway, to get started, the first thing that I was going to need was some styrofoam, and just by chance, when I was cleaning things up earlier in the week, I had found this entire bag of cups. I actually have no idea where I got them from or why I even had them, but I definitely wasn't using them for anything else, and I felt that they were kind of perfect for this project. So I decided to just go ahead and use them, and the first thing that I was going to have to do was get all the air out of them. This is because styrofoam in general is actually mostly air, and even though this cup looked and felt solid, it was at least around 95% empty space. All of this empty space actually makes it a pretty good insulator, and it makes it work really well to keep things hot or cold, but in my case, this extra volume was a problem. So I was going to have to get rid of it, which was thankfully pretty easy, and all I had to do was get this large dish, and then add a bunch of acetone nail polish remover. I put it on the cup and I carefully lowered it in, and almost immediately, I could see that it was releasing a bunch of air bubbles. It was also making a really nice fizzing noise, which I thought was kind of satisfying, and as I kept pushing on it, it was slowly getting eaten by the acetone. Then, over the next 15 seconds, the entire cup gradually disappeared, and eventually, I was left with this little puddle of goo. At this point, what I had was also clearly nothing like the styrofoam that I'd started with, but what I think is interesting is that no reaction had actually taken place. It was still exactly the same thing as styrofoam, which is made from a plastic called polystyrene, and the only difference is that it was no longer pumped up with air. This is because the acetone is able to partially dissolve the polystyrene, which softens it, and it allows all of the air to escape. This then left me with a bunch of plastic that was taking up at least 95% less space, and what I had to do next was just add the rest of the cups. So I continued adding them one by one, but I quickly realized that doing it like this was going to take a really long time, and I instead started throwing in a bunch at once. What was nice was that they still seemed to melt away just as quickly as the single cup, and again, I couldn't help but find this process oddly satisfying. However, something that I should mention is that even though there was no reaction going on here, this was still letting off a bunch of acetone vapor, and having an open solvent like this is a big fire hazard. On top of that, the goo itself is absolutely horrible when it lights on fire because it'll stick to everything, and something very similar to this is used to make modern day napalm. But with that being said, when the last cups eventually disappeared, I was left with this huge blob of polystyrene, which, as I just mentioned, was super flammable and really sticky. However, this was just because it was completely soaked with acetone, and to turn it into something that I could actually work with, I was going to have to dry it out. So I quickly poured off as much of the acetone as I could, and then I dumped out all of this goo onto a large baking tray. I also did my best to spread it out as evenly as possible, and again, I feel like it's important to mention that this was kind of a huge fire hazard. But either way, all I had to do now was just let it sit there and wait for the acetone to evaporate, and after a few days, this was what I was left with. On the outside, it looked like it was nice and dry, but what was kind of annoying was that on the inside, it was still pretty soft and gooey. This told me that if I ever wanted it to fully dry, I was going to have to start breaking it apart, and this was thankfully pretty easy. It also had a really interesting texture, and in my opinion, it kind of felt like pulling apart a fresh quesadilla. When I eventually felt that I'd split it apart enough, I let it dry for a few hours, and then I came back to it and split it apart again. I then repeated this process a few more times and left it overnight to fully dry, and in the morning, I was left with some nice and dry chunks of polystyrene. The only problem was that they were still way too big, and what I really wanted was some nice powder, so I just dumped them all into a blender. I then turned it on to the max setting, and they all immediately started getting torn apart. It was also kind of working even better than I thought it would, and after just a couple of minutes, it already looked like it was a decent powder. The only part that I really didn't like was that I started seeing some acetone vapor condensing on the sides of the blender. I really thought that all of the acetone was gone, but clearly there was still some left over, and this was both annoying and potentially really dangerous. This is because if there was enough left, it could cause it all to gum up again, and in theory, it could also ignite and potentially cause the blender to explode. So I made the decision to pretty much immediately stop it, and what I had to do next was take a closer look at it. I had to be sure that stopping it early didn't leave a bunch of huge chunks in it, and it was actually way better than I expected. It was also pretty much exactly what I was hoping for, and it was just a nice pile of powdered polystyrene, and it definitely took up way less volume than all of the cups that I started with. Most importantly, though, it was now in a form that was actually usable, and after over a week of waiting, it was finally time to try and turn this plastic into some hopefully amazing cinnamon flavor. So I decided to just immediately start, and the first thing that I was going to have to do was break down all of this polystyrene back into just styrene. Based on a little research, this also didn't seem too difficult, and I was able to find a few people on YouTube who had already done it, and I even found this really useful article that outlined the process in detail. This article also suggested using a catalyst called magnesium oxide, which I thought was kind of interesting, and I really wanted to try it out. So I decided to just go for it, and the first step was to get a flask and to carefully pour in all of my crispy polystyrene powder. Then on top of this, I added 65 grams of magnesium oxide, which, as I said before, was supposed to act as a catalyst. Theoretically, it probably would have been a good idea to mix it in, but I didn't really think that it was necessary, and honestly, I was feeling a bit lazy. So instead, I just quickly cleaned up the flask and got rid of any loose powder, and I started putting together the rest of the setup. To do this, I first added a short path condenser to the middle neck, and I sealed the other two with some stoppers because I wasn't going to need them. Then, at the other end of the condenser, I attached a vacuum adapter and a flask, and with all of this in place, the setup was very close to being done. The only other thing that I had to do was put a heating mantle under the reaction flask and to attach some water lines to the condenser, and at this point, it was good to go. So when I felt that I was ready, I just cranked up the heating, and I waited for it to get nice and hot. For a while, though, it really didn't seem like very much was happening, and over the next 15 minutes, all it did was just shrink a bit. When I saw this, I started getting slightly worried that I potentially ruined things by not properly mixing the catalyst, but then almost right at that moment, I was greeted with a nice little puff of smoke. This was then followed by a lot more smoke, which started filling the entire setup, and I felt that this was a good sign. This because it showed me that something was for sure happening, and the polystyrene was clearly starting to break down. As far as I know, this was mostly happening just because of the heat alone, which was causing the long polymer chains of the plastic to slowly split apart. At the same time, though, all of the magnesium oxide catalyst was supposed to be helping with this process and making it go a lot faster. The only unfortunate part was that right now, it didn't seem like any of this smoke was actually styrene, and I think it was mostly just smaller fragments of the polystyrene. To fully break it apart and to get single molecules of styrene, I was going to have to keep heating it and to let it cook a bit more. So I just kept going, and as it slowly got closer to 400 Celsius, or 752 Fahrenheit, it actually started making some liquid, which was really nice to see. This is because, in theory, this was supposed to be mostly styrene, and now I basically just had to wait. So I just let it sit there, and over the next few hours, I slowly collected some murky yellow liquid. Eventually, though, it completely stopped coming over, and when I looked over at the other flask, I saw that there was pretty much nothing left. It was now just a bunch of black crust, which was probably mostly the catalyst, along with a small amount of tar. This was a very good sign that pretty much all of it had been converted, and at this point, the reaction was definitely done. So I turned off all the heating and I went back over to the other flask that was filled with my beautiful yellow liquid. As I mentioned before, this was supposed to be mostly styrene, and I was pretty happy with how much I got, but considering that pure styrene is clear and colorless, this was obviously full of a bunch of other trash. I was definitely going to have to clean it up a bit, and to get started with this, I quickly poured it all into a separatory funnel. This then caused it to separate into two layers, where the bottom one, as far as I know, was mostly just water, and I'm not entirely sure where it came from. It really didn't matter though, because it was all just trash, and to get rid of it, I just quickly drained it away. This left me with some yellow liquid, which was still pretty much just as dirty as it was before, and to continue cleaning it, I poured it all into a beaker. Then into this, I started adding a bunch of white powder called sodium sulfate, and I was hoping that it would pull out any water that might have still been there. I was also hoping that this would get rid of all of the cloudiness, and when I came back to it about 20 minutes later, it was nice and crystal clear, which I was really happy to see. The only unfortunate part was that the sodium sulfate hadn't just magically taken away the yellow color, and there was obviously still a bunch of garbage in here. So I was still going to have to clean it up a bit more, and to do this, I started by pouring it into a funnel that had some cotton at the bottom. This would block out any sodium sulfate that I might have accidentally transferred over, and everything was getting filtered directly into a fresh round bottom flask. Then, when it all eventually passed through, I got rid of the funnel, and I quickly put together pretty much the exact same setup as before. The only difference this time was that I included a thermometer, which in this case was extremely important. With everything in place, I then cranked up the heating, and within just several minutes, it had already started boiling. There was also some vapor that was quickly trickling up the column, and when it eventually made it to the condenser, I started collecting some colorless and crystal clear drops of liquid. This was really good to see because it showed me that the distillation was definitely getting rid of that nasty yellow stuff, except for what was sad is that this wasn't actually styrene. It was just some random side product, and I knew this because the temperature on the thermometer was only around 40 C, and this told me that the vapor that was coming over was only barely warm. It wasn't even close to being hot enough for the styrene, which would be well over 100 C, and I was just going to have to wait for the temperature to slowly rise. So I just sat there watching it gradually collect more and more clear liquid, and when it eventually got to around 100 C, it started to look a bit milky. It was also around this point that I started getting more and more nervous that the temperature just wouldn't stop increasing, and that somehow there wasn't actually any styrene here. I probably worry like this during most of my distillations. However, eventually, it thankfully ended up stopping at exactly 142 C, or 288 Fahrenheit, which was extremely close to the boiling point of styrene. This told me that now, everything that was coming over was probably some nearly pure styrene, so I quickly got rid of this flask that was filled with junk, and I swapped it out for a fresh one. At the bottom of this flask, I also included a very small amount of something called 4-tert-butyl catechol, which would help stabilize the styrene and prevent it from spontaneously turning back into polystyrene. But anyway, at this point, I just had to do a bit more waiting, and over the next 30 minutes, all of the styrene slowly distilled over. During this time, I also carefully watched the temperature, and when it started to rise again, I knew that the distillation was done. So I turned off the heating and I carefully removed the flask, and what I had now was just a bunch of nice and clear liquid, and it was kind of weird to think that this used to be a bunch of styrofoam cups. With that being said though, based on just the smell and the boiling point alone, I was 99.9% sure that this was styrene, but to be 100% sure, I was going to have to do a couple tests. These tests were also relatively quick to do, and I just had to run a small amount of it through these two little instruments that I have, where the first one does something called FTIR, and the second does something called HNMR. I then got these results, which may or may not mean absolutely nothing to you, but together they told me that this was for sure styrene, and that it was relatively pure. So now, knowing this, I was able to move on to the next step, and what I think is interesting is that even though all of this styrene just smelled like plastic and kind of gave me a headache, it was actually pretty close to being cinnamon flavor. In theory, I was really only one step away, and the only thing that I was missing was this small section here. This meant that I was, of course, going to have to somehow add it, and while it didn't look too complicated, it was going to be the most difficult part. With a simple Google search, though, I quickly found this on Wikipedia, which claimed that it was possible using something called the Vilsmeier-Hawk reaction. Finding an actual procedure, unfortunately, wasn't as easy, but after searching for a while, I was thankfully able to find one in this paper, and it was even better than what I was hoping for. So I decided to just go ahead and try it out, and to get started, I went and got a fresh flask, and I added 70 mils of a solvent called dimethylformamide, or DMF for short. Then after that, I added a stir plate and a large dish filled with ice, and I dropped in a stir bar. I also turned on the stirring and added a thermometer, as well as an addition funnel and a stopper. With all of this in place, I then had to wait for the DMF to cool down, and in the meantime, I went and got another chemical called phosphorus oxychloride. This is honestly kind of a horrible chemical, and it's both really corrosive and kind of toxic, but it was exactly what I needed to make my cinnamon flavor, and I added about 37 grams to the addition funnel. I then carefully sealed the top and went to take a look at the thermometer, and it was extremely hard to see, but it showed that the DMF was now less than 10 degrees Celsius. This meant that it was good to go, and when I felt that I was ready, I carefully opened the addition funnel and I unleashed the phosphorus oxychloride. I then did my best to adjust it so that it would get added at a slow but steady rate, and what I had to do now was just closely watch the temperature to make sure that it never went above 20°C. This is because if this happened, the reaction could potentially get out of control, and while it wouldn't just explode or something, it could cause the entire thing to boil over. What I did think was kind of interesting, though, was that it didn't really look like very much was happening, and it almost looked like I was just adding water to more water. However, in theory, the nasty phosphorus oxychloride was supposed to be reacting and combining with the DMF to make a new molecule, which is known as the Vilsmeier reagent. This was supposed to be the main active ingredient in this reaction, and in just a few minutes, it's going to make a lot more sense why I'm making it. With that being said, when it was eventually all added, I got rid of the addition funnel, and what I had to do next was just let it stir for a bit to make sure that it had all reacted.
Vital Farms farmers are up early every day for their hens, but couldn't you just sleep in?
Do you like waiting for your breakfast?
Vital Farms. Good eggs, no shortcuts.
60% of women experience side leaks with bladder protection underwear. Try Always Discreet. Its rapid dry core absorbs up to 25% faster than Depend and fits up to 95% of body shapes. Try Always Discreet, designed to protect.
Being short-staffed, we all have to do a little bit more. That's why we switched to Dawn Professional. Its grease-cutting suds last 2 times longer, so we can wash double the pots in just one sink, which means we can focus more on our famous baked ziti.
Dawn Professional Manual Pot and Pan.
Cologuard colon cancer screening kit. Simple and non-invasive.
Really takes the scare out of screening.
Dear Savvy, who says you can't have it all? You've got the tech, you've got the drive, and now you've got Toyota value. Toyota, let's go places.
While I was waiting, though, it was the perfect time to go and get all of the styrene that I just made and to measure out the amount that I needed. When I was first planning this reaction, I was really tempted to just risk it all and use everything, but at the same time, I knew that was a horrible idea. This is because there have been way too many times where a reaction has just totally failed on me, and considering that I had never done this one before, I didn't really have the confidence. So in the end, I decided to go with only 27.5 mils of the styrene, which was about 1/3 of what I had, and this would give me a couple more attempts if this ended up being a complete failure. With that being said, at this point, the Vilsmeier reagent was definitely ready, and the next step was to slowly add all of the styrene. So I started by pouring in just a small amount, and at first, it really didn't look like much was happening. It really seemed like it was just going to be another step where it would feel like I was just mixing water with water, except eventually it actually started changing color. This told me that there was definitely some sort of reaction going on, and in theory, the styrene should have been attacking the Vilsmeier reagent and forming a bond with it. This would then lead to the formation of this new intermediate, which was basically a combination of both molecules, and now it was starting to look a bit closer to cinnamaldehyde. What I also thought was interesting was that this intermediate technically had a second form that existed at the same time, and this will be important later on. But anyway, what I had to do next was make sure that everything fully reacted here, and to do that, I was gonna have to heat it up. So I just quickly pulled out all of the ice and I replaced it with some water, and I added another thermometer. I then cranked up the heating, and as it warmed up, the color of it gradually shifted to orange, and then to something that kind of looked like some tasty cranberry juice. It was, of course, still just a bunch of toxic and carcinogenic chemicals, though, and despite how good it looked, it would have been an absolutely horrible idea to taste it. But anyway, it eventually got to 55°C, and according to the procedure, this was when it was supposed to suddenly start heating up. It also said that it could potentially heat up so much that it needed to be cooled, but for whatever reason, that didn't seem to happen. It did look like it was slowly getting darker, though, which told me that more of it was definitely reacting. So I gave it about half an hour to make sure that I didn't cause some sort of disaster, and when it seemed safe, I cranked the temperature even higher. It then continued to slowly heat up, and over the next 45 minutes, it got even darker. In fact, by the time that it got to around 75°C, it was nearly black, and at this point, the reaction was probably really close to being done. Just to be absolutely sure that everything had reacted, though, I had to let it sit like this for another hour. When I came back to it, I was kind of surprised to see that it had gotten even darker, and now I was ready to move on to the final step of the reaction. So I just quickly took apart this entire setup and poured everything into a beaker that was surrounded by ice. This is because what I had to do now was pretty much the opposite of the previous step, and I had to cool it as much as possible. I was going to have to get it as close to 0°C as I could, and while I was waiting, I also had to mix together another solution. So I went and got a beaker, and I added 340 mils of water, followed by 133.5 grams of something called anhydrous sodium acetate. I then started mixing it around to get it to dissolve, and after only a few minutes, it had pretty much all disappeared. With this ready, I was able to go back and check on the other stuff, which during this time had partially solidified. When I saw this, I was a bit concerned that this might be an issue, but at the same time, I figured that it was probably fine. It was also around 0°C, which was exactly what I wanted, and I decided to just go with it. So I started by adding a very small amount of the sodium acetate solution, and almost immediately, it thankfully started loosening up. I was very happy to see this, but at the same time, it was also starting to heat up quite a bit, and I had to make sure that it stayed cool. What was supposed to be happening here, though, was pretty exciting, and all of the water that was in the solution I was adding should have been attacking the intermediate from before. More specifically, it should have been attacking this form of the intermediate, causing a portion of it to get kicked off, and leading to the formation of the final cinnamaldehyde. Also, as a side note, all of the sodium acetate that was in the solution I was adding wasn't just doing nothing, and it was there to act as something called a buffer, which would help keep the pH constant, and this was very important for this reaction. When I was eventually done adding it, though, I let it stir for a bit longer, and when it looked like the color stopped changing, I pulled it out of the ice bath. I then carefully placed it into a hot water bath that I preheated to 75°C, because again, I apparently had to heat it up. However, this was thankfully going to be the last time that I had to do this, and it was just to be absolutely sure that it all reacted. This way, I'd be able to get as much of the cinnamaldehyde as possible, assuming that the reaction was actually working. When I came back to it about 15 minutes later, it looked pretty much the same, and the only difference was that it seemed to be a bit clearer. At this point, though, it should have finally been done, and the only thing left to do was to put it in the fridge and to let it cool down. I then left it overnight, and in the morning, when I opened the door, I was hit almost immediately with a really nice smell of cinnamon. At the same time, I was also really excited and kind of surprised by what I saw, because on the surface, there was now what looked like a thick layer of oil. It was very possible that this was almost entirely cinnamaldehyde, and this was a really good sign. The only unfortunate part was that all of this potential cinnamaldehyde looked like it was black, and it was clearly full of a bunch of nasty junk. So even though it was kind of tempting, tasting it like this would have been an absolutely horrible idea, and I was definitely going to have to clean it up. On the bright side, this was supposed to be a relatively straightforward process, and the first step was to pour it all into a separatory funnel. On top of this, I then dumped in 100 mils of a solvent called diethyl ether, which was immediately able to mix with the oily layer on top. I then sealed it with a stopper and carefully took it off the stand, and I started shaking it around. I was doing this to try and force the diethyl ether and the water to mix, which should help the ether pull out any cinnamaldehyde that might have been stuck in the water. When I eventually felt that I'd shaken it enough, I'd put it back on the stand, and over the next few minutes, it separated into 2 layers again. This time, though, the bottom water layer was a lot clearer, which was good, and it told me that the ether had probably pulled out some cinnamaldehyde. With this in mind, I then carefully drained away all of this red water, and I took the ether oil mixture that was left in the funnel, and I poured it into a beaker. Then after that, I put all of the water back into the separatory funnel, and I added some ether, and I repeated the exact same extraction process 4 more times. I was doing this just to make sure that I got out absolutely everything, and when I was done, I was left with a beaker full of nice red liquid. Most of this was just all the ether that I had added, and only a small amount was the oil that I actually wanted, but what was important was that it was already a lot cleaner than what I had started with. The only unfortunate part was that there was for sure still a bunch of trash in it that I was going to have to get rid of, and to get started with this, I had to pour it all back into a separatory funnel. I then dumped in 100 mils of regular water, which almost immediately turned yellow, and this told me that it was definitely pulling out a bunch of crap. In particular, though, I was really hoping that it was removing any DMF, which was in the original reaction mixture, and that was for sure picked up by the ether. I also wanted to be absolutely certain that all of this DMF was gone before moving on, and the easiest way to do this was to just wash it with a huge amount of water. So I decided to repeat this same washing 5 more times, which should have been more than enough, and by the end, the water was almost colorless. This meant that it probably wasn't pulling out much of anything anymore, and I quickly drained away all of the water. I then took all of my slightly less red liquid and I transferred it all to a flask, and I set it up for a distillation. I then cranked up the heating, and I was doing this to get rid of all of the ether, and only a few minutes later, it was already boiling. After that, it only took about 30 seconds to start collecting some crystal clear ether in the beaker, and now I just had to wait for it all to pass over. This wasn't going to take very long though, and only about 20 minutes later, it was pretty much done. What was left in the flask was now a super dark and goopy liquid, and again, it didn't really seem like it, but this was theoretically cleaner than the oil I started with. To get pure cinnamaldehyde though, there was just a bit more cleaning to do, and I felt that the easiest way to do this was to just do another distillation. So I just carefully transferred all of it to a much smaller flask, and I quickly put together pretty much the same setup. The only slight difference this time was that instead of collecting everything in a beaker or a single flask, I was going to have to use 3 flasks, and I also had to attach a vacuum line. All of this extra stuff kind of made it look a lot more complicated, but it was still more or less the same thing, and it'll all make sense in a bit. In any case, when I felt that I was ready, I turned on my vacuum pump, and I carefully pulled all of the air out of the setup. I also cranked up the heating, and only a few minutes later, I saw that it was already starting to boil. The vapor was also starting to climb out of the flask, and it wasn't long before I started collecting a nice and colorless liquid. This was very exciting, and I was very happy to see that it wasn't a nasty red color, except just like last time, I knew for sure that it was unfortunately just trash. This is because when I looked at the thermometer, I saw that it was only around 30 C, which was still way too low for it to be cinnamaldehyde. The temperature was continuously rising though, which was good, and I just had to patiently wait until it got to the boiling point of cinnamaldehyde. The only tricky part was that because this was all being done under a vacuum, the boiling point of cinnamaldehyde was going to be much lower than its normal temperature of 248 C or 478 Fahrenheit. Instead, it was probably going to be around 100 C or 212 Fahrenheit, which was a value that I got using this online calculator, but it was very hard or even impossible to perfectly predict. This made me a bit worried that I would have trouble differentiating it from the junk that I had to separate it from, but there really wasn't too much that I could do about this. It was also absolutely not an option to do it without a vacuum and in the presence of air, because this would cause a lot of the cinnamaldehyde to just get oxidized and destroyed. So all I could do was just continue patiently waiting and watching the temperature and to hope that it magically stopped at 100 C. However, long story short, that didn't happen, and it ended up going right past it and stopping at 125 C, which was a lot higher than I expected. As I just mentioned though, the boiling point under a vacuum is always hard to predict, and it was very possible that cinnamaldehyde was now coming over. What also made me think this was that when I looked at it much closer, it seemed to be faintly yellow, just like pure cinnamaldehyde, and I decided to just commit to it. So I carefully twisted the end of the setup, which allowed me to swap the flask without releasing the vacuum, and now I was fully separating this fraction. I then continued collecting this yellow oil and carefully watching the temperature, and over the next hour, the flask slowly filled up. At some point though, the temperature suddenly dropped, which told me that some higher boiling point stuff was going to start coming over, and when I looked back at the original flask, it looked like all that was left was some red junk. At this point, the distillation was done, and I was almost certain that what I had now was some nice and relatively clean cinnamaldehyde. The only part that kind of concerned me was that it was definitely way more yellow than pure cinnamaldehyde should be, and the idea of tasting it like this was honestly making me uncomfortable. So just to be safe and to put my mind at ease, I was unfortunately going to have to clean it up a bit more, and to do this, I quickly put together this fresh and clean distillation setup. I then cranked up the heating, and it really wasn't long before some drops started coming over, and this time, I decided to collect a decent amount before swapping the flasks. This would just really make sure that I got rid of any impurities, and when I felt that I'd sacrificed enough, I switched it to the second one. What I was collecting now should have been extremely pure cinnamaldehyde, and what was very nice to see was that it was definitely a lot less yellow. I then just kept going and waiting for the temperature to suddenly drop, and when I saw this happen, I quickly switched it to the third flask. I also turned off the heating as well as the vacuum pump, and at this point, I was finally done. After weeks of work, I now had the beautiful pale yellow oil that I was hoping for, and I carefully started transferring it all to a vial. As I did this, I was also hit almost immediately with the super nice and sweet smell of cinnamon, and by now, I was pretty much 100% sure that this was pure cinnamaldehyde. However, if I was gonna taste it, I was of course gonna have to be absolutely sure, so I went ahead and ran some tests on it. Like the styrene, I did both an FTIR and an HNMR, and this was what they gave me. Again, it might not mean anything, but together they showed me that this was for sure cinnamaldehyde and that it was quite pure. And I was very happy to see this.
Vital Farms farmers give their hens a lot of attention. Is it really necessary to give them that much?
Nope.
Vital Farms. Good eggs, no shortcuts.
With bugs, the struggle is real. That's why you need Zevo traps. Zevo works 24/7 to lure, catch, and kill 99.9% of bugs trapped for effortless protection. Zevo, people friendly, bug deadly.
Hey, Chicago, you work hard. So how about a bank that lets you know when you can afford to play? Let's get more for money. Huntington Bank.
How long will this take? I'm kind of in a rush.
Just 10 minutes.
10 minutes?
Just 10 minutes.
Get out.
You're home for the holidays, back in your old room. Oh, at least you can get a deal on your shorts for dad. Something with a little more coverage.
This is because now, after all of this work, I could finally taste it, and I wouldn't have to worry too much about it instantly killing me. I should say, though, that there was still a chance that it contained something horrible that didn't show up on the NMR, and in general, it's not a good idea to taste any homemade chemicals. But either way, I just pulled out a small amount of it, and I sucked it into my mouth.
Whoa. Okay. Definitely cinnamon, but it kind of tastes good. It doesn't burn nearly as much as I thought pure cinnamon oil would. And it's also kind of sweet. Every other flavor I've had just tastes horrible or weirdly enough burns my mouth, even when it's supposed to just taste like grape or something. But this is supposed to burn, and it doesn't even burn that much. It's kind of interesting.
Okay, so I for sure had some nice and tasty cinnamon oil, but more importantly, it was now finally time to try and make some candy with it. Specifically, though, I really wanted to make little cinnamon hearts, which have always been one of my favorite candies, and I wanted them to look as close as possible to the classic ones that I grew up with. The only tricky part was that I quickly found out that to make them like this, it was a lot harder than I thought, and it was also going to be extremely expensive. However, long story short, I ended up spending an obscene amount of money, and a couple of months later, I was the proud owner of this customized candy making machine. More accurately, though, it was mostly just the rollers that were customized, and there were little hearts carved out into each of them. They were also the exact size and shape that I wanted them to be, and right now it might not be super obvious how this is used to make candy, but it'll make a lot more sense in a few minutes. With that being said, now that I had the machine, I was finally able to get started, and the first step was to get a pot with a thermometer attached to it. Then into this, I poured in half a cup of water, followed by 2 cups of regular table sugar, and a 1/4 cup of corn syrup. This was apparently all that was needed to make hard candy, and from what I could tell, the only difference between most recipes was the proportion of each ingredient. The specific recipe that I was using, though, was from this video made by the channel Flavor Lab, and I just felt that it looked good. But either way, with everything added, I quickly mixed it around, and when I eventually felt that it looked nice and even, I turned on the cooktop and cranked up the heating. I then just had to leave it and wait for it to warm up, and to carefully watch the thermometer. This is because as it got hotter and as the water in it slowly boiled away, the temperature was supposed to slowly increase. According to the Flavor Lab video, this would gradually bring the candy through several stages, where the first one was referred to as softball. What I needed, though, was hard crack, which would occur between 290 and 310 Fahrenheit, and this would give me candy that was hard like a lollipop. So I just let it go, and over the next 20 minutes, the temperature slowly rose, and eventually, it got to the 290 mark. I decided to let it go a bit further, though, until about 300 Fahrenheit, and the moment that I saw this happen, I turned off the heating and got rid of the thermometer. At this point, the base candy should have been ready, and it was time to give it some flavor. So I went and got all of my precious cinnamon oil, and I carefully pulled out 3.7 mils, which ended up being most of it. I then quickly shot it into the still super hot sugar, and I thought that it was kind of interesting to see it just sit on top and basically do nothing. However, this was only because the boiling point of cinnamaldehyde was way higher than 300 Fahrenheit, and with most other flavors, shooting it in like this would probably be a bad idea. Regardless of that, I was now super close to being done, and there was just one last but extremely important ingredient to add. This was, of course, some potentially carcinogenic red dye, which was absolutely essential to make proper cinnamon candy, and I felt that several drops would be enough. I then quickly mixed it around, and in less than a minute, it had a nice red color, but I wanted it to be even stronger, so I dumped in a whole bunch more. After this, I was actually able to get the exact red color that I was looking for, and at this point, things were looking really good. I was starting to feel a little nervous though, because what I had to do next was the actual hard part, and I was kind of worried that I would completely screw it up. However, I chose to instead just not think about it, and I pulled the sugar off the cooktop, and I quickly poured it onto some silicone. I then started moving it around while it was cooling down, and eventually, it was supposed to turn into something that was kind of like bread dough. Long story short, though, that didn't happen, and I did completely screw it up. And instead of getting something that was soft and malleable, I got something that was filled with a bunch of hard chunks. The moment that I saw this, I honestly started to panic, and I really started worrying that I had just lost the majority of my cinnamon oil. Totally failed. It's simple as that. I failed. You know? Pack up our bags. That's it. That's our candy. This is it. That's the cinnamon candy. What made things even worse was that I couldn't find anything about this online or how to fix it, and it really seemed like I was just going to have to restart. At the same time, though, I felt that there had to be a way to remelt it without burning it or completely destroying it, and I figured that it was at least worth a try. I also felt that I had to at least make an attempt to not just lose the majority of my cinnamon oil, and in my mind, the best first step was to very carefully break apart all the sugar. No! This gave me some nice little pieces, which I was able to put all back into the pot, and then I put this back onto the cooktop. On top of this, I also shot in a random amount of water, as well as a completely arbitrary amount of corn syrup, and I cranked up the heating. I then just waited for it to melt, and what I was hoping for here was that all of the extra water would help prevent the sugar from burning, and that the extra corn syrup would make it take longer to harden. The only thing that kind of concerned me was that heating it again would potentially cause it to caramelize, and by the time that it got to 300 Fahrenheit, it was looking a lot frothier than before. It also looked like it was turning brown, which really scared me, but it seemed like it was mostly just because the food coloring was breaking down. So I just blasted in some extra red color and mixed it around, and very quickly all of the froth disappeared, and it actually looked really good. This time though, I wasn't going to let it cool down at all, and I almost immediately pulled it off the cooktop and started pouring it out. Compared to before, it was definitely way more liquidy, which I felt was good, and I did my best to constantly move it around. While I was doing this, I was also still really worried that I would end up just getting a bunch of solid chunks again, but that thankfully didn't happen. Instead, over the next several minutes, it just slowly got thicker, and eventually, I had pretty much exactly what I wanted. It was just a blob of gooey sugar, which felt almost shockingly similar to hot bread dough, and I was happy to see that my recovery attempt had actually worked. There was unfortunately almost no time to celebrate this though, because I still had to turn all of this sugar goo into some nice little cinnamon hearts before it cooled down, and it was time to use my machine. From what I saw online, it also seemed super straightforward, and I basically just had to throw it into the rollers and then squish it. So that was exactly what I did, and for the most part, it seemed to be going pretty well, and I was super happy to see that it was forming some beautiful little hearts. The only weird part was that it was a lot more difficult to turn than I thought, and I think this was because the sugar that I was putting in had cooled down a bit too much. This needs to be like anchored to the ground. I also might have been just going too slow, which was causing it to solidify, and I was only able to squish half of the sugar before it became way too hard. Okay. So I ended up having to basically just give up trying, and it was honestly kind of impressive how badly I had screwed up this entire process. Despite that though, it wasn't like it was just a complete failure, because I was still able to get a bunch of little hearts, and they were actually super nice. To get them apart, I also just had to apply a bit of force, and they all easily crumbled, which I thought was really satisfying. After that, I then spent a couple minutes breaking apart the hearts that were still stuck together, and at this point, I was extremely close to being done. In theory, there was just one last step, which was to coat the candies with more sugar and to give them that classic look that I originally wanted. I had actually even bought an entire machine to help me do this, but after seeing how nice they were without a coating, I decided to keep them this way. There was just something that I really liked about them like this, and now, after months of working on this project, I was finally done.
Finally done. And I think there's only one thing left to do. After all this work, I can see, was it all worth it for this? We'll see. Okay. It tastes, I mean, I don't know why I'm surprised. It tastes exactly like cinnamon candy. It's really good. And that's pretty much the exact flavor that I wanted. It's not too much cinnamon, not too little. It's a very nice, mild cinnamon candy. The only thing that I think is that kind of threw me off, normally they just crunch. But this one, it's a bit more chewy. It's kind of like I just made cinnamon heart Jolly Ranchers, basically. Oh, that one was crunchy for some reason. And more cinnamony. Okay, I clearly need to refine my candy skills. But overall, I'm honestly kind of amazed at how well they turned out.
Okay, so in the end, and despite an almost impressive lack of candy making skill, I think I can still call this project a success. I mean, I was actually able to turn a bunch of old styrofoam cups into some nice little cinnamon candies, and even though they weren't exactly perfect, I'm still really happy with them. What will also be fun is that in the future, I do plan to revisit this whole candy making process, and I have at least a few projects that I think are going to be really interesting. However, in the meantime, I'll be taking a little break from candy, and I'm going to be focusing on some more dangerous projects, like turning air into a bomb. This is actually a video that I was probably never going to make because I know that YouTube would definitely not like it, but I'm happy to say that it's now possible thanks to Nebula, who's also the sponsor of this video. For anyone who hasn't already heard of Nebula, it's a creator-owned and operated video streaming service with content from hundreds of creators like The Thought Emporium, Tierzoo, and Real Engineering. It also has a huge catalog of Nebula originals, which includes shows, films, and documentaries, as well as exclusive bonus content from many creators, and it's all delivered completely ad-free. Personally, I've been really enjoying the travel series game by Wendover Productions called Jetlag the Game, which features many creators you may know taking part in travel-related challenges all across the world. This show is also funded and produced by Nebula, which I think is really cool, especially because I'm now a part of Nebula myself. As a creator on Nebula, I'll be offering early access to new videos along with all of my older uploads, including Nile Blue, as well as the videos that I've had to remove from YouTube. I will also eventually be making some more videos that I know YouTube won't like the one I mentioned earlier, but now, thanks to Nebula, I'm still excited to make them, even though I know they'll probably get demonetized by YouTube. With all that being said, though, I really think that Nebula is a great platform, especially because of how supportive they are of all of their creators, and I definitely recommend checking them out. You can also do this right now by clicking on my link in the description, go.nebula.tv/NileRed, which will give you 40% off an annual subscription coming out to only $250 a month. And a portion of this will directly support this channel. And that's it. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.
Every bottle of McCormick is flavor sealed. For fresh flavor, everyone notices.
60% of women experience side leaks with bladder protection underwear. Try Always Discreet. Its rapid dry core absorbs up to 25% faster than Depend and fits up to 95% of body shapes. Try Always Discreet, designed to protect.
This video has been sponsored by Raycon. Last year, I started getting really interested in aerogel, which is one of the lightest known materials. There are many different types of aerogel, but the most common one is from silica, and that's what I have here. By volume though, it's actually less than 1% silica, and over 99% of it is just air. This makes it extremely light, and when I'm holding it, I can almost barely tell that it's there. There are many potential uses for silica aerogel, but its simplest and probably most common use is as a thermal insulator. This is because it's mostly made of air, which in general is a good insulator, but the key part is that all this air is trapped in a network of silica. This makes it really hard for the air molecules to move around and for the heat to transfer to the other side. After watching a few videos about it, mostly by Veritasium, I decided that I had to try making it myself. On the surface, the general process was relatively simple, where all I had to do was make an alcohol-based gel and then dry it. However, the issue is that in practice, it's way more difficult, and getting even a decent quality aerogel is really hard. I'd never done anything like this before, but I had faith that I could do it. To start my mission, the first thing that I had to do was make the alcohol-based gel, which I thought was going to be relatively easy. However, that really didn't turn out to be the case. The first problem was that there wasn't just a perfect recipe for the gel, and everyone seemed to have their own slightly different way of making it. I wasn't looking for anything fancy though, and I wanted it to be as easy as possible, and it seemed like a recipe from aerogel.org fit that perfectly. The first chemical that I needed for it was the hardest to get, and it was something called tetramethyl orthosilicate, or TMOS for short. This is basically a liquid source of silica, and because of that, it's also really dangerous. My favorite thing about it is that it reacts with water and turns back into silica, and it can do this in both your lungs and your eyes. The best part too is that the particles form in the eyes under the surface, and they're way too small to remove, so it can lead to permanent blindness. For this reason, when I was going to be working with it, I'd have to be very careful and to only use it under a fume hood. This small bottle of it cost me about $100, and I ordered it from a chemical company. Now, the other things that I needed were methanol and concentrated ammonia. For the methanol, I just bought it from a local hardware store, and I got the ammonia online. With all the ingredients, I was now ready to get started, and the first thing that I had to do was make some dilute ammonia. The stuff that I had here was concentrated, so it was around 28 to 30%, but I needed it to be closer to around 0.1 or 0.2. To do this, I just added 5.4 mils of the concentrated stuff to a bottle and poured in a liter of distilled water. After this, I moved on to making the actual gel solution, and I added 33 mils of methanol to 2 beakers, and then into the one on the left, I also added 16.5 mils of that dilute ammonia that I just made. With this all added, I then busted out the TMOS, and I carefully poured in 33 mils to the one on the right. This gave me my 2 starting solutions, and to make the gel, all I had to do was mix them. So I turned on some strong stirring, dumped one into the other, and let it stir for about 30 seconds. It didn't look like much was happening, but there was a reaction going on, and the TMOS was slowly turning back into silica. At first, the silica formed as an extremely fine suspension of particles that were so small that they weren't even visible. During this phase, which was what I had here, it was still completely liquid. As more of it formed, though, the particles would come together and form a complicated and fragile network of silica. This network would have a lot of extremely small pores in it, and these would trap some of the methanol and water. This would cause the solution to thicken and eventually form a gel, which is a mixture of a solid and a liquid. Before it became a gel, though, I had to pour it into a mold, and I had less than 10 minutes to do this. One of the simplest ways that I saw was by Ben over at Applied Science, and he just cut the top off a syringe. This way, the extremely delicate gel could then be taken out of it by squeezing on the plunger. This all seemed to work okay, but my biggest issue with this method was that the gels were kind of ugly. The major goal of this project was to make aerogel in general, but I also wanted it to be as beautiful as possible. The ones that you can buy are always these nice cubes or well-defined shapes, and I wanted to get as close to that as I could. So I had to somehow come up with a way to do this, and this was the part that made making the gels a lot harder than I initially thought. This is mostly because the final gels are really delicate to the point that I feel like they could break almost just by looking at them. This totally ruled out using any of those soft silicone molds, and it also would just get stuck in any hard mold. So I wasn't able to use any traditional mold for this, and I had to get a bit creative. I spent about a week trying out random things, and eventually I came up with something that worked. It was also really cheap and easy, and what I ended up using was a plastic cookie cutter that I got from Amazon. I think it might have been okay on its own, but to make sure that the gel didn't stick to it, I sprayed it with a bunch of silicone lubricant and wiped it down. After that, I put it onto a piece of glass that I took out of my IKEA display cabinet, and I made a border around it with duct tape. With the tape in place, I took away the cookie cutter, and I used a dollar store cheese grater to shred one whole dollar store candle. I then melted all the wax by blasting it with my heat gun, which is basically an overpowered hair dryer. When it all seemed nice and liquidy, I used a ruler to scrape off the extra stuff, and the goal was to make a layer about the thickness of the tape. This part was always a little bit sloppy, and I usually had to scrape it and remelt it at least a couple times. It didn't have to be perfect though, and all I wanted was for the glass to be covered in a somewhat even layer of wax. When I felt that I had this, I dropped the cookie cutter onto it, and I put a dish on top to help keep it in place. I then shot it again with the heat gun to really make sure that the edges were sealed, and I let it sit there for 30 minutes for all the wax to harden. At this point, it still might not make sense how this was all going to work, but I promise that it will make sense in a few minutes. Also, just to be clear, this was all done well before even starting to make the gel solution, because like I said before, that starts to harden in less than 10 minutes. But now, cutting back to the gel solution that I made, it had only been a couple minutes, and I started filling the mold. I found that the best amount to add was 10.4 mils, and I did this as fast as I could, and then covered the whole thing with a dish. As the reaction continued, it would cause things to slowly heat up, and without a cover, the gels would all dry out and crack. With the dish, though, the methanol vapor was kept inside, and this problem seemed to be avoided. What I had to do now was basically just wait for it all to turn into a gel. This usually took around 10 or 15 minutes, but just by looking at it, it was very hard to tell when it was ready. So I came up with a very scientific method to figure this out, where I would occasionally just punch the table and see how it shook. I also found that it was just good to punch the table in general because even early on, it helped release some bubbles. Eventually, around the 10-minute mark, when I would hit the table, it looked pretty solid. When I saw this, I would usually give it a few more minutes, and then I would take off the dish and add some more methanol. This had to be done quickly though, because a lot of the methanol had vaporized and there wasn't much of it left on the surface. Right now, they were all still way too fragile, and if I tried moving them, they would probably crack and fall apart. So I let them sit there for another 10 minutes, which gave more time for the TMOS to react and for the gels to get stronger. After that, they all looked good to go, so I took away the dish, and now it was time to see why I put this whole weird setup together. I first added some more methanol, and then I carefully pulled on the corner of the mold, and I cracked it away from the wax. I then peeled off the rest of it, and I was able to completely separate it without putting any real strain on the gels. The gels were all still technically in the mold, but there was now no bottom, and I could easily get them out without damaging them. All I had to do was push on them a bit, and they slid out really easily. They were all dropped directly into a bunch of fresh methanol, and I went back to making some more gels. However, this time, I didn't just use the same mold again, and I instead used a hexagon one. To set this up, I started by adding a bit more wax, and then it was pretty much the exact same as before. When this was eventually ready, I whipped up some more gel solution, and again I added it in the same way. The only difference was that this time, the hexagons were slightly smaller, so I added 8.8 mils instead. When these were ready, I cracked them off the wax, and I added them all to the square gels. What I had to do now was let all these gels soak in this methanol for at least a day, and then swap it out for some fresh methanol. With this setup, it was thankfully quite easy, and all I had to do was lift this strainer and drop it into a new dish that I had already filled. I've seen a lot of people do this by individually moving each gel, but I don't think that's the best method. I've mentioned a few times now that they're extremely fragile, and I feel that this would almost definitely damage them. In my opinion, using a strainer here was very important, not only because it made it way easier and I can move them all at once, but it also was a lot nicer on the gels. As the gels sat there, the water that was in them was being taken out and replaced by methanol. The main goal was to replace all the water with methanol, but this process was unfortunately very slow. It would take about a week to be done, where every day or second day, I would lift it out and put it into some new methanol. This part of the process was definitely the most wasteful, and just to make these gels, I had to use about 10 liters of methanol. There wasn't much way around this though, because I had to make sure that there was absolutely no water left. I also do plan to recycle all of it by distilling it, but still, it was a lot of solvent to make such a small amount of gel. After letting them soak for about a day, I took out one of them to have a closer look at it. When I started this project, I was really hoping to make gels that were completely smooth, but the surface of this one was a bit rough looking. This happened because when I was making it, I added the extra methanol a bit too early, and the surface hadn't completely hardened. This was a bit disappointing, but it also didn't matter too much, and it shouldn't be noticeable in the final aerogel. After this, I took a look at the hexagon one, and I thought that it looked pretty good. However, I apparently squeezed a bit too hard on it, and it broke and fell back into the methanol. The whole gel making part was pretty much done, and all I had to do was swap out the methanol a few more times. After this, the next major step was to dry the gels and replace all the methanol with air, but just like everything in this project, it wasn't super straightforward. I wanted to see what would happen if I just tried evaporating the methanol, and I also blew on it a bit to try to speed it up. Within a couple minutes, it had cracked all the way through, and when I tried pushing a bit on it, the whole thing just exploded. The cracking here happened really fast because I was blowing on it, but I wanted to see what would happen if I let it evaporate much slower. So I took another piece, put it into a small dish, and covered the top. Within a few hours, it already started cracking, and then over the next couple days, it cracked even more, and it also shrank a lot. The major reason why this happened was because of something called capillary action. This effect is seen with liquids in narrow tubes, where if the liquid is attracted to the walls of the tube, it will try to climb it. The same thing's occurring with the methanol and the very small pores in the gel. As the methanol evaporates at the surface, the methanol deeper in the gel tries to move up its pores and fill its place. This creates an inward pulling force on the walls of the pores, and it causes a lot of them to contract or even collapse. This also happens at different rates all over the gel, which puts uneven forces on it and causes it to crack and shrink. It was very hard, and it felt like porous and crunchy glass. What I thought was cool, though, was that it still had that slight blue haze that you see with aerogel. Then just for fun, I added some water to it, and it started popping like crazy. After this, I let it dry, and what I was left with looked a lot like glass. However, it wasn't completely solid, and it was still very porous. But anyway, that was kind of a tangent, and the main point is that you can't just dry the gel in a normal way. It has to be done using a specialized method so that it doesn't collapse on itself. There are a couple ways to do this, but I decided to go with the most common way, which is by supercritical drying using CO2. The general idea behind this process was to first replace all the methanol in the gel with liquid CO2. The liquid CO2 is then heated until it goes supercritical, where it's kind of a mixture between a liquid and a gas. Then from there, it can be converted to just plain CO2 gas. By doing this, we're basically turning a liquid into a gas without having to evaporate it. This makes it possible to completely avoid that problem with capillary action, and the gel shouldn't collapse. The methanol here was just being used as an intermediate because the liquid CO2 isn't able to mix with water. It is technically possible, though, to make methanol go supercritical, but it's a lot more dangerous. But with all that being said, to actually do this, I had to put together a specialized supercritical dryer. And like the gel recipe, I also got the information on how to do this from aerogel.org. They have a full guide and a complete parts list, and they also have a lot of very useful information when it comes to making aerogel in general. I decided to deviate a bit from their guide, though, and to build a slightly bigger chamber. The main chamber of their larger version had an inner diameter of 1.5 inches, but I decided to bump it up to 2. Almost all these pieces were pretty specialized, and I couldn't just buy them in any local hardware store. The entire thing also had to be made out of high-pressure stainless steel, which wasn't exactly cheap. And unfortunately, there wasn't much of a way around this because building it with cheaper materials, especially those not rated for high pressures, is a major safety problem. Unsuitable materials have failed and exploded and hurt people in the past, and it's not something to take lightly. But anyway, with that being said, I was able to order all these pieces online from a supplier called McMaster Carr. It all arrived a few days later, and the first thing that I did was take everything out of its packaging and roughly lay it all out. I then had to connect all the pieces, and to do this, I first wrapped all the threads with Teflon tape and then screwed them all together. After this, I attached a connector for a hose to a CO2 tank, and it was almost ready to go. The last parts that I needed were sight windows that would be going on the sides. These were very specialized pieces with glass in them, which could take high temperatures and pressures and let me see what was going on inside the chamber. They weren't mandatory at all, though, but it was going to make the process a lot easier, and I thought that also I might be able to get some cool footage in the chamber. This second reason was actually what mattered to me more, and it was why I built the bigger chamber in the first place. A bigger chamber meant a bigger window, and to me, that probably meant better footage. Each of these windows were unfortunately expensive, and they cost about $400 US. I was lucky, though, because they were in stock, which they often aren't, and they were shipped out right away. They both arrived about a week later, and I was ready to attach them to the chamber. However, to prevent leaks, they first had to be loaded up with a bunch of Teflon tape, and it was recommended on aerogel.org to wrap them 4 or 5 times. After that, I screwed them down as far as I could with my fingers, and then I used a giant socket to crank them down. It was important to use a socket here and not just a regular wrench, because the force around the window had to be applied evenly. A wrench would only have 2 main points of contact on it, and this could cause some twisting strain, which could either crack the glass or just weaken it. I also marked their starting point, so I would know how much I turned them. According to the manufacturer, it was safe to turn these up to 3 times, but I never found that I needed to go more than 1 or 1.5. After both of these were on, the chamber was pretty much done, but there was still one last thing that I needed. For this whole supercritical drying process, I needed liquid CO2, so I had to go pick up a tank of it. To the valve of it, I attached a quick release adapter, tightened it down, and snapped in the high pressure hosing. Now coming back to the pressure chamber, I snapped in the other end of the hose. I then made sure that all the valves on the chamber were closed, and I was now finally ready to test it out. I started by opening the tank, which let out liquid CO2, and it filled the hosing. I then opened the valve on the chamber, and the CO2 started rushing in. The pressure gauge also increased, and I let it max out at around 900 psi before closing it. After this, I shot all the joints with some soapy water to see if there were any leaks. I was hoping that the chamber would just be perfect and it would all magically be fine, but that definitely wasn't the case, and there were bubbles forming everywhere. Like this, it would probably still be safe to make the CO2 go supercritical in it, but it would also all just leak out and be close to useless. So of course I had to fix this, and it was actually pretty easy. All I had to do was use much thicker Teflon tape and tighten things a little bit more. To empty the chamber, I closed the CO2 tank, reopened the main valve, and then slowly turned the one at the bottom. This allowed me to vent all the CO2 that was in the system, and only after this could I safely disconnect the hosing. The tape that I used this time was the much thicker orange one, and I replaced most of the white tape in the whole setup. I then retested all the joints, and this time it was a lot better. There was still a small amount of bubbling in some places, and to fix this, I just tightened it a bit more. After that, I tested its holding power by filling it with a bunch of liquid CO2 and leaving it for a couple days. I marked the height that it started at, and when I came back, it was only a bit lower. There was always going to be some sort of leak in the system, but as long as it maintained most of its level for at least a day, it was more than fine. After this, the chamber was finally ready, and I could do some supercritical drying. The only problem that I still had, though, was that I didn't know how I was going to be loading the gel into it. From all the tutorials and the videos that I saw, I couldn't understand how people were getting the gel inside. We saw before how fragile it was, but it seemed like everyone just threw it in and let it sit at the bottom. In my mind, there was no way that this wouldn't have damaged it. Also, there was the other problem of taking the aerogel out after it was done, which is also super fragile. I spent a long time trying to come up with a solution, and I decided to make a bent version of those things that they use to load pizzas into an oven. To make this, I just took a random piece of metal that I had lying around, and I hammered it into the rough shape that I wanted. I then used an angle grinder to shape it, and I finished it up on a cutting board. This was the final result, but it was honestly way better than I thought it would be. At this point, the chamber and everything about it was finally and totally done, and the gels were done as well. I had finished cycling them all in the methanol, and I was ready to turn them into aerogel. So I started by filling the chamber with 45 mils of methanol, and I pulled out one of the gels. I then carefully lowered it in, and I made sure that there was enough methanol to completely cover it. I wiped down all the threads to get rid of any methanol that might have been there, and I screwed on the window. Like before, I first did this as tight as I could with my fingers, and then I really cranked it down. I then carefully carried the whole thing back to the stand, and I attached the CO2 hosing. I also taped the camera to the window to film inside. When I first tried this, I used a phone because I assumed that a camera wouldn't be able to focus that close. However, the camera and lens that I was using apparently didn't have any problem. I then opened the main tank and I carefully turned the valve so the liquid CO2 would only trickle in. The goal here was to fill it really slowly over the course of about an hour.
Good.
I was hoping that I'd be able to see the gel in the chamber, but it was unfortunately just barely out of view. I kind of expected that though, because the gel was so low down, and the windows were mostly just to help keep track of the liquid CO2. For this whole supercritical drying part, I found it very hard to see a lot of info available, and I was only able to find the one on aerogel that worked was quite good, but I wasn't sure what the quality of the final aerogel. From the photos, it all definitely worked, but they looked like they had a lot of cracks, and I wanted mine to be crack-free. So what I ended up doing was combining their procedure with another one that I found, and I also injected some of my own ideas. One of the biggest factors when it came to making crack-free aerogel seemed to be speed, where slower was almost always better. This was the main reason why I was adding the liquid CO2 over the course of an hour. If I added it too quickly and it mixed too much with the methanol, it could create stresses at the surface of the gel, which could cause it to crack. When it was barely over halfway full, the liquid CO2 usually stopped coming in, and to get more, I had to open this valve on the right. Doing this let some of the CO2 gas out of the chamber and lowered the pressure, and it let more liquid CO2 come in from the tank. I only opened it a very small amount, and when the chamber was eventually full, I closed it again. Then, I let it sit like this for 30 minutes. It can be a bit hard to tell here, but there are two layers where the liquid CO2 is sitting on top of the methanol. To make it more clear, I went ahead and shook it a bit, but this probably wasn't the best for the gel. For the most part, besides when I shook things, these two solvents were completely separated, and they were only slowly mixing together. It wasn't enough for them to just blend together, but a small amount of each of them was dissolving into the other. This meant that the gel was only slowly getting introduced to the CO2, which again was a good thing. When I came back 30 minutes later, they'd clearly mixed quite a bit, and the methanol layer had expanded. It was always kind of hard to tell exactly where the methanol was, but it had clearly shifted up, and the light was getting warped in a different place. They were still mostly separated though, and because methanol was more dense, it was sitting at the bottom. This was convenient because the next step was to drain it, and it meant that all I had to do was open the valve at the bottom of the chamber. This again had to be done really slowly, and the target was to do it in about 2.5 hours. When I stopped seeing methanol dripping out, the CO2 in the chamber was just above the gel, and I closed the valve. When I was done, I checked how much methanol I had, and it was about 40 mils. I started with 45 mils though, so there was still some methanol mixed in with the CO2 in the chamber. Some of the methanol also probably got vaporized as it came out and just went into the air. So for this reason, it was really important to do this in a well-ventilated area to avoid breathing in a bunch of methanol. I refilled it, again slowly, over the course of about 30 minutes, and I brought it up above the window. Then after that, I let it sit overnight, and I waited for the methanol that was still in the gel to slowly get swapped for the CO2. When I came back the next day, it looked pretty much the same, and I opened the valve at the bottom. I collected everything, but this time, it was mostly CO2. I was getting mostly dry ice, which was forming as the liquid CO2 was leaving the valve. Under normal atmospheric pressure, liquid CO2 can't exist, so as it left the chamber, it jumped to being a solid. When I got the level down just above the gel, I refilled it in the exact same way as before and left it overnight. This time, after all the dry ice had disappeared, I had just a couple mils of methanol in the beaker. The basic goal here was to keep repeating this process over and over until I didn't see anything in the beaker, and then to do it one last time. In total, I usually had to do this 3 or 4 times, which meant that I soaked it overnight 3 or 4 times. I started this run on Sunday, and it was only by Thursday that it was ready. After all this, the gel should be filled with only liquid CO2 and no methanol, and definitely no water. I was finally ready to actually supercritically dry it, so I closed all the valves on the chamber and I closed the tank itself. Now, to supercritically dry the gel, the general idea was really simple. Almost all I had to do was heat it up and push the liquid CO2 into the supercritical state. With CO2, this thankfully happened at a low temperature, and it was barely above room temperature at around 31 C. For this part, I used a heat gun, and I carefully blasted the chamber. Almost all of the heat was focused on the largest section, and a small amount was on the small cross. For safety reasons, it was important not to heat any of the valves. The main goal here was to get to 31 C, but as it got hotter, the pressure also increased. I had to make sure that by the time it got to 31 C, that the pressure was just below 1100 psi, but this was a bit tricky. The amount that the pressure increased all depended on how much liquid CO2 I started with. The more CO2 there was, the more the pressure would increase, and it was always slightly different between runs. If it ended up going too high, I would have had to relieve the pressure by opening a valve, but what I started with turned out to be pretty close to perfect. To prevent the gel from cracking, I also first brought it up to 28 C, held it there for 20 minutes, and then brought it up to 31. This whole part took about 45 minutes, and during this time, the surface of the CO2 was constantly changing. The boundary between the liquid CO2 and the gas above it started out as being very evident, but it slowly disappeared. This was because as the temperature and the pressure increased, there was less and less of a difference between the density of the gas and the density of the liquid. The CO2 gas in there was getting denser, and the liquid was expanding and getting less dense. Eventually, at the supercritical point of 31 C, these two phases of CO2 had the same density, and they were able to mix together. This new mixture was supercritical CO2, and it had properties that were a combination of a liquid and a gas. It was able to dissolve stuff like a liquid, but it was also able to diffuse and to move around like a gas. The most important property, though, was that as a supercritical fluid, it had effectively no surface tension. And without a surface tension, this meant that it wasn't possible to have capillary action, and we shouldn't have that problem with the gel trying to crush itself. It was a lot harder to see in the chamber than I expected, and the supercritical transition was honestly not as clear as I hoped it would be. On my second channel, though, I did a much more in-depth video about supercritical CO2 in general. I also did it in something that made it a lot easier to see what was going on, and if you're interested in checking it out, there's a link in the description. But anyway, after reaching the supercritical point, it wasn't even close to being done. I still had to heat it a lot more and push the CO2 further into the supercritical region. This had to be done extremely slowly and carefully by only raising it by a few degrees and then waiting 20 or 30 minutes. Doing this as slow as possible was very important because it was the best way to avoid cracking the gel. Even though all the CO2 in the gel was supercritical, when it's heated up, it still expands, and if it's done too quickly, it would just break it. This was the scheme that I tried to follow, where each temperature interval was held for at least 20 minutes. As the temperature increased, so did the pressure, and at 39 and 53 C, I had to carefully open the valve on the right and vent some of the CO2. I eventually got it to 60 C, and at this point, everything in the chamber was well above the critical point and deep in the supercritical region. If I did everything right, the gel would hopefully still be uncracked, and it would be filled evenly with hot supercritical CO2. What I had to do next was the last and most important step, and that was to get rid of all the CO2. To do this, I just had to open the valve and vent it, but it had to be done very carefully. If the pressure dropped too quickly, the pressure outside in the gel could become less than the inside, and it could cause it to explode or crack. So I opened this valve almost as little as I possibly could, and I slowly depressurized it. As the pressure decreased, all the CO2 in the chamber gradually moved out of the supercritical area. All the CO2, though, was still quite hot, so instead of turning back into liquid CO2, it was all going back into regular CO2 gas. As a gas, it also has no surface tension, and it should be able to leave the gel without causing any damage. It took an hour and a half to completely depressurize it, and over this time, I had to constantly check on it and adjust the valve. When the pressure was eventually at 0, I completely opened the valve, took away the camera, and removed the hosing. I brought it all over to my vise and unscrewed the window, and now it was time to see if all this work was worth it. As I pulled it out, it didn't look like it had shrank or anything, which was definitely a good sign. So at the very least, I had made some sort of aerogel. When I got it out more though, I noticed that there were, unfortunately, at least a few major cracks in it. But despite this, I was still pretty happy with how it turned out. I mean, it wasn't even close to being perfect, but for my first attempt, I thought it was pretty good. From all this though, my main conclusion was that this process kind of sucked. It took about 4 days just to prepare the gel in the chamber, and then it took an entire day just for the supercritical part. It was also very labor intensive, and I had to babysit it the entire time, and I couldn't really do anything else. Also, on top of this, using a heat gun wasn't really ideal because it was only able to get one side of the chamber. I unfortunately wasn't able to see the gel the whole time, so I don't have a lot of proof of this, but I feel like it was just this supercritical step that really caused the gel to crack. I wanted to try doing it again, but instead of just doing the same thing, I decided to try something new. This time I didn't use a heat gun, and I instead bought a sous vide meat cooker. This thing was originally meant to cook things like steak, but I felt that it would be perfect here. It had a built-in temperature controller, so all I had to do was put the chamber in the water with it, and then click a button. So to get this started, I loaded the chamber with a hexagon this time, and I repeated the same exchange steps using the liquid CO2. When it was done, I lowered the entire chamber into a tub of water, and I attached the sous vide cooker. I then added as much water as I could, but I was only able to cover half of the main chamber. This was fine though, because the part where the gel was completely covered, as well as a decent portion above it. This would give me good temperature control and consistency in the part that it mattered the most. Even though the upper part wasn't in the water, it would still heat up because the whole thing was made of metal. However, it would also lose a lot of heat to the air, which wasn't good. To try and fix this, I loosely covered the whole thing with aluminum foil, which would help hold an insulating pocket of air. This wasn't a perfect solution, but it would let the top part roughly match the temperature of the bottom, and that was all I needed. After this, I was ready to get things going, and all I had to do was turn on the cooker. This entire process in terms of heating was similar to what I did with the heat gun. I had to keep raising it by a few degrees and then waiting about 20 minutes. However, this time, the major difference was that I barely had to do anything. I just occasionally clicked on the cooker a few times to turn up the temperature, and that was it. What was interesting was that without the camera right against the window, this supercritical part looked a lot different. For some reason, when the camera was super close, it wasn't possible to see the blue haze that it made at the supercritical point. Unfortunately, though, I didn't plan to film any of this, and everything here was just done last minute using my phone. What was also weird was that at some point, it all turned orange inside the chamber, but there was no orange light anywhere. Then, as it got further past the supercritical point, this color slowly disappeared. I vented it at 46 and 53 C, and I eventually got the temperature up to 62. Once it was there, I didn't need the hot water anymore, and I pulled out the chamber. I was now able to get a decent angle to look inside, but I was only able to see a small part of the gel. It was completely uncracked, which was a very good sign, but I had no idea what the other part of it looked like. To get rid of all the CO2, I just opened the valve and I vented it over the course of an hour and a half. I also used a screwdriver to help turn the valve a lot more precisely. As I vented it, I kept looking at the gel, and it looked the same even after all the CO2 was gone. After seeing that, I honestly started to get really excited, but again, it was just a small portion of the gel, and I tried to not get my hopes up too much. Now that it was empty, I carried the whole thing over to my vise. I then unscrewed the window and I took a look inside.
I like what I see.
Oh,
Look at that.
and well, my hopes weren't destroyed. From what I could tell, it was and I could honestly barely believe it. I really did think this one would be cracked as well, and I thought that it was just going to be a bit less than the last one. What I had here, though, in my opinion, was about as close to perfect as it could have possibly been. It was slightly yellow, though, and I'm not sure if this was because of the recipe that I used or because the gel was really old. I originally made them back in November, and this run was done in March, so they weren't exactly fresh. My personal opinion is that it's probably from the recipe and not the age, but I don't have any real evidence to prove that. Either way, though, I finally did it. I started working on this project back in July, and it has taken a long time to fix all the problems and to get all the supplies. I was extremely lucky that it worked after just 2 real attempts, but it took months and months of constantly reading stuff and trying little things. I was really happy with the final result, and the only issue that I saw were some small bubbles in it, but those are from when I made the original gel. I didn't think they'd be visible in the final aerogel, but I mean, they obviously were. In the future, I might try to fix that, and I also might try to modify the chamber so that I can load more gels. In my opinion, even with the sous vide cooker, it was still way too much work just to dry 1, and I'm convinced there's a way to do up to 4. However, for now, I'm a bit tired of thinking and working on aerogel, and that probably won't happen for another year. Now, on a bit more of a personal note, projects like these kind of destroy my soul. They can take months of work to just finish the project, and then it usually takes at least a couple of weeks to put it all together. This isn't at all a complaint, though, because they're always worth it at the end. But for over a year now, I felt like I need to work on some smaller and less serious projects. I've also felt like I wanted to show more of what goes on behind the scenes because there's so much more happening that the camera never captures. So in February, I decided that I'd finally make it happen, and I hired a friend of mine as a cameraman and editor. Since then, we've already completed a few projects, and the first video of this new type was released a few weeks ago. It was completely different than what I would normally do, so I posted it on my second channel, Nile Blue, because I want to keep this type of content completely separate from the main stuff. The goal of these videos is to still be scientific and educational, but to also show a lot more of the fun side of practical science. However, the only issue is that that channel basically makes no money, and unlike Nile Red, it also has no Patreon support. Thankfully, though, I've been able to get some nice sponsors on this channel like Raycon, who are making Nile Blue possible. Raycon makes wireless headphones and earbuds, and they recently sent me a pair of their new E25s to test out. They showed up in this nice little box, and I was able to Bluetooth pair them with my phone in less than 30 seconds without even reading any of the instructions. I've tried them out for the last couple of weeks while working in the lab, and so far, I've really liked them. They have good bass, 6 hours of battery life, and they're comfortable to wear for a long time. Also, this is kind of a niche thing, but I like that I'm able to just use one of them and I can turn the other one off. This is because while I'm in the lab, for safety reasons, I can't block both ears. In terms of cost, they're also surprisingly affordable, and despite sounding just as good, they start at half the price of other premium wireless earbuds. But with all that being said, I definitely recommend checking out Raycon. You should also use my link, buyraycon.com/NileRed, which will give you 15% off your order if you choose to pick some up. And now, this is finally the end of the longest video that I've ever made. I hope you guys enjoyed it, and I'll see you on the next one. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.
What is it about Chamberlain University that makes our nursing students so successful? Our culture of support gives every student peace of mind. Care isn't just what we do, it's who we are. That's what you can expect from the #1 largest nursing school in the country, Chamberlain University.
With new, gentler scents, clean smells as it feels.
About 7 months ago, I saw a video by AVE where he attempted to follow a paper that he found online, which detailed how to make transparent wood. The basic idea was to first treat the wood and then to fill it with a plastic resin. I honestly think he made a good attempt at it, but in the end, it was pretty much a total failure. However, I didn't think it was because he lacked the skills to do it or anything, and I thought that it was mostly the supplies that he used. The paper called for a very specific wood and epoxy resin, but he tried to substitute them for ones that were easier to get. Also, I think the paper that he had was incomplete because he mentioned in the video that there was no procedure in it. So unfortunately for him, all he had to go on was from a couple of lines of text in one of the diagrams. This can make things incredibly difficult, and on top of not having the correct supplies, I'm not really surprised that it didn't work out. In any case, his video was still very entertaining as usual, and it got me interested in trying it out myself. To get the highest chance of it working though, I tracked down the exact supplies that were used in the paper. I also found a complete copy of the paper, which included an experimental section. It still wasn't as detailed as I would have ideally liked it to be, but it was definitely a lot better than just what was in the diagram. So in terms of supplies, the first and most important one was the wood. They used basswood from the Walnut Hollow Company, and it was very easy to order online. The company itself didn't ship to Canada, so I had to get it from eBay, and it arrived a couple weeks later. It was just this big carving block though, and the paper called for 3mm slices, so I had to cut it. I read online that the easiest way to do this was with a table saw, so I tried it out. I originally didn't plan to film this, but I decided to at the last minute. And because of this, what you see here is definitely not the safest way to use a table saw, and not something you should use as a reference. I wanted to get the best shot possible, but I didn't have a stand, so I had to do it from a weird angle and push the wood sideways. I'm also only using my right hand because my left one was holding my camera. At the time, I didn't really feel like this was unsafe at all, but looking back now, it doesn't look very good. But anyway, that aside, the first few cuts that I made were lengthwise ones, which went along the grain of the wood. The next ones were cut the other way, and again, it was done with poor technique. When I was done, I cleaned them all with sandpaper, and this was the result. The main difference with these cuts is the way that the grain runs across them, and the paper had a good diagram of this. Wood naturally contains a system of narrow tubes, which allow the tree to move water and nutrients, kind of like our blood vessels. The exact anatomy and structure changes between hardwood and softwood, and between species, but that isn't really important here. I think the only thing you really need to know from this is that these tubes do exist, and they run in the same direction as the grain. If we look closely at this piece, which was cut lengthwise, we can see grain lines running from end to end. This means that the narrow tubes span the entire length of it and only open up on the ends. On the other hand, the widthwise cuts were against the grain, so all the tubes were cut much shorter, and the open ends are on the large flat part. This means that the tubes are now quite short, only about the thickness of this piece, which is between 3 and 4 millimeters. The paper detailed quite a bit about how this affects the resin doping process, but I wanted to try it out for myself and to show you guys the result. Anyway, the next step was to chemically treat this wood with a mixture of sodium hydroxide and sodium sulfite. I got the sodium hydroxide as drain cleaner from my local hardware store, and I think I bought the sodium sulfite from eBay a really long time ago. I then looked at the paper to see how much I needed of each, and I was sad to see that they just gave concentrations, but somehow no volume amount. I figured that it probably just needed enough liquid to cover all the wood, and that 500 mils would be more than enough. And now that I had a target volume, I could calculate how much I needed of each, which came out to be about 50 grams of the sodium hydroxide and 25 grams of the sodium sulfite. So now that I actually knew how much I needed of each, I could move on to making the solution. I went ahead and pulled out a 1 liter beaker and I filled it with distilled water up to around 400 mils. Then I turned on my stirring, added 50 grams of the sodium hydroxide, and waited for it all to dissolve. A few minutes later, there was no solid left, and the solution had heated up quite a bit. So I went ahead and poured in the 25 grams of the sodium sulfite, and I waited for that to disappear as well. Now, some of you might be wondering here why I started with 400 mils if I did all my calculations based on 500. And the reason for this was that adding both the ingredients caused the volume to increase a bit. If I started with 500, the final volume would have been slightly above that, meaning my concentration would be a bit less than what it called for. In theory, and especially for this, I don't think it's a really big deal, but I still tried to get it as accurate as possible. So I started with a random lower volume, let it increase as things dissolved, and then just topped it off to the 500 mil mark. When the solution was ready, I also took out the stir bar because it's not going to be used for the rest of the prep. The reason for this is because as the wood gets processed, it becomes quite fragile, and if the stirring's left on, it would probably start breaking it apart. In any case, the solution was now ready, and I just needed to heat it up, so I turned on the hot plate. And when it started boiling, I dropped in some of the wood pieces. I probably could have just thrown them in all at once, but I decided to add them one by one just to make sure that it didn't bubble out of control. When it was all added, it seemed relatively tame, so I turned the heat up a bit more. This was probably a mistake though, because within just a few minutes, it started boiling way too violently. It also started bubbling a lot more, and I was kind of concerned that it would get out of the beaker, so I took it off the hot plate for a bit. Then I put it back on about a minute later, and I also turned the hot plate to a lower setting. Over the course of the next couple minutes, the boiling slowed down a lot, and it eventually got to a rate that I liked. The idea here was to bring it to just around or below boiling, but not to boil it too violently, because then I would just be losing a whole bunch of water. At this point, I thought it looked decent, so I added a bit more distilled water and I put a bowl on top. The purpose of this bowl was to help cool the vapors and recondense them into the beaker, and to help with this, I put a bit of water in it. Under ideal conditions, I would have done this all in a round bottom flask and used a condenser column above it. However, these pieces of wood were clearly way too big to fit into the opening of a round bottom, so I had to use this poor man's system instead. Okay, so to understand what's going on here, I first need to quickly go over the basic composition of wood. In general, wood is made of three main components: cellulose, hemicellulose, and lignin. The cellulose is an unbranched polymer made of glucose, and it forms long chains that are usually between 7,000 and 15,000 units long. The hemicellulose, on the other hand, is a much shorter branched polymer, usually between 500 and 3,000 units long, and it's made from a mixture of glucose and some other sugars. Together, these two biopolymers form the major framework of the wood, but alone, they aren't very strong. So to increase the strength, the tree uses another biopolymer that's called lignin. This one's even more branched than the hemicellulose, and it also has no real defined structure. It's kind of just a random network of phenolic units, but it's really useful. It serves to cross-link and hold in place all of the long hemicellulose and cellulose fibers, and it also fills up the empty space. So with that being said, I can now explain what I'm doing here. In the presence of the sodium hydroxide and the sodium sulfite, some of the lignin's getting chopped up and removed from the wood. This whole wood treatment process that I'm doing is very similar to something called the Kraft process, which is used to convert wood into pulp and then paper. And in the future, I'm definitely going to try out the Kraft process for myself because I'm really interested in making some paper. In any case, the major idea here was that by removing the lignin, it would just leave behind the porous network of cellulose and hemicellulose. Then in a future step, I could inject epoxy and it would fill up all this empty space. This process mostly just targets the lignin, but to a certain extent, it also attacks some of the hemicellulose. In the end, though, there will still be some left, so I'll have a mixture of cellulose and hemicellulose. However, for the rest of the video, I thought it was kind of annoying to have to mention both every single time, so whenever I mention cellulose, just know that I'm including hemicellulose as well. In any case, this reaction is quite slow, so even with heating, it still takes a while. In the paper, it said to soak it for 12 hours, so I just left it overnight. When I came back the next day, I noticed that I had lost a lot of water, and this was because my bowl had dried out. This wasn't really an issue because I still had plenty of it left, but I probably should have topped it off a bit more the night before. Regardless though, at this point it was done, so I took it off the hot plate. This dark, nearly black solution that almost looked like Coke or Pepsi was dumped off into another beaker. Then my now treated dark pieces of wood were washed 3 times with boiling distilled water. The purpose of these washings was to get rid of any reaction side products, as well as any sodium hydroxide or sodium sulfite that might remain. So each time I just poured in the water, mixed it around a bit, and let it sit for about 5 or 10 minutes. Each time this gave me a nice yellow colored solution, which I would then pour off and dump in more distilled water. By the 3rd time, I thought the yellow color would completely disappear, but it didn't really seem like that was the case. When I was done these 3 washings, I topped it off with some more boiling distilled water just to make sure that the wood didn't dry out. So at this point, this was what the wood was like. For the lengthwise piece, it was still rigid in the direction of the grain, but in the other way, it was kind of floppy. And this made sense because we weren't supposed to be damaging the cellulose in any way, so they should still be strong. We were just getting rid of the lignin that held each fiber together. For the other piece, it was floppy in all directions, which made sense because we had no long cellulose fibers here. They were all cut very short, basically to the thickness of this wood, and now with very little lignin left, there wasn't much holding them together. At this point, the pieces were more or less ready to be filled with the resin, but there was still some lignin left that was making them brown. So the next step was to get rid of almost all the lignin that was left, and to do this, I used hydrogen peroxide. In total, I added 100 mils of 35% peroxide, and I stirred it around. Almost immediately, though, I realized that adding everything all at once was probably a mistake. The peroxide quickly started breaking down into oxygen gas and water, and the whole thing started to bubble up. It also didn't really look like it was going to stop anytime soon, so I had to take it away and put it in a container. And by the time I got it there and set up the camera again, it was already foaming like crazy. I left it here for a few minutes with occasional mixing, and eventually it all went down. I think the major reason why this happened was not only because I dumped in all the peroxide at once, but I also kind of heated the solution before adding it. The paper said that the wood needed to be boiled in the peroxide, so I didn't really think it was an issue to preheat it, but I mean, it clearly was. In any case, when it was all under control, I put it back on the hot plate, but the volume was really low. Instead of just dumping everything off and remaking the whole thing from scratch, I decided I would just top it up with regular 3% peroxide. The reason I did it like this was not only because it was easier, but also because I was kind of afraid of making it too concentrated. I had hoped that by doing it this way, the bubbling wouldn't get too crazy. It initially seemed okay, but as the temperature increased, the foaming got worse and worse. It wasn't nearly as bad as before, but by the time that it got to boiling, the foam was at the top, and I had to take it off the hot plate. There was something in the liquid that was making it foam a lot worse than usual, so I dumped it all off, and I filled it up with some fresh 3% peroxide. This was then slowly heated and brought to a boil, and while it still did foam, it wasn't nearly as bad as before. One thing that I do want to mention is that the paper called for a very specific concentration of peroxide, which was why I initially made it by diluting the concentrated stuff. By their instructions, it comes out to be around an 8 or 9% solution, but based on my experience from this run, I think the dilute 3% stuff is more than good enough. In any case, the direction that it gave was to just boil it in the peroxide until the yellow color disappeared. It gave no indication as to how long this would actually take, and it also didn't really say how to determine when the yellow color was gone. So my plan was to basically just keep boiling it until they turned white or something. I also randomly added more peroxide at various intervals when I felt that it needed more. There really wasn't much science to that though, and it was more or less just when I felt like the volume was too low or when it wasn't bubbling enough. Just like the last process, this one was really slow, and it took about 5 hours for it to look like this. The ones that were cut widthwise were completely white, but the lengthwise ones still had yellow on the edges. So I kept this going for another hour or so, but it didn't really seem to change, so I took it off the hot plate. I dumped out all the liquid, and then these pieces were washed 3 times with distilled water. This was done just to get rid of as much of the peroxide as possible. Before I dumped off the water from the last washing, I took a closer look at them. This was one of the pieces that was cut widthwise, and you can faintly see my fingers through it. Then by contrast, I pulled out one of the lengthwise pieces, and you couldn't see my fingers at all. Again, this comes down to the direction of the grain, because here they're all running lengthwise, so it's perpendicular to the light that's hitting it. This causes a lot of the light to be scattered, and very little of it is able to make it through. Whereas on the other hand, the widthwise cuts have their cellulose and their tubes running parallel to the light, so a lot more of it's able to get transmitted. In any case, these wood pieces were now almost ready, but there was just one last step. The resin that I'll be using isn't compatible with water, so I first need to somehow get it all out. The most common way to do this, normally, would be to just leave it out in the air and to let it all evaporate. However, I can't do that in this case, because now that the lignin is gone, as they dried, they would all shrink and get really hard. All of the cellulose fibers would get really densely packed together, and it would make it really hard to fill it with the resin. So instead, I used a solvent that could pick up and absorb the water, but at the same time, still be compatible with the resin. The paper specifically said that they used 95% ethanol, so that's what I used, but I think it's also possible to use methanol or isopropanol. But anyway, that was about it. After I added the ethanol, I covered the top, and I let it sit in the fridge for about a day to pull out as much water as possible.
Smiling first can help someone find the courage to do the same.
Being short-staffed, we all have to do a little bit more. That's why we switched to Dawn Professional. Its grease-cutting suds last 2 times longer, so we can wash double the pots in just one sink, which means we can focus more on our famous baked ziti.
Dawn Professional Manual Pot and Pan.
Olive Garden's never-ending pasta bowl is back. So first round, get your go-to. Second, have what she's having. What he's having. Go on, try that new spicy 3-meat sauce. Starting at $13.99 and back for a limited time.
Okay, so at this point the wood pieces were ready, and I just had to put the resin in them. In theory, there are many different epoxies that can be used, but the paper specifically called for this one. There might be other reasons why they used it, but it seemed like the major one was just that it had a low viscosity, which made it a lot easier to pull it into the wood. To use it, it was pretty simple, and I just had to mix part A with B in a ratio of 2:1. So just for example here, I measured out 40 mils of A and 20 mils of B. Both the parts were then transferred to a disposable plastic cup, and I started mixing it around. And after about 30 seconds or a minute, when I felt that it was a pretty good mixture, I dumped it into another plastic cup. The major reason for this is that often at the sides of the cup, it doesn't really get mixed very well. So to fix this, I just dump everything into a new cup, and I leave all the potentially poorly mixed stuff in the old one. This one was again thoroughly mixed around just for good measure, and then it was good to go. So for the first run, I randomly picked out several small pieces, and I put them all on some paper towel to soak up some of the ethanol. All of these pieces came from a larger widthwise cut one that had fallen apart. I then transferred them all to a bowl, and on top of it, I poured in the epoxy. One thing to keep in mind is that right after making the epoxy, it starts to set. So because of this, it was really important to pick all the pieces and to get them into this bowl as quickly as possible. Just letting these pieces soak in the epoxy really wouldn't work very well, and I had to pull a vacuum. So this entire bowl was sealed in a vacuum chamber, and I turned on my pump. As the pressure dropped, air in both the wood and the epoxy started to get pulled out. It also caused a lot of the ethanol in the wood to evaporate, and because of this, a lot of bubbling started happening. The vacuum was held on for about 5 minutes, and then I repressurized the chamber. And when I did this, the epoxy rushed into the wood to fill the empty space where there used to be ethanol or air. According to the paper, this process then had to be repeated 2 more times. In theory, it would probably be best to be able to do this process several times, but we're limited by the cure time of the epoxy. The paper warned that by about the 30-minute mark, the epoxy usually starts to get too thick. After the 3rd cycle, the pieces weren't floating well anymore, and it looked like they'd sunk down, which I thought was a good sign. I had hoped that this meant that most of the air and ethanol had been removed and replaced with epoxy. What was unfortunate, though, was after this, the paper wasn't super clear about the next step. All it said was that the wood and the resin was kept static for 12 hours, but I didn't really know what that meant. If I just left it like this in the bowl, it would completely solidify and just never come out. There would also be so much extra epoxy around it, which I didn't really think made sense. So I decided to take the pieces out and to just let them sit on the back of a crystallizing dish. I figured that this way, when they all hardened, they would be a lot easier to peel off. I also thought that having a whole bunch of extra epoxy wouldn't be ideal, so I did my best to clean things up. Then I left them out overnight, and 12 hours later, they were really easy to remove. I expected it to be quite hard, but I was able to just pick them all off with my fingers. The bottom of the dish was also relatively easy to clean by just scraping everything off. These were the final pieces, and I thought they kind of looked okay, but they were definitely far from perfect. To test them, I put them on the printed out procedure from this paper just to see if the text could be read through them. It was definitely possible to see that there was writing behind them, but it was nowhere near clear enough to actually read it. Now, taking a closer look at the pieces, there were clearly some problems with them. As this one cured, it kind of pulled itself apart, and I think it was just because there wasn't enough epoxy in it. There was also this one as well, which didn't have any cracks in it. It was very slightly transparent around the edges, but it almost looked like it was mostly just a surface coating, and not much actually got inside. To test its strength, I tried breaking it, and it really wasn't strong at all. To be fair, the epoxy still hadn't fully cured, but if enough had gotten in there, it definitely would have been better than this. In the paper, it said that the vacuum was used to both get rid of the air as well as the ethanol. However, even after the 3rd cycle, it seemed like a lot of ethanol was still coming off, so I thought this might have been the problem. To fix this, I thought that it might work to do a quick pre-drying step. So into the bowl, I put another piece of a widthwise cut, and I put just this in the vacuum chamber. Then I turned on my pump, and I pulled out a bunch of the ethanol. As I did this, the piece slowly turned white, and it also shrank a bit. I kind of didn't really have a real endpoint, and I just stopped it when I felt like it looked good enough. So when it was done, this was what I had. There was still a bit of ethanol in it, but I feel like most of it had been taken out. So now again, just like before, I had to fill it up with resin. And to do this, I put it in the bowl, dumped in the epoxy, and put this in my vacuum chamber. After the 3rd cycle, it looked pretty decent, and I put it on the crystallizing dish to cure. This time, though, I didn't wipe away any of the epoxy, and I actually added extra. Then the next day, when things were still soft, I peeled it off the dish. I also used a razor blade to cut off most of the excess stuff. And when I was done with a few last finishing touches, this was what it was like. It still wasn't beautiful and uniform like what they had in the paper, but it was definitely the best result that I had so far. Now looking closer at the piece, it was still kind of soft because the epoxy hadn't fully cured. And because of this, when I peeled it off the dish, I kind of put stress into this piece, which made small tear lines. In any case, I wanted to test how transparent it was, so just like in the last run, I put it against some text. This time, I was happy to see that it was way better, and I was actually able to read what was on the other side. I'm not sure if this is actually because my pre-drying step did anything though, and it might just be because the top of this piece is smooth. In the other runs, I took away most of the excess epoxy, and because of this, the surface of the pieces became quite rough. This would cause it to scatter light a lot more, and it could be one of the major reasons. What was interesting though, and they covered this in the paper, was that it really had to be right against the paper to read anything. The reason for this was that because although it was transparent, it was only barely so, and the cellulose was still scattering a lot of the light. Now for my third run, I wanted to try it with one of the lengthwise pieces. So just like the other run, I did a quick pre-drying step, and then I did the vacuum cycle 3 times. Then when it was done, I put it on the crystallizing dish, and I waited until the next day. The next day when I came back, the difference was pretty obvious. The 2 ends were kind of able to become transparent, but the middle of it was still quite white. When I took a closer look, I was able to see that barely any epoxy was able to make it to the center. As I mentioned before, the tubes in the wood were only open on the 2 ends, so for the epoxy to get to the center, it had to travel quite far. On one end, it looked like it almost made it a centimeter, but on the other side, it was only a few millimeters. This is why these lengthwise ones aren't ideal for this purpose, because it takes a lot more effort to get the epoxy in it. The trade-off, though, is that if we are able to get the epoxy fully into this piece will be a lot stronger than the other one. This was highlighted by the clip you saw earlier, where after the lignin was removed, this piece was still kind of strong, whereas the widthwise one was ready to fall apart. In any case, these runs were moderately successful, but I really didn't like the pre-drying step. It seemed to help to get out some of the extra ethanol, but it also caused the piece to shrink. This caused the cellulose fibers to pack more tightly together, which meant it would be harder for the epoxy to get into it. The paper didn't mention any issue about getting rid of the ethanol, and especially nothing about any pre-drying step, so I started thinking that it was probably just an issue on my side. And it was very likely just something to do with the equipment that I was using. The pump that I use is a water circulating aspirating pump, which is really useful and good for a lot of applications, but it just doesn't pull that much air. It's still able to get down to a really good vacuum, but it just takes a while. And I started thinking that if my pump didn't pull air very quickly, and on top of this, my vacuum chamber had a lot of dead space, I just wasn't doing things very efficiently. I figured that the next easiest thing to try would be to get a smaller chamber so I could pull a quicker vacuum. So that's exactly what I did, and I tried it both with a pre-drying step and without one. This was what it looked like the next day, where the one on the top was the one that got pre-dried. And right off the bat, I saw that that one had a much better result because the other one had already cracked. It was also really white in the center, which told me that the epoxy didn't penetrate it very well. These results were definitely not as good as I had hoped for, and they were actually significantly worse than one of the previous runs. However, I still thought there were a couple things that I could try. I mentioned just a minute ago that my vacuum pump didn't pull that much air, so one major improvement could be to just buy a faster pump. On Amazon, this really wasn't very expensive, and I was able to pick one up for around $100. Also, one other major improvement would be to make these pieces thinner. I thought of cutting it with a table saw like before, but I didn't think it was going to be possible to make pieces that thin. So I ended up trying it with a hacksaw, but it didn't really work out. I ended up asking my dad for help, and he said to just cut it freehand on the table saw. This would have been really dangerous to do one-handed like I did before, so this time I had my dad cut the pieces while I did the filming. These were all the pieces that were cut off, and this time they were a lot thinner. Instead of being between 3 and 4 millimeters, they were all between 2 and 3. I also only went with widthwise cuts this time because I wanted to get the best results possible. They were then treated just like last time, where the first step was to remove most of the lignin. And when that was done, I treated it with the peroxide, but this time I added the peroxide slowly and I started with a cold solution. I then slowly brought this to a boil and it never ended up bubbling out of control. However, even after boiling it for almost the same amount of time, it never fully whitened. At the time, I really didn't know what the reason for this was, but now I'm thinking it was because of the washing steps. In the first run, even though I washed the pieces quite well, there was still some sodium hydroxide that was stuck inside of them. However, in this case, I think just because the pieces were a lot thinner, it was way easier to wash out all the sodium hydroxide. And because of this, there was little to none of it left over, which could catalyze the breakdown of the peroxide. This was important, though, to generate oxygen gas in the wood and to destroy the rest of the lignin. I'm not 100% certain about this theory, but it would explain why the pieces didn't whiten properly and why it didn't bubble very much. Unfortunately, though, while I was doing it, I didn't think of that, so I tried a different route. I took out a small piece and I heated it with just regular bleach, and I found that it worked quite well. I considered splitting this batch in two and trying 2 different treatment steps, but in the end, I kind of just said screw it, and I poured in a bunch of bleach. I then turned on the hot plate and I heated it to around 50 or 60 C. The yellow color very quickly disappeared, and it only took something like 10 minutes to become completely white. And at this point, it was taken off the hot plate and all the bleach was poured out. Looking at these pieces, I was really happy with how white they were, but I also noticed that a lot of them had fallen apart. Using straight up hot bleach was obviously a little bit too rough on these pieces, so I don't think it was the best method. What I think the best thing to do is to just not wash the pieces too thoroughly after removing the lignin. Or maybe it's possible to give them a pre-treatment by soaking them in some sodium hydroxide. If that fails though, maybe a really dilute solution of bleach could work, or maybe just not heating it at all and letting it sit overnight. In any case, it was then washed thoroughly with water, and between each run, I let it sit in the water for about 10 or 15 minutes just to soak up as much of the bleach as possible. When I felt that it was done and I didn't really smell any bleach, I added the 95% ethanol. However, almost immediately, it started to get cloudy, and I think it was because the ethanol was reacting with the bleach. This ends up forming some chloroform, which dissolves into the ethanol, but it also forms sodium acetate, which I think is what gave it the cloudiness. In theory, this honestly really isn't a big issue, but I did want my pieces to be as clean as possible. So I let them sit here for a few hours to fully react, and then I dumped off the ethanol and I topped it up with some fresh stuff. In hindsight, it might have been a good idea to go back and do another water washing to get rid of the sodium acetate, but oh well. The small amount that was present probably really wouldn't affect very much. Anyway, with all this done, I was ready to try things out. And for my first run, because I had this new vacuum pump, a new vacuum chamber, and thinner pieces, I didn't really think a pre-drying step made any sense. Also, in the meantime, I looked at the paper and I realized something pretty significant. I had focused on the fact that in the procedure, they said that their sample pieces were peeled off in the end, but when I looked at the pictures, they actually kind of looked different. In this small image, I thought the entire transparent piece was the wood, but it's actually not. The wood's just in the middle, and it's surrounded by a bunch of plastic. In my mind, though, to get a relatively thick but still really uniform piece like this, they had to have used some sort of mold. They couldn't have just peeled it off a dish like I did. So I decided to try this out, and I went and got the silicone molds that I used for my making soap video. Using scissors, I cut out a few sections to make sample wells, and I was ready to get started. For the first run, I used the largest piece that I had, and I just put it in the well and covered it with epoxy. Then I turned on the vacuum, and the difference was immediately evident. With the smaller chamber and the faster pump, it got to a vacuum way quicker. It also clearly pulled a better vacuum because there was way more bubbling. As it continued, it got kind of crazy, and it caused a lot of splashing. After the third cycle, though, this is all really important to clean up with ethanol, otherwise it'll all get caked on and kind of ruin the chamber. In any case, this was what it looked like when it was done, and it was probably the best run that I had so far. I let it cure overnight, and the next day I took it out of the mold. Unfortunately, the piece had floated a bit to the top, so it wasn't completely covered with the epoxy. On top of this, the epoxy had kind of shrank in on itself, which made the whole thing have a bit of a curve. Nonetheless, though, it was still a pretty nice piece, and it was definitely transparent. I cut off the extra epoxy with a hacksaw, and then I tried to see if I could read through it. Unfortunately, even though it was quite clear, I couldn't because I think the epoxy was spacing it up from the paper. And as we saw before, taking it just a little bit away from the paper can make things too hazy to see through it properly. I thought this piece was pretty good, but when I let it cure for another day or so, it ended up cracking itself. In my mind, the major reason for this was that the top part didn't end up getting covered properly, so I tried to do something about this. I did another run, and like before, the piece slowly floated to the top. I tried occasionally poking it back down, but it didn't really work at all. What I ended up doing was waiting about an hour for it to harden a little bit, and then on top of this, I poured some fresh epoxy. I think I added too much though, so using a syringe, I pulled out some of the excess. And when I felt I got to a good level, I just put it on the side and waited for it to cure overnight. The next day it looked okay, so I demolded it and cut off the excess with a hacksaw. This was the final result, which I thought looked decent, but it was still definitely far from perfect. When I looked at it on the side, I could see that there was a whole bunch of extra epoxy above and below the wood, and also the piece was curved. I'm not exactly sure what the reason for this was, but apparently it still happens even when the top is completely covered. In any case, I started thinking that maybe using a mold like this wasn't actually a good idea. When I was doing it before by just putting it on the back of a dish, I didn't have a problem with any of my pieces bending. So I decided to try doing that again, except this time I had a much better pump and a better vacuum chamber. Unfortunately, at this point, I didn't have any large pieces left, so I just used a couple medium-sized ones. When they were done, I laid them out on the dish, and I made sure that they had a huge excess of epoxy. I also came back about 30 or 40 minutes later, and I covered the top with the half-cured epoxy that I had pulled these pieces from. This was what it looked like the next day, and the piece on the right was probably my best one so far. Unfortunately, the one on the left didn't get fully filled, so it was kind of just scrap. I peeled it off, cleaned it up with a razor blade, and then I did my transparency test. And this time, it was pretty good. It was a bit hazy, but the text on the other side was still pretty easy to read. So I guess these conditions were my best so far, but there is definitely a lot of improvement that can still be made. For example, as the piece cured over the next couple days, it ended up just bending itself again. It luckily didn't end up cracking, but it was still definitely a problem. However, it did kind of work pretty well as a nasty overgrown thumbnail. Anyway, I think that's about it. In general, I had a lot of fun working on this project, but I definitely think it was a lot more difficult than I expected. And this was mostly because, again, there just wasn't very much detail in the paper. I think the overall takeaway, though, is that for this process to work well, you need a good vacuum chamber, a pretty good vacuum, and to have the pieces as thin as possible. And one final thing, which I never really mentioned, was the reason why these people even tried making transparent wood in the first place. And the reason for this was that not only did it make a strong composite material, it was also transparent, and it came from a renewable resource. The major issue with it, though, as we saw in this video, is that getting the epoxy into it is really hard, so making larger pieces is going to be difficult. In the future, I might revisit this because I think I still do want to make a large piece of it. I would start out with using the same 2mm thickness, but just have a really large face, and then I might move into some other thicker or weird shapes. I have so many projects to do before that, though, so I have no idea when or if I'll ever get around to doing that. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see my videos at least 24 hours before I post them to YouTube. Also, everyone on Patreon can directly message me, and if you support me with $5 or more, you'll get your name at the end like you see here.
Smiling first can help someone find the courage to do the same.
We made a better tasting snack!
Nothing's working with them.
Let's try Simply, with no artificial colors or flavors.
Ingredients you feel good about with the flavors of Cheetos and Doritos.
These are good.
Win the snack time battle with Simply.
In the world of science and engineering, there are many things to study. For example, mathematicians study what is. Physicists study what probably is. Engineers study what isn't yet. But the bioengineers, we study what never should have been. On this channel, that is very much the case. We've turned various vegetables into meat and are actively working on a system to play video games with a dish of living neurons, amongst other things. Though something we haven't done in a while is any real genetic engineering and messed with the life code of an organism. But that's easy enough to fix. Inside this box is my order for thousands of dollars worth of custom printed DNA. And today we're going to put each of them into some cells so I can show you what they do and how they work. And there are some pieces in here that I have wanted for years. If this is your first time hearing of the concept of printing DNA, I am pleased to report that it is actually really old technology at this point, and surprisingly affordable. There are lots of companies now that'll print out almost any sequence you want, though of course the trick is knowing what sequence to order in the first place, but we'll get to that. There has been a slow and steady revolution in the world of biology that's taken place over the last 30 years, and what was once painfully expensive now is a service used even by plucky high school students. But what can we even do with a printed piece of DNA anyway? Why would somebody pay hundreds or thousands of dollars for a few micrograms of life spaghetti? Short answer, the limit is basically only your imagination. You can make an organism synthesize useful chemicals, or make rainbow fish, or custom flowers, living logic gates, or snozzberries that really taste like snozzberries. With enough time and resources, you could probably make most of the monsters from Dungeon Meshi. And while that would be unfathomably difficult, it's not actually impossible. It's simply a matter of skill, time, and having a nearly endless supply of money to throw at the printers. Over the years, I've had all kinds of weird and cool bits of DNA printed or sent to me, and it'll take a whole series to go through them all, especially because I keep buying or making more. In preparation for this video, I've been going through my collection and picking the best pieces, tidying up their designs, and having them reprinted. That way, they're as easy to use as possible and are nice enough to be worth selling to all of you. One of the nice things about DNA is that once you have the original sequence printed, it is much easier to make copies and share it. And for the last few months, we've been getting ready to add DNA, bacteria, and other biologicals to our store. There are a few places that sell DNA, but the ones that have the most selection and the highest quality are businesses that only sell to other businesses, or to academics and nonprofits. On top of that, the DNA they sell is designed for industry and academics. What we wanted to do is have a store that'll sell more broadly, and the DNA that we carry will instead be designed to be either an amazing learning experience for students, or things that are demonstrations of modern synthetic biology. And of course, there's a few things that we made because they're either just cool or a useful tool. Today, not only are we going to be learning how to code DNA and go through a lot of constructs to learn how they work and see the cool things they can do, many of them are available now with the plan to add more to our store regularly. And I have some truly magnificent things in the works that will be the subject of upcoming videos and are just finishing printing. So let's dive in and learn how to recode life itself. Like all coding languages, learning them is best done by starting with simple examples, and we'll build up to more complex use cases. We'll start with literally the most basic use case, making a bacteria produce one new protein, and we'll work up to building metabolic pathways, logic gates, and oscillators by the end of the video. In truth, though, there are actually a lot of ways to modify the genetics of an organism, and not all of them involve printing DNA. Before DNA printing was cheap and many genetic tools have been developed, scientists use things like atomic gardens to make their GMOs. Basically, the way this worked is that you have a specially built circular area where you can put plants, and in the center was a retractable pillar. Inside that pillar would be an extremely radioactive chunk of material that would allow you to irradiate all the plants you put around it. Once you'd irradiated them enough, you harvest their seeds and plant them and see if you get any weird plants that have new properties that you want. You then take those weird plants and breed them with normal crop strains to stabilize the gene. As you might imagine, there's nothing particularly efficient or fast about this process, but you've enjoyed the results of it even if you didn't realize it. For example, those red grapefruit you see everywhere were made this way. Normally, grapefruit didn't have that intense red color on the inside. But it's not just grapefruit, lots of crops are fruited this way. Though for some reason, mutagenesis like this usually isn't considered genetically modified, even though you're changing literally thousands of genes randomly. For some reason, this doesn't count. But mutagens are still used all the time to tweak and improve crops, and we use them in the lab as well. Even before nuclear gardens, humans have been messing with the genetics of pretty much every organism around us. For as long as there have been humans, there have been GMOs. My favorite example of this is Brassica oleracea. This simple plant started as field mustard, and it had a wide natural range. But everywhere it grew, different pockets of humans started growing it and selecting plants for characteristics they liked. Some people selected for terminal buds, which gave us cabbage. Some selected for lateral buds, which gave us Brussels sprouts. Some for stem, which gave us kohlrabi. Stem and flowers, and you get broccoli. Flowers alone, and you get cauliflower. Seeds, well, that's just mustard. And some truly deranged humans selected for leaves, and that's how we got stuck with kale. There are almost no foods that you have ever eaten that haven't been heavily modified by curious humans wanting to make their food just a little bit better. We just happen to exist at the end of a 10,000-year journey where most of the work has already been done. Corn was inedible, carrots were a joke, and almonds or tomatoes would probably have killed you. And it's not just the plants. Animals and even various fungi and microbes have been domesticated and tamed by human modification. Silkworms, bees, puppies, beer, chocolate, apples, potatoes, and turnips, all just as man-made as a Pop-Tart. Turnips, by the way, also brassica. But thankfully, we're not Neolithic humans anymore, and now we can just go in and directly change and add or remove whatever gene needs tweaking. So let's move on from random to precision and learn how we can just print and insert DNA however we want. Now, the first thing you need to do before you start printing is pick the organism you want to work with. There are many to choose from, and scientists have also isolated examples from almost every area of nature and chosen examples to work with that have become so-called lab strains. Today, we're going to be working with a bacteria you have almost certainly heard of before, E. coli. Now, if you've never worked with E. coli before, a brief word of warning. E. coli was isolated from a human stool sample nearly 100 years ago. As such, it's not so much that E. coli smells like poop, so much that poop smells like E. coli. In fact, around 25 to 55% of the dry weight of poop is actually bacteria, not the food you ate. So most of what comes out of you grew inside of you. Horrifying as that thought is. While E. coli is a fantastic organism to work with in principle, being easy to modify as well as being the most well-studied organism on Earth, the smell is not fun. That stank comes from a chemical called indole and is actually how the bacteria communicate with each other. Because bacteria have no mouths but must scream, they all produce small amounts of indole. They can measure the level of indole present in solution as well. When the level gets past a certain threshold, bacteria know that their population has gotten too dense and will slow down their metabolism to avoid depleting the food supply as quickly. They're also not the only organism that use scents to communicate like this. The smell of cut grass, for example, is actually grass screaming to their neighbors to warn them that something has been damaging them. And nearby leaves of grass will increase the amount of bitter compounds in response to discourage pests. Though, unfortunately for the grass, that doesn't seem to deter the sharpened steel moving at many revolutions per minute. Anyway, all the DNA I'll be showing off today has been designed to work in E. coli because, as I said, it's a very easy organism to work with. For one, its doubling time is 20 minutes, so growing more is very quick. But beyond that, both its genetics and the physical makeup of its outer membrane make it particularly amenable to modification. E. coli in the wild have one main chromosome, but like many bacteria, they can also have extra pieces of DNA that float around called plasmids. These are small circular pieces of DNA that can be exchanged between cells to transfer new abilities if one of them evolves something new and useful. For example, the difference between dangerous E. coli and harmless E. coli is a plasmid that some of the cells carry that induces virulence and makes them dangerous. But without it, they're harmless, and some E. coli strains have been used as probiotic formulations. We can take advantage of all of this and design our own plasmid, and then stick that plasmid into the E. coli. If we design it correctly, it can't tell the difference between a natural one and our homemade one, so it'll run the program without issue. Think of all of this like installing new software. Instead of installing virulence genes, we're going to make the E. coli do fun and new things. Now, we're going to be designing our plasmids so that they continue to exist as plasmids. However, it's also possible to design them in such a way that the DNA will end up incorporated into the main chromosome, instead of just floating around on its own. But that's more complex, so we'll talk about that another time. For a plasmid to work, it really needs two things at a minimum: an origin of replication and a selection marker, though that's just what it needs for it to exist. We also need to add whatever else it is that we want the E. coli to do. But those first two things are mandatory. An origin of replication is exactly what it sounds like. It's a place where the machinery inside the E. coli can grab onto the DNA and start the copying process. This way, as the cells grow and divide, new copies of the DNA will be inherited by all of the daughter cells. There are many ORIs to choose from, but generally they come in two flavors: high copy and low copy. This refers to how many copies of the DNA will end up being maintained in each cell. Low copy is in the 5 to 10 range, high copy is in the 400 to 600 range. So, just a small difference between the two. High copy is better for, well, making lots of copies of the DNA and physically producing a lot of DNA. Whereas low copy is better for protein expression because you're less likely to overwhelm the protein production machinery. With the ORI chosen, the other thing to pick is your selection marker. A selection marker is just something you can use to sort the modified cells from the unmodified ones. And since we can't go in with tiny tweezers and just pick out the good ones, this usually means something like an antibiotic resistance gene. This way you can kill off any cells that haven't taken in the new DNA by spreading the bacteria onto an antibiotic plate. When we go to actually put the DNA into the cells in a moment, only a tiny portion of the cells will actually successfully take it in. So we need to get rid of all the failures and allow only the modified ones to grow. Though you don't need to use antibiotics necessarily. Of course, they're quick and easy, but that does mean you're spreading antibiotic resistance genes around. Other options can include things like synthesizing essential amino acids. And instead of antibiotic plates, you grow the bacteria on media that is missing that essential component. Or you give them the ability to eat something that normal bacteria can't, and then you feed it to them. Many of my plasmids are designed to work with an antibiotic called kanamycin. I like this one for two reasons. First, I'm allergic to penicillin family drugs, so I don't love working with ampicillin, which is what many other plasmids use. Secondly, because penicillin has been around for so long, many of the microbes in the air around humans actually tend to be resistant to it already. So you'll have much more of an issue with contamination with ampicillin than you will with kanamycin. Now, it may have sounded like you need to code all of this stuff up yourself, but in truth, this has all been done for you. There are many, many plasmids already available that come with an ORI and a selection marker already built in, as well as what's called a multiple cloning site, or MCS. The MCS is a spot where it's been purposely made very easy to pop the DNA open and slot in a new piece. This way, you don't have to print the whole plasmid each time, only a tiny little piece, and you choose what's called the vector or backbone according to your preferences and needs. Most of my plasmids are based around a vector called PET9A. It's a low-copy kanamycin-carrying backbone. So all we need to do now is design the piece we slot in. So with the basics sorted, what can we actually put in here? Well, let's start off easy. One of my favorite families of proteins are the fluorescent proteins. As their name implies, they're proteins that respond to UV light by glowing brightly. And they come in literally every color. They're also the closest thing to a hello world equivalent that you're going to get with DNA, so are the perfect thing to start with. I am an avid collector of fluorescent proteins, and my freezer is packed full of different tubes of colors, and we actually did a video showing off the state of my collection a few years ago. But since then, I have added some truly incredible ones and actually made a few of my own. Because these sorts of proteins are useful and variable, there's actually a whole website dedicated to cataloging fluorescent proteins called FPBase, where you can explore the different colors and find their sequences. However, it's not quite as simple as just copying the sequence you find on this site and pasting it into our plasmid. First, it needs to be translated from protein sequence to DNA, but that'll only give you the code for the protein itself, and pasting it into the plasmid won't have any effect. To make this work, we need two more things, a promoter and a terminator. Just quickly as a refresher, this is the central core tenet of biology. DNA is the information storage molecule, and proteins are the big important molecules that DNA usually codes for. But to get from DNA to protein, there's a middle step. The DNA first has to be read and a copy made out of RNA. It is this RNA, called messenger RNA or mRNA, that is then read and transcribed into protein. And yes, mRNA is the same stuff used in vaccines. Because it will instantly induce the creation of protein as soon as it gets inside of a cell, but will then be quickly broken down, it makes a great vaccine platform. You can get a ton of protein produced quickly so your immune system can chew on it, but then the RNA is broken down and the process stops. Anyway, back to our code. Promoters are sequences where RNA polymerase can grab onto the DNA and start making that RNA copy. The RNA copy acts as instructions for the protein production factory that'll grab onto it called a ribosome. The ribosome reads the RNA in 3-letter chunks to know both where the start and end of the protein sequence is and what that sequence should be. But what happens when the ribosome gets to the end of the protein sequence? Well, there's a stop codon, but the other thing you need is called a terminator. This is a sequence that, among other things, forces the ribosome to pop off, and it will also make the RNA transcription stop as well during that step. This combination of promoter, protein sequence, and terminator is what's called an operon, and is the basic structure of all genes. So let's actually do it and try this out. To start with, I've got a plasmid that codes for a bright green fluorescent protein in this tube. But how do we get the DNA into the bacteria? Also, it's actually not enough to just say, I want to use E. coli, because there are many strains to choose from. I'm going to be using this plate of E. coli strain DH5A as the starting point for this process. It is a super common lab strain that both grows quickly and is easy to put DNA into, though it's not the best for protein production. For our purposes today, that's fine, and the ease of transformation is what we want. And you can get it now on our store. To get started, we need the bacteria to be very actively growing, so I'm going to set up liquid culture to grow overnight. The liquid in this tube is called LB, or lysogeny broth. It's a mix of yeast extract and enzymatically digested milk protein called peptone, as well as a little bit of salt to taste. You can either buy this as a pre-mixed powder or buy the individual ingredients and mix it up yourself, which is what I do since it is much cheaper that way. We need it in two forms, liquid like this, and then also solidified into plates with the addition of some agar. For those plates, we need two sets. One with and one without our chosen antibiotic mixed in. Because E. coli aren't the only things that can eat LB, we need to sterilize all of this growth media, as well as work under sterile conditions to avoid contaminating our cultures or our workspace. Generally, sterilizing media is done in a pressure cooker of some kind, and I use these nice dental autoclaves for this. I'm mixing up multiple bottles with and without agar, but no antibiotics yet. These get added after sterilizing as they're heat sensitive. Then we load the bottles into the autoclave and let it cook for half an hour. When the cycle is done, the autoclave is carefully depressurized, and then the hot bottles can be removed and brought back to the lab. At this point, the agar will have melted, so while it's still molten, we can add the correct amount of antibiotic solution. Antibiotics usually come as a powder, so we have to make a concentrated stock solution, which are then sterilized with special syringe filters. These have pores that are so tiny that no living organism can fit through, effectively sterilizing any solution passing through one. Then when the bottles are cool enough that you aren't getting burned, but they are still very warm, we can pour the media into petri dishes which come pre-sterilized. These can then be allowed to cool and solidify. But with that done, we can finally prep our bacteria. By the way, I am breezing through this without giving much in the way of exact measurements, so there's going to be links in the description to written protocols for all this stuff for those that want to follow along. One of the greatest boons to modern biology is the overwhelming amount of information available online, from protocols, reagent info, and more. And to be a biologist is to really collect and synthesize as much information as possible to create working protocols. Unlike chemistry, we can't really see any of what we're handling until the very end. It's all just moving small volumes of clear liquid around. The real magic happens by designing and correctly following protocols, and that's like 99% of the actual work. All right, now with sterile growth media ready, I can inoculate 10 milliliters of normal LB with our E. coli. Then I'll pop it into my Tippy incubator at 37 degrees and leave it to grow overnight. You don't actually need one of these. A regular incubator works just fine, but these do make the bacteria grow a little better. The next day, I'm going to use 500 microliters of this solution to inoculate another 40 milliliters of LB. But this time, we're going to monitor it closely for a few hours. What we're waiting for is the bacteria to be in the middle of what's called log phase. When bacteria grow, they go through distinct phases. First, they're growing slowly for a while until a critical mass has accumulated and their doubling begins to make the population explode. At some point, when the nutrients start to run out, they slow down and hit the plateau phase, before eventually starting to die off. Log phase is when the population is exploding and the bacteria are at their most active. We can check to see where they're at by using a device called a spectrophotometer. It's basically just the light and a photodiode, and it'll measure how cloudy the solution has become by comparing between the pure LB solution and our bacteria solution. This cloudiness is called the optical density, and we're looking for around an OD of 0.5. You can totally learn to eyeball this with enough practice, which is how I used to do this, but if you want the absolute best results, a spec is helpful. With our bacteria grown enough, we need to wash them to get rid of any of the LB and other salts or side products that will impede the DNA going into the cells. And to do that, we're going to be using a centrifuge and a bottle of sterile 0.1 molar calcium chloride solution. But before we do, I'm going to prepare a crushed ice bowl to do all the work in. From this point in the protocol, we want to keep everything very cold. Not frozen, but around 2 or 3 degrees. While the protocol will work without ice, we've checked, and ice actually improves the effectiveness enough to be worth it. Anyway, we take our E. coli solution and load it into our centrifuge with a matching dummy tube filled with the same amount of water on the opposite side to it. This way, the centrifuge won't explode. This will form a pellet of cells at the bottom of the tube. We can then carefully dump out the LB and replace it with 10 milliliters of calcium solution. Everything is mixed by pipetting up and down gently, then it's all spun down again. We're once again going to replace the solution, this time with 8.5 milliliters of calcium. Because the goal of this is to have frozen tubes for later use, we add in 1.5 milliliters of sterile glycerol on top, which will act as a cryoprotectant. Once that's mixed, we're going to aliquot the E. coli slurry 10 microliters at a time into a bunch of tubes. I'm using my fancy repeater pipette to make this fast and save on the carbon tunnel. These can then be quickly frozen in our -80 freezer and are now ready whenever you need them. If you want a protocol that doesn't make nearly as many tubes and only makes a single tube of bacteria, I've put a link to an older video where we go over it. All of these frozen tubes are what are called calcium competent. What we just did was strip the bacteria of its food, and with the cold calcium solution, we're decorating the outside of the cells with calcium ions, as well as opening tiny holes in the bacteria's membrane. This makes it so that any DNA we add in here will stick to the bacteria and have an easy time of getting into the cell.
Grainger knows that if you're a lineman in charge of keeping the lights on, you go to great lengths, and sometimes heights, to ensure the power is always flowing. Which is why you can count on Grainger for professional-grade products and next-day delivery, so you have everything you need to get the job done. Call 1-800-GRAINGER, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Speaking of which, I'm going to go ahead and do a bunch of tubes at once, since we went to the trouble of making a big batch. But each of the tubes will have a different piece of DNA added to them. To each of the tubes, I've added about 100 nanograms of their respective DNA. But if you're using a stubborn strain like BL21, you can increase the DNA concentration up to 1 microgram. And of course, be sure to carefully label each of the tubes, as it is impossible to know what these tubes are otherwise. Anyway, with our tubes of E. coli inoculated with the DNA, these can be put into the fridge for about 20 minutes to allow the DNA time to get friendly with E. coli. Then we're going to do what's called heat shocking. Basically, we're going to stick the tubes into a heat block set to 42 degrees and let them cook for exactly 45 seconds. Then we plunge them back into ice. Basically, what we're doing is making the holes in the E. coli bigger and then in one big flush, forcing a bunch of DNA in and slamming the holes shut behind. To help them recover from this whole ordeal, we add 1 milliliter of LB and then let the tubes hang out in the incubator for an hour or two. Finally, 150 microliters of each solution can be spread out onto appropriate antibiotic plates. These are just left in the incubator to grow overnight. The next day, the plates should be covered in little colonies, and we can see what the DNA did. As a refresher, here is a regular plate of E. coli. Now, here's the one with the green protein. It already looks distinctly more yellow, but look what happens when I hit it with a UV light. It is so bright, you could comfortably read a book with this glow. Using a fluorescent protein like this is called using a reporter, because the glow is our signal, or report, that the modification worked. If we see it, we know the DNA must be present. So there we go. That's our hello world done. And this green, known as Fu-GFP, is easily my favorite. Okay, now that we've got the basics done, let's ramp up the complexity. As I said earlier, there are a lot of fluorescent proteins to choose from. Some don't even glow, but instead are brightly colored in white light. Probably my favorite of those is called Amyl CP. It's a gorgeous shade of blue, but it has always bothered me that you're forced to choose between something that either looks blue or glows blue, but never both. But, I mean, I'm a genetic engineer and I can print whatever I want, so I made this. I call it electric blue, and you'll see that it is both blue in white light and under UV. And the glow color really is a deep ultramarine blue, not the usual cyan of many other fluorescent proteins. To design this, all it really took was a little bit of copy and paste. I looked up the code for Amyl CP, and I found the code for a bright blue glowing protein on FP base called Electra. Then, instead of just pasting them side by side in the plasmid, I added a little flexible linker sequence between them. I also removed the stop codon from Electra to make sure that the ribosome reads through and makes this as one giant protein. The linker is made of a string of glycine and serines represented by these G's and S's. This will act like a big floppy noodle, but keep the two proteins connected, allowing them to do their things, but stay close together. Sure enough, it works exactly as designed, and sometimes designing proteins is literally this easy. You just find the bits of other proteins that do the thing you want, and you slap them together with a linker and express them as a fusion. Moving beyond electric blue, there is a whole collection of other weird fluorescent proteins. Another in my collection actually has the ability to change color. So it initially glows green, but when you hit it with a UV light, you'll start to see it very quickly start to change to orange. Now, instead of responding to blue light and glowing green, it responds to green light and glows red. This is particularly helpful when tagging proteins inside of a big animal cell, because you can hit a specific spot with a UV laser, so only a tiny subset of the proteins in that cell change color. Then you can track each individual protein as it moves around the cell. In a similar vein, I have one fluorescent protein that behaves like a timer, and over the course of about 24 hours, it shifts its fluorescence from blue to red. Here you can see different cells seem to be glowing different colors, and you can see that the red ones are much older than the blue ones. It's also possible to build fluorescent proteins into sensors. For example, if you break one in half and fuse it to a protein called calmodulin, you'll end up with a protein that changes from dim to bright when calcium levels are high, which is the same sort of thing we used in the last episode of our neuron project to see individual neurons firing. When a neuron fires, there's a huge influx of calcium, making the protein glow brightly. If instead of bacteria, you modify something like a fish to contain this protein in its neurons, you can produce crazy videos like this where you see the whole brain firing. Though modifying animals is a slightly different tool set than modifying bacteria. Also, there's nothing to say that you should be limited to fluorescent proteins. You can express almost anything you want, though some things you'll run into some trouble physically or might be illegal. Toxins and infectious agents, for example, are almost always illegal without special licensing. But enzymes, on the other hand, are a great choice, and you can do a lot with them. Enzymes are just proteins that have a catalytic effect and will take some starting compound or compounds and modify them. And this is part of what makes biology amazing. With the right enzyme, you can stick all kinds of crazy molecules together and build it all up from basically sugar. Whereas trying to make the same molecule with classical chemistry could take a massive setup and horrifyingly toxic reagents. Here's a really fun example. ATF1, also known as acetyltransferase 1, is an enzyme that I took from baker's yeast. What it does is stick acetyl groups onto alcohols and forms what are called acetate esters. These compounds tend to smell fruity and pleasant and are part of why fresh baked bread smells so good. It's from the esters produced by the growing yeast as the dough ferments. Making esters like this is a classic high school chemistry experiment, but normally requires concentrated sulfuric acid and a reflux setup, amongst other things. But by expressing the enzyme in E. coli, I can do the same reaction, but instantly and in a tube. If I inoculate a tube with the modified E. coli and then let it grow for a few hours, the E. coli will have produced a ton of the enzyme, and importantly, plenty of the special acetate reagent that's also needed, called acetyl-CoA. When I add a few drops of isoamyl alcohol to the tube and then give it a shake, within a few minutes the tube will start smelling pleasantly like banana as isoamyl acetate is formed. If we sub this out for other alcohols, we'll get other scents, like pear or citrus. Though the trick is to not let it grow too long, otherwise the butthole smell starts to become much more noticeable than the fruit smell. But we'll come back to this construct in the future as it's really fun to play with. But what happens if we want to express multiple enzymes? For example, in a previous video, we made yeast produce beta-carotene and turn the cells bright yellow and orange. But beta-carotene synthesis takes a bunch of steps, so we used a construct that had multiple operons. By following the pattern of promoter, gene, and terminator many times in the same plasmid, you can express multiple things and build pathways where chemicals are handed off between enzymes to make more complex chemicals, or break something big down. With beta-carotene, not only do you need the enzymes to make the actual carotene itself, you also need to add extra enzymes that make parts of the yeast metabolism more efficient and overproduce some of the starting materials. And this is the trouble you'll run into with pathways like this, balancing all the levels of everything and making sure that none of the chemistry is getting bottlenecked somewhere. Companies industrially do this all the time. There is a huge number of products that are made in either yeast or E. coli by expressing a few select enzymes to produce industrially useful chemicals. All those amino acids that get added to your sports supplement, for example, are grown in engineered organisms that have been tweaked to massively overproduce whatever amino acid is interesting. Now, up to this point, we've basically just been telling the bacteria to crank out as much protein as possible because the promoter I've chosen is what's called constitutive, meaning it is always running. Constitutive promoters come in a range of strengths, so you can tune the levels of expression by adjusting the promoter. But that's a very permanent change in expression level and involves more DNA printing. What if we wanted to adjust the level on the fly? In nature, it would be very silly for genes to always be on all the time, even if they're not needed, as that would be very inefficient. So it should come as no surprise that every organism has many ways to turn genes on and off conditionally. One of the classic examples of this is the lac operon. One of the main sugars in milk is called lactose, better known as my ancient enemy. And while I did once genetically modify myself to be lactose tolerant, E. coli don't need to be, as they can eat lactose naturally. But because lactose isn't always present, being primarily in milk, the E. coli need a way to turn the lactose digesting genes off when not in use. This is accomplished with a protein called the lac repressor. It binds to a special sequence between the promoter and the start of the protein sequence and clogs up the machinery, preventing RNA polymerase from binding and the gene from running. But when lactose is present, it binds to the lac repressor, causing it to change shape and pop off, allowing gene expression. There are a lot of repressors like this that have been found and can conditionally turn a gene on or off. There are also the opposite, which are activators. These bind certain sequences and cause gene expression to increase by promoting RNA polymerase binding. This simple system is extremely important because in essence, what we've just stumbled onto is the biological equivalent of a transistor. Instead of controlling the flow of voltage, it controls the activation of a gene. Or with the repressors, it's more accurately a NOT gate. It inverts whatever signal it's given. Before we try wiring them together in bacteria, I've got a little setup made of actual electrical components to show you what I want to build and what we should expect. You can think of transistors like essentially just electrical valves. When you apply a little bit of voltage to their gate, they'll allow a lot of current to flow between the other two terminals. Here I have a pair of transistors wired up into what's called a bistable switch. Basically, whenever I press one of the two buttons, it will switch the state of the circuit and then stay like that. If I press button A, it switches to state 1. But if it's already in state 1 and I press the button again, nothing changes. But if I press button B now, it'll switch to state 2. If it's already in state 2 and I press button B, no change. In bacteria, we don't have switches and wires, and so we use repressors and the sequence they target to program what gets connected. And instead of switches, if we choose repressors that are sensitive to specific chemicals, we can apply those chemicals to cause the system to switch states. And that's exactly what I've built here. There are two sections, the part that acts like our transistors and the part that acts like LEDs. If we zoom in on the transistor part, we can see the trick to how this works. Normally, repressors are proteins that are always produced, and in turn, they control gene expression by binding specific chemicals. But what if we just stopped producing the repressor protein itself? We'd get the same effect, right? If there's no repressor present, there's nothing to stop gene expression. So what I've done is I've taken two repressor proteins, LAC and TET, but I've wired them to control each other. So whenever LAC is produced, it will turn off TET. If TET is produced, it'll turn off LAC. When a cell first starts expressing this system, it'll randomly settle into one of the two states. But we should be able to toggle between the two states by applying the chemicals those repressors respond to. To be able to see what state the system is in, I've put the same DNA binding sequences in front of two different colored fluorescent proteins, which will act as our LEDs. If the bacteria are red, they'll be in one state. If they're green, they're in the other. But we shouldn't see any bacteria that are yellow, meaning that they're producing both proteins at once. Sure enough, the initially transformed bacteria under the microscope show a very clear mix of red and green cells, but very few, if any, yellow. So the cells have correctly booted and settled into one of the two states. When we streak these out on the lactose-containing plates, we get red bacteria, and on anhydrous plates, we get yellow, which means this is working perfectly. We made an actual living transistor circuit. Let's finish this video off with one last construct that is the sum of all we've learned. Once again, here is the electrical circuit I want to emulate. Basically, it's 3 transistors this time that are wired in a circuit. Each of the transistors can be imagined like a repressor. If they're arranged in a loop, this will induce oscillation as each transistor turns the next one off in turn. And we see the 3 LEDs blink in turn. Though this will only work with an odd number of transistors. If we have an even number, it's like the bistable switch and it'll settle into a stable state. But with an odd number, it'll always cycle. In this analog version, we see that the lights don't just turn on. They go through distinct brightening and dimming cycles as they turn on and off. And we should expect the same in the bacteria as well. The capacitors in this circuit sort of represent how much protein is built up. Even when the next element in the circuit is being triggered, it does take time for the previous one to clear. The DNA version is very similar. Like before, it's divided into two sections, the oscillator part and the reporter part. The oscillator is made of 3 repressors wired in a loop, and we've got 3 fluorescent proteins to act as our LEDs. And I've chosen the colors to be as far apart spectrally as possible to make them easy to differentiate and see if this is working. This oscillating construct is called the repressilator and was originally published in 2000 by Michael Elowitz and Stanislaw Liebler as an example of an artificial circadian rhythm circuit. My homebrew version of the construct was designed to make it as easy to use and modify as possible, and hopefully look good on camera. So let's see how we did. Right off the bat, we see that different colonies are different colors, which is exactly what we want to see. In the original paper, their clock was so fast and consistent that they actually got concentric rings on their colonies. On mine, while there are a few colonies that had a bit of a ring structure, nothing like the original paper, which means that my clock must be running much slower. Under the microscope, we see all 3 colors, and the cells seem to only really express one color at a time, which is a really good sign. One of the cool tricks that the authors used were these special microfluidic flow cells that allow you to follow the lineage of a single bacteria as it grows, divides, and pushes the daughter cells out the little tubes. And you can see that the bacteria literally oscillate colors as they grow. Unfortunately, I don't have the special microfluidic system, and my microscope, while wonderful, is very clunky and shaky switching between the color channels. So I'm going to need to build a special rig to record a time-lapse of this properly. But that'll have to be for the future, as it's a rather involved build. Even though I can't make a time-lapse of this yet, we can still test the rest of the circuit by streaking this out on either lactose or TET plates, like the bistable switch. And sure enough, it has a huge effect. On lactose, you get mostly red colonies with blue and yellow mixed in. And on TET, you get mostly blue with red and green mixed in. Under the microscope, we see the same. In the lactose version, we see lots and lots of red cells, some blue and some green. And in TET, we see lots of blue, some red, and some green. Unfortunately, the third repressor isn't triggerable, so I can't make it go mostly green. So the circuit definitely works. I think the tick rate is just really slow. This was actually something I was wondering about when I designed the circuit. Because a lot of the repressor proteins build up on each tick of the cycle, it takes a long time for it to be used up enough for the gene to run properly. It's like having a really large capacitor in the electrical circuit. It'll make everything tick super slowly, but it will still tick. The way the original authors solved this was by having a second sponge plasmid basically covered in binding sites for the repressors on a plasmid that is high copy. This way, most of the protein that is produced gets purposely wasted, allowing the circuit to tick over much faster. I am thrilled that this worked, as it is the biggest genetic circuit like this I have ever coded up from scratch on my own. But I definitely want to make another accompanying plasmid or a second version with a built-in sponge. I'm releasing this first version as the base clock speed, and will release a faster clock in a bit. Also, this and all the rest of the constructs are designed to be easy to pop pieces out and replace them. Don't like one of the colors? No problem, it pops right out. Or you can apply this to something totally new and replace the colors with enzymes. The plasmids are all open source and you can change and use them however you want, and all the code is available on our GitHub. If there's a lot of demand for this and the rest of the constructs, we plan on releasing more plasmids regularly, as well as adding cool organisms to our store like our famous pet, Jerry. Eventually, we'll also release kits for those that want to try their hand at all of this, but don't have all the gear yet. Even though I think I just crammed the better part of an entire year of bio classes into one video, I did have to skip over a lot of important bits. As such, I'm sure you still have a million questions, like how do you actually program this stuff on the computer? Or how do you order a construct from a DNA printing company? Well, thankfully, you're in luck, because with this video, we just released a bonus companion video over on Nebula that covers at least some of those million questions. We go through how to use the DNA editing program you've seen throughout this video, as well as how you can find DNA sequences and how you edit your new monstrosity. Nebula, if you haven't heard of it before, is the amazing creator-owned streaming platform where all of your favorite creators have come together to make and share the content you love without having to worry about advertisers. And we are very proud to be part of the Nebula community. Not only are the videos completely ad-free, there is a ton of bonus content there too. This isn't the only video that came with a Nebula companion. Our Egyptian mummy project had one too, going over all the spells, hieroglyphs, and recipes used in that video. Beyond those Nebula exclusives, there are also Nebula originals, like Mustard's The Origin of Stealth, exploring the engineering of the F-117 Nighthawk, one of the coolest looking stealth aircraft. And if that wasn't enough, there are also Nebula classes where creators teach you about a wide range of topics. One that is particularly relevant today is How to Research Like a PhD Student by Tom Nicholas. It's a great dive into how to prepare for a project like the ones you've seen today. Nebula is the fastest growing independent video platform, and we are joined by so many amazing creators like Practical Engineering, The Hacksmith, Becky Stern, Lewis Wise, and too many others to possibly list them all here. Nebula is also helping creators like us elevate our content and take it to the next level. Better production value, bigger stories, all without having to chase the trending tab or appease the whims of advertisers. So if that sounds good, then use the link in the description to get a year's subscription for the incredibly low price of $36 or just $3 per month. Or the best deal of them all, which is a lifetime subscription for only $300. I can't think of any other streaming platform that is as good value for the price. So head on over to nebula.tv/The Thought Emporium to sign up today and upgrade your viewing experience. That's all for now, and we'll see you next time.
Nationwide is so much more than a great insurance company. They're one of America's largest financial services companies. Like how I'm more than Saquon Barkley, the NFL's reigning leading rusher. I'm also the NFL's leading husher. Shh, hush up back there. Wow, I might have just set the hushing record. Well, almost. For your insurance and financial needs, Nationwide is on your side.
Nationwide Investment Services Corporation, member FINRA, Columbus, Ohio.
This video is brought to you by Squarespace. Inside your head is one of the greatest computers in the universe, which is surprising because I've seen your bro. Those are history, and yes, you do need to eat more fiber. But
Beloved soul, welcome home. We've missed your light. Heaven has watched you through the long nights, through every silent tear. Every moment you wondered, am I seen? Am I truly chosen? The answer is yes. You are seen, you are known, you are chosen. And the reason you're here right now is no accident. God is moving behind the veil. What you're hearing isn't coincidence, it's divine alignment. Take a breath. Right here. Right now. This moment is sacred. What follows isn't just a message. It's the revelation your spirit has been crying out for. God is aligning you with someone younger, not by logic, but by spirit. You've questioned it. You've dismissed it. You've tried to explain it away. But heaven says, this is not a mistake. This is a miracle in motion. For the Lord sees not as man sees. Man looks on the outward appearance, but the Lord looks on the heart. 1 Samuel 16-7. This younger soul has been praying for real love, not superficial, not temporary, but love that speaks in silence, that knows without words, that touches the soul, not just the body. And you are that answer. You carry wisdom shaped by fire. You hold keys forged in seasons they have not yet walked through. This is why you were prepared for such a time as this. Two are better than one. If either of them falls, one can help the other up. Ecclesiastes 4:9-10. They felt your spirit before they knew your name, dreamed of your presence, longed for your peace. And now God is orchestrating your soul's connection. This isn't emotion, it's revelation. Your rhythm calms their storms. Their lightness lifts your heaviness. You'll speak clarity where they've known confusion. They'll restore joy where you've grown weary. Together, you heal what life broke. This is sacred. This is purpose. This is love reborn. Now, as you step into this divine alignment, I invite you to declare it. Type Amen in the comments below if you receive this word. Let heaven and earth see your agreement. And stay with me until the end. We'll close with a prayer that seals this word deep in your heart. Don't confuse silence with absence, and don't confuse delay with denial. Just because your story doesn't fit the world's timeline doesn't mean it's not right on time in God's plan. Listen closely, because this message is not just for anyone. It's for the one who's been feeling too different, too late, too much. But heaven sees you differently. Heaven says, you are right on schedule. Society will try to label you too old, too intense, too experienced, too complicated. But God never asked for their input. His design is not governed by the shallow standards of popularity or public approval. He is not moved by opinions. He is moved by obedience. This love that's coming, it's not for likes. It's not for display. It's not to prove anything to anyone. It's for purpose, for legacy, for healing. They're not coming to complete you. You are not half a soul waiting for another half. You are already whole. You've been forged in the fire. You've been made ready. And the one coming isn't your missing piece, they are your mirror, a reflection of answered prayers and divine preparation. You see, God does not operate within the limits of logic. As scripture says, his ways are higher than our ways. Isaiah 55:9. He operates through destiny. And this love, this sacred connection, is not random. It's a part of the assignment he entrusted to both of you before you ever met. This is kingdom alignment. And yes, it might come quietly, like a gentle rain that softens the hardened ground of your heart. Or it may crash into your life like lightning in a still sky, sudden, undeniable, electric. Either way, you'll know. Because peace will speak louder than fear. Let them talk, let them wonder, let them question. You don't live by their voice, you live by God's confirmation, and heaven has already signed off on this union. Their opinion isn't required for your miracle. This person, this soul chosen to walk beside you, will not shrink you. They won't be intimidated by your wisdom, your depth, or your strength. They will honor it. They will feel safe in it. They won't try to dim your light. They will draw closer to it, like it's the warmth they've always longed for. They won't remind you of your age. They'll remind you that your soul is timeless. And when they speak of you, they won't speak casually. They'll speak with reverence, because they will see you clearly not just as a lover, but as a divine guide, a trusted friend, a safe place. Their respect won't be performative. It will be natural, because your presence brings healing. Don't run from this. Don't sabotage the very thing you asked God for. Don't talk yourself out of what your soul already recognizes. You've done the inner work. You've let go of what wasn't meant to stay. You've cried when no one was watching, and yet you never gave up on love. And now, the promise is catching up to your faith. You don't need to chase. You don't need to convince anyone. You don't need to hustle for what's already yours. Because you're not chasing love, you're becoming it. Every act of faith, every season of surrender has turned you into the very vibration that attracts what heaven has already written for you. This love is coming toward you whole, honest, and heaven-sent. It won't play games. It won't cause confusion. It will feel right. Maybe they won't look like what you expected. That's how you'll know. Because it won't be about appearances. It will be about recognition, the kind that happens soul to soul. You'll know by the calm that settles in your spirit when they're near. You'll know by the way your heart stops racing and just rests. You'll know because God will speak through their presence without needing many words. And you'll know because the fruit will show peace, clarity, joy, trust. This isn't just love. This is assignment. This is alignment. They are not a detour. They are the next step. You may feel them already. In your dreams, in your thoughts, in those quiet moments when your heart stirs and don't know why. That's not fantasy. That's not wishful thinking. That's your soul preparing for what it was always promised. And when it arrives, you will recognize it not because it looks like the movies, but because it feels like home. You are right on schedule in God's calendar. You are being preserved, not passed over. Heaven has been guarding your heart, not because love skipped you, but because what's coming is holy, powerful, and perfectly timed. There's a kind of love that doesn't arrive on demand. It doesn't bow to social expectations or chase temporary trends. It comes when the soul is ready. It arrives when the noise has quieted, when the heart has been softened, and when the spirit has matured enough to hold it. And that is where you are now. So let me ask you gently but directly, can you trust the author of your story? Can you let go of the deadlines and surrender to divine timing? It's okay to feel hesitant. God knows you've been hurt. You've built walls not because you're cold, but because you were never held the way you deserved. But now, something new is unfolding. Something real. Something sacred. Don't let fear answer questions that only love is qualified to handle. The one God is sending isn't coming with confusion. They're not coming to fill a void or play a part. They're coming with a heart that's already been broken and healed. They've tasted betrayal. They've wrestled with doubt. But when they see you, they will see home, not perfection, not performance, just peace. This love won't arrive because of your age, your appearance, or your resume. It's not rooted in logic, it's rooted in spiritual resonance. Your soul recognizes what your eyes haven't seen yet. This is the kind of connection that transcends surface. It's not about matching years, it's about matching callings. Your spirit has been shaped by fire, theirs has been refined by storm, and together you become balance, restoration, wholeness. In Genesis, when Isaac met Rebekah, he wasn't chasing a partner, he was grieving the loss of his mother. But when he saw Rebekah, he was comforted. Genesis 24-67. That's what's coming to you, not a fantasy, but a comforter, a co-builder of purpose. You are not imagining this shift. You are not delusional for still believing in love after so much disappointment. You are simply hearing the whispers of heaven calling your heart to attention. This is not the time to shrink. This is not the time to doubt your worth. This is the time to stand open-handed and expectant. Because what's coming will not diminish you. It will not make you feel smaller. It will not take from you to feed itself. It will remind you who you are. It will mirror the work you've done in silence. It will speak to the healing you thought no one else could ever understand. And yes, this person may be younger, but do not let the world's obsession with appearances blind you to heaven's design. This is not immaturity meeting experience. It is spirit meeting spirit. They've been prepared. You've been preserved. You didn't miss each other. You've been moving toward each other, not by accident, but by divine orchestration. And when it happens, it won't be loud. It won't need fireworks. It will feel like stillness after chaos, like the moment you exhale and realize, this is what I've been waiting for. You'll see it in their eyes, not the gaze of lust or curiosity, but of reverence. You'll hear it in their questions, the ones no one else ever thought to ask. You'll feel it in their presence, not rushed, not unsure, but anchored. They won't just hear your words, they'll listen between them. They won't just hold your hand, they'll hold space for your soul. To them, you won't just be another chapter, you'll be the turning point. This isn't just romance, this is a return, a homecoming, a divine unveiling. So let the fear melt, let the armor fall. You are not being left behind, you are being aligned. And heaven is not late, it's right, on time. There will be moments quiet, breathtaking moments when they stop mid-sentence, eyes softening as if something eternal has just touched them. And they'll whisper, I've never felt this safe with anyone before. That's not chance, that's not chemistry, that's soul recognition. Because even if their mind can't explain it, their spirit remembers you. They've walked through long valleys. They've prayed with trembling voices. They've pleaded with God, send me someone who won't play games, someone who doesn't come with hidden motives or half-love masked as affection. And heaven heard. You are not just an answer to that cry, you are the fulfillment of a promise God made to their heart long ago. But you're not coming to complete them. You're coming to call them forward into the next version of themselves, into the purpose that's been waiting for the right person to unlock. And they will do the same for you. Because they carry something you once buried, something tender and unguarded, a lightness you were once told was too much, a freedom you had to hide just to survive. But their presence, it will feel like permission, like stepping barefoot into grace. This isn't about control. It isn't about fixing or saving anyone. This is about divine partnership, a covenant connection forged in purpose and fire, the kind of bond where no one shrinks to make space for the other because both rise in each other's light. They won't flinch at your strength. They won't be intimidated by your age, your power, your story. In fact, they will honor it. With every glance, every word, every act of gentle pursuit, they'll say, I see what you carry, and I want to love you with care because you've walked alone long enough. God is not sending someone who needs rescuing. He's sending someone ready to build, ready to grow, ready to listen, ready to pour into you with the same intention and reverence you've spent a lifetime giving others. Their presence will feel like rain after drought, like melody after silence, like Sabbath rest after war. And no, they may not have your years, but they have your rhythm, they have your heart, they have the humility to sit at your table and the courage to bring something of their own. They won't impress you with loud declarations. They'll earn your trust with quiet consistency. No confusion, no mixed signals, no dishonor. Just steady, humble, sacred pursuit, because they know, without a shadow of doubt, that you are the one. And here's the truth. You will laugh again. Not the polite, measured laugh you've learned to give, but the deep, belly-shaking, throw-your-head-back kind of joy you thought life had stolen. You'll dance again, not for anyone's approval, but because freedom will rise in your bones. You'll stop shrinking. You'll stop editing yourself. You'll stop hiding your softness like it's something to be ashamed of. And when people around you question it, when they say, but they're younger, what could they possibly understand? You'll just smile. Because this won't be about logic. It won't be about fitting into the mold of what makes sense to them. It will be about destiny. It will be about divine timing. It will be about what God Himself has ordained. And no voice, no critic, no cultural expectation, not even the echo of your past can undo what heaven is now establishing. This union, it is not a reaction, it is not a rebound. It is a revelation. It is holy. It is blessed. And it is coming right on time. Because this season of your life is not a closing chapter. It's the divine beginning you didn't even know you were still allowed to hope for. And now you'll see. God saved the most sacred love for last. You're not simply falling in love. You're stepping into destiny. What's unfolding in your life right now is far bigger than emotion, timing, or even attraction. This is a divine orchestration, a holy partnership that doesn't just bless your present, but breaks chains tied to your past and rewrites the future for generations to come. This love was never meant to be ordinary. It was meant to be a healing force, a light sent into the dark corners of family history, into spaces where silence, shame, or sorrow once ruled. You're not stepping into romance, you're stepping into restoration. And no, you're not too late. You're not foolish for believing in something deeper. You're not settling for less. In fact, heaven is raising you higher, lifting you into the fullness of who you've always been, beneath the survival, the performance, the self-protection. And the moment you stop running from it, when you stop second-guessing what your soul already knows, you'll feel it. Not just a fleeting emotion, but the peace that surpasses understanding. Philippians 4-7. That sacred yes in your spirit that says, this is it, this is real, this is safe. The one who is coming into your life is not random. Heaven is guiding them. Every day, every challenge, every lesson, they're becoming more ready to meet you where you are. Your prayers were not whispers into a void. They were seeds planted in the soil of eternity. And now, God is bringing the harvest. Even if they seem far, whether by distance, circumstance, or timing, remember this. God is never delayed. He is intentional. The crossroads of your life and theirs has already been written. Psalm 139:16 says, all the days ordained for me were written in your book before one of them came to be. Nothing is out of place. Nothing is off schedule. You are not chasing love anymore. You are becoming it. And as you radiate that truth, love without fear, presence without pretense, softness without apology, they will be drawn to you. Not because you demand attention, but because your spirit speaks a language theirs has waited to hear. This time, you'll know what it means to be chosen fully, not for what you can give, not for your outer beauty, not for your effort, but simply for who you are at your most unfiltered, sacred core. They will see your scars and still call you beautiful. They will witness your strength and say, I honor that. They will walk beside you, not only in sunshine, but in shadows. They'll hold space for your doubts and stay. They won't just be there when it's convenient. They'll be present when it's uncomfortable, when the past comes knocking, when you question your worth, when vulnerability feels too raw. And in those moments, they won't retreat. They will choose you again and again. Because this isn't a fairy tale. This is a faith story. This is the fruit of refusing to settle, the reward for waiting on God's design rather than fabricating one out of fear. This is what happens when you surrender your timeline for His timing. And now it's arriving. So what do you do now? You stay open. You stay soft. You stay honest. Don't build walls before the door even opens. Don't dismiss this love just because it doesn't match the world's mold. Heaven doesn't match based on logic. It matches based on purpose, on frequency, on spirit. The world may say, they're too young, too different, not what we expected. But heaven says, this is who I've prepared. Heaven isn't looking for perfect symmetry. It's looking for heavenly design. Because love, when it is truly holy, doesn't need to look conventional. It just needs to be God ordained. And this is what you've waited for. Through loneliness, through loss, through seasons where it felt like your heart had been buried under layers of self-defense, you still chose to believe. You still prepared. You still surrendered. And now you're being asked to receive, not because you earned it, not because you checked every box, but because God is good, and He delights in blessing you with what no eye has seen, no ear has heard, no mind has imagined. 1 Corinthians 2-9. You are not being lucky. You are being loved. Intentionally, eternally, and exactly as God always intended. This isn't the end of your story. It's the beginning of a divine legacy. This is not just a story about love. It is a revelation about timing, identity, and the sacred way heaven fulfills promises. Everything you've been through, every heartbreak you've survived, every lonely night, every whispered prayer, it's all been leading you to this moment, to this divine encounter, to this holy connection that doesn't just feel good, it heals. This connection is heaven's orchestration. They are the confirmation that God heard you, saw you, and has been preparing something greater than you imagined. They are the answer not because they complete you, but because they mirror the strength, softness, and spirit that already lives inside of you. This love doesn't arrive to rescue you. It arrives to rise with you. It will meet you where you are, see you fully, and love you completely, not in fragments or conditions, but in wholeness and reverence. They won't be intimidated by your scars. They'll honor your story. They'll speak life over the parts of you that once felt too broken to reveal. And when they arrive, it won't feel forced or chaotic. It will feel like peace. It will feel like God. Because that's what it is, holy connection in its purest form. So now, as this sacred chapter begins to unfold, walk in expectancy, not anxiety. Let your heart remain in gratitude, not fear. Celebrate the wait instead of regretting the time. because what's ahead of you will not be rushed, will not be stolen, and will not be missed. It is yours, handwritten by the one who knows your heart better than anyone ever could. Let this message anchor you through the distractions of the world. When the noise of doubt tries to shake you, return to this truth. Heaven still writes love stories, and yours is being written in gold. Now is the time to prepare your space, both inward and outward. Start with the little things. Make room emotionally by letting go of bitterness or comparison. Take care of your body not for approval, but as an act of love toward yourself. Speak words of faith out loud, even when you feel nothing. Bless your home with peace. Choose honesty in your relationships. Cultivate the kind of life that reflects the love you are about to receive. Not because you're trying to earn it, but because you're making space for it. Keep showing up to your own life with hope in your hands. Keep loving without fear. Keep listening for that soft whisper of God saying, I have not forgotten you. Because you haven't been overlooked. You've been set apart. And now, what was once just a dream will soon become your everyday reality. You're not just about to be loved. You're about to be known. Fully, finally, and forever. Before we end, I want to invite you into a sacred moment. Let's seal this prophetic word with a prayer that roots it deep into your spirit. Let this be more than a closing. It is your yes to divine timing, divine love, and divine alignment. Heavenly Father, we come before you with open hearts, quieted spirits, and deep reverence. You are the author of time, the God of heavenly design, the one who knows the end from the beginning. Lord, we thank you for every moment you've preserved us, every delay that was actually protection, every no that led us to your better yes. Today, we receive this word as truth, not just with our minds, but with our hearts. We declare that we are not forgotten, not overlooked, and not late. We are aligned, we are seen, we are chosen. Thank you, God, for preparing a love that does not confuse us, a connection that does not require us to perform, and a partner who will not shrink in our presence, but rise with us into your divine purpose. Father, we thank you that this love is not a fairy tale, it's a faith story. You have shaped our souls through fire, tested our hearts through loneliness, and taught us patience through seasons of silence. And now, we receive the fruit of that faith. We embrace the one you are sending, not as a rescue, but as a reflection, not to complete us, but to complement the calling you've placed on our lives. We lift up the one you are preparing. We bless their journey, their healing, their growth, and we ask that wherever they are right now, you give them strength, peace, and clarity. Knit our spirits even now across time and space. Let the moment we meet be wrapped in your unmistakable peace. Lord, we surrender every fear, every timeline, every doubt. We let go of what the world says love should look like. We release every lie that told us we are too old, too much, or too late. And instead, we cling to the promise that your plans are to prosper us, to give us hope and a future, Jeremiah 29:11. We trust that what you've begun, you will complete. Let this love bring healing to what others broke. Let it carry laughter where sorrow once lingered. Let it be quiet strength in a loud, impatient world. Let it be proof that you still write love stories, and that ours, Lord, is being written in gold. Help us prepare emotionally, spiritually, and practically. Let us clear the space in our hearts, homes, and habits to receive this blessing without fear. Let our lives reflect readiness, not resistance. May we cultivate faithfulness in the waiting and generosity in the arriving. Holy Spirit, Remind us daily that we are worthy, that we are whole, that we are not asking for too much, we are just no longer willing to settle for less than holy. Make us magnets for what aligns with heaven. And when love arrives, let us recognize it not by looks, but by fruit, peace, patience, gentleness, faithfulness, and joy. We seal this prayer in faith. We wrap it in trust. We release it into your hands and rest in the assurance that what you've promised is not only possible, it's on its way. In Jesus' name, amen. Thank you for being here today. If this prayer stirred something in your heart, if this message spoke to the deepest parts of your soul, don't just keep it to yourself. Type, "I'm ready for divine love. Amen," in the comments below. Let heaven know, let your heart agree, and let your faith rise. Make sure to subscribe and stay connected, because this space is where faith meets promise, and we're just getting started. More truth, more healing, more divine orchestration is on the way. You are not alone. You are not behind. You are not forgotten. You are about to be loved like never before. And the next chapter, it's not a rewrite. It's the beginning of your legacy.
Do you know Hobby Lobby has hundreds of incredible products on sale every single week? Just check out our weekly ad to discover unbelievable savings across the store and start shopping in-store or online at hobbylobby.com today.
Exterior. Night. Hollywood. Speed camera 1. Speed camera 2.
You there? Yes, you. This message has found you at the perfect time. This is no coincidence. You were meant to hear this. If you've ever felt hated, rejected, misunderstood, or attacked for no reason, this is your confirmation. You are not imagining things. You are not crazy. You are one of the chosen ones. And let me tell you, the hate you experience is not just ordinary. It is spiritual. Today, I'm going to open your eyes to something most people will never understand. And after this, you will never see hatred and rejection the same way again. You will know exactly why most people hate the chosen ones, and more importantly, why that hate does not matter. But before we dive in, I need you to engage with this energy right now. If you know deep inside that this message is for you, type 77, 111, or 333 in the comments. Let your spirit confirm it. And if you haven't already, make sure to subscribe and tap the bell icon, because this channel is your safe space, your divine guidance in a world that tries to dim your light. Now, listen closely. You were never meant to fit in. You were never meant to be liked by everyone. In fact, the very fact that people hate you for no reason is proof of who you are. Let's be real. You've noticed it your whole life, haven't you? From childhood, people have looked at you differently. Some admired you, but many envied or resented you. You walked into a room, and without even saying a word, people just reacted. Some would smile, others would frown. Some would start whispering or giving you strange looks. And you always asked yourself, why do people treat me like this? Well, today you are getting your answer. The world does not hate average people. The world does not despise those who follow the crowd. But the world will always have a problem with those who are different. Those who walk in truth. Those who shine light in dark places. The world fears what it cannot control, and chosen ones cannot be controlled. You don't just exist. You shift the energy wherever you go. You expose the truth, whether you realize it or not. And that alone makes some people uncomfortable. The truth is, they don't hate you. They hate what you represent. They hate the power inside you, the light you carry, the purpose you are walking toward. This is deeper than opinions. This is spiritual. You see, when you are chosen, your very existence disrupts the system. You were sent here to wake people up, to break generational curses, to bring knowledge, healing, and change. And do you really think darkness would welcome that? No. This world is run by fear, illusions, and lies. And when you show up with truth, clarity, and divine wisdom, you become a threat to those who are comfortable in deception. That's why the moment you start stepping into your true self, the attacks increase. People suddenly start turning against you. Friends become enemies. Family members betray you. Strangers go out of their way to bring you down. And at first you think, what did I do wrong? But the truth is, you didn't do anything wrong. You did something right. Your spirit irritates those who have chosen to live in darkness. And I need you to understand this today. This is not a punishment. This is proof of your power. The enemy does not attack those who are weak. The enemy does not waste time on those who are insignificant. The ones who are attacked the most are the ones who carry the most purpose. So if you've been hated for no reason, rejected, isolated, or falsely accused, congratulations. You are powerful. And the sooner you understand this, the sooner you will stop wasting energy on people who were never meant to understand you in the first place. After today, you will no longer ask, why do they hate me? Instead, you will say, of course they hate me. I am chosen. And you will keep moving forward, unshaken, unstoppable. Now, let's go deeper. Why exactly do people hate the chosen ones? Let's talk about it. Who are the chosen ones? Listen carefully. You are not like everyone else. You have always felt different. You see the world through eyes that others cannot. You sense things that others ignore. You walk a path that most people will never understand. And there is a reason for that. You are the chosen one. Now, before we go deeper, let me make one thing clear. Being chosen is not about arrogance. It is not about feeling superior to others. It is about carrying a responsibility that many do not have. Because being chosen is not about what you gain. It is about what you must endure and what you must do in this world. And if you are here right now, listening to this message, something inside you is waking up. You are remembering who you are. So what exactly does it mean to be chosen? Let me break it down. 1, the chosen ones are spiritually awake. Most people are asleep. They move through life blindly, following the crowd, believing whatever they are told, never questioning anything. They chase after material things, social validation, and meaningless distractions. But not you. You see through the illusions. You feel the energy behind words, actions, and situations. You can sense when something is not right. You are deeply connected to your intuition, and it has saved you more times than you can count. Even when you try to ignore it, your spirit always knows the truth. That's because you are not here to blend in. You are here to wake up, to become conscious, and to see the world for what it truly is. And that alone makes you different. 2, the chosen ones carry divine purpose. Your life is not random. Everything you have been through, the struggles, the heartbreaks, the betrayals, has been preparing you. From an early age, you felt it. You were never like the others. While they chased temporary pleasures, you searched for meaning. While they laughed at things that didn't matter, you thought deeply about the world, about existence, about your true purpose. And guess what? You were right. Because chosen ones are not here to live average lives. You were given a unique mission, a spiritual assignment. Some of you are meant to be healers, bringing light into dark places. Some of you are meant to be leaders, guiding others to truth. Some of you are meant to break generational curses, stopping the cycles of pain that have existed in your family for centuries. You were born for more. And deep inside, you've always known it. 3. The chosen ones have an unshakable spirit. Let's be honest. Life has not been easy for you. You have faced challenges that most people couldn't survive. You have been tested, broken, and pushed to your limits. You have been betrayed by people you loved. You have walked alone when others had support. But look at you. You are still here. You didn't break. You didn't give up. And that is because you were built differently. The Most High gave you a spirit that cannot be defeated. No matter how many times you fall, you rise again. No matter how many people turn against you, you keep going. No matter how much they try to destroy you, you come back even stronger. And that is why you are chosen. Because what was meant to break you only made you more powerful. 4. The chosen ones are misunderstood. Have you ever felt like you just don't belong? Like no matter how much you try to connect with people, there is always a distance. That's because your energy is rare. People don't understand you. They don't get why you think the way you do, why you move differently, why you don't follow the crowd. And sometimes that makes you feel lonely. But let me tell you something. You are not alone. There are many chosen ones across the world, walking the same path, feeling the same things. And though we may be scattered, we are connected in spirit. Your soul family will find you in time. But until then, understand this. Not everyone is meant to understand you. Your spirit irritates those who are still asleep. And that is why some people will reject you, envy you, or even hate you. But do not let that stop you, because those who misunderstand you now will one day seek your wisdom. 5. The chosen ones have divine protection. No matter how much you have been through, you are still standing. Ever wondered why? Because something greater has always been watching over you. Think back to the times when you should have lost everything, but somehow you didn't. Think back to the moments when danger was near, but something pulled you away just in time. Think about how, even in your lowest moments, something kept you going. That is divine protection. The chosen ones are always under divine guidance and favor. That is why you survive things that others cannot. That is why you bounce back when others do not. That is why you cannot be destroyed. Because you are protected, and no amount of hate, envy, or negativity can change that. 6. The chosen ones must walk the path alone for a while. This journey is not easy. Many will doubt you. Many will leave you. Many will betray you. And you will have to learn how to stand alone. But understand this, your isolation is not a punishment. It is preparation. The Most High is setting you apart so that you can find your strength, develop your wisdom, and become the person you are meant to be. So do not fear being alone. It is only for a season, And when the time is right, the right people will find you. Until then, stay focused, keep growing, keep walking in purpose, because your time is coming. Who you are is powerful. You are not crippled. You are not cursed. You are not alone. You are chosen. And no matter how many obstacles you face, nothing can stop your destiny. You were sent here for a reason. And deep inside, you already know it. So walk boldly, step into your power, and never let this world make you forget who you are. Why does the world hate the chosen ones? Let's be clear about something. The world does not hate average people. It does not despise those who blindly follow trends, fit in, or conform. But the world will always have a problem with the chosen ones. If you have ever felt hated for no reason, if people have turned against you when you've done nothing to them, if you've been rejected, ridiculed, or envied, there is a reason. And today, I'm going to tell you exactly why. You see, this is bigger than you. This is not about personal opinions, petty jealousy, or simple misunderstandings. This is spiritual. There is a deep, hidden reason why the world reacts to you the way it does. And once you understand it, you will never again take their hate personally. Because the truth is, they do not hate you. They hate what you carry. Let's break it down. 1. Your light exposes their darkness. When you walk into a room, the energy shifts. You don't have to say a word. Your very presence speaks. Why? Because you carry light. And when light enters a dark space, it exposes everything hidden. Most people live in illusions. They wear masks. They pretend to be something they are not. They lie to themselves, to others, and to the world. But when a chosen one appears, their light forces people to see the truth. And that is uncomfortable. People don't like being exposed. They don't like being reminded of their insecurities, their weaknesses, or their darkness. And so, instead of facing their own issues, they turn against you. You are not the problem. You are simply a mirror, reflecting what they don't want to see. And instead of healing, they choose to hate. 2. You cannot be controlled. Most people are easily controlled. They follow the trends. They believe whatever they are told. They seek approval. They live in fear, fear of rejection, fear of failure, fear of standing out. But not you. You move differently. You do not follow blindly. You question everything. You trust your intuition. You think for yourself. You refuse to live in fear. And that makes you dangerous to a system that relies on control. The world is built on manipulation. Governments, media, corporations, even social structures, all of them thrive on keeping people asleep and obedient. But the chosen ones, they wake people up. They challenge the system. They inspire others to think. They break the cycle of control. And that is why the world hates them. Because a person who cannot be controlled is a threat to those who do the controlling. 3. Your energy is too strong. Ever noticed how some people just seem irritated by you for no reason? Even if you are kind, even if you stay quiet, and low vibrational people cannot handle high vibrations. It's like putting darkness next to fire. One has to leave. Your very presence disrupts their comfort zone. It forces them to feel things they don't want to feel. So instead of elevating themselves, they try to bring you down to their level, but they can't. And that frustrates them even more. 4. Envy and jealousy. The truth is, most people live in regret. They settled for less. They gave up on their dreams. They themselves and the expectations of the world. But when they see you, someone who refuses to settle, someone who walks in purpose, someone who knows their worth, reminds them of everything they could have been, and that breeds jealousy. They see your strength, your confidence, your resilience, and instead of being inspired, they feel threatened. They think, why does this person have what I don't? Why do they shine when I feel so dull? Instead of doing the inner work, they choose the easier path. Hate. They whisper behind your back. They try to block your blessings. They secretly hope for your downfall. But what they don't realize is the chosen ones cannot be stopped. No matter how much they envy you, they cannot take what was divinely given to you. 5. The spiritual battle against the chosen ones. This is deeper than humans. This is a spiritual war. From the moment you were born, the enemy knew you were different. That's why your life has been harder than most. That's why you faced rejection, attacks, and opposition. That's why people turn against you for no reason. Because this is not just about flesh and blood. The darkness recognizes your power, and it will use weak-minded individuals as vessels to try to bring you down. Jealousy, the gossip, the fake friends, the betrayals, they are all tactics. But here's what the enemy doesn't realize. Every attack only makes you stronger. Every betrayal only sharpens your wisdom. Every rejection only pushes you closer to your destiny. They hate you because they fear what you will be, and they should, because once a chosen one steps fully into their power, nothing can stop them. Do not be afraid of their hate. So now, let me ask you, what will you do with this knowledge? Will you shrink yourself to please them? Will you dim your light so they feel comfortable? Will you give up because they don't like you? Absolutely not. You were not sent here to be liked. You were sent here to fulfill a purpose. And if the world hates you for it, so be it. Because at the end of the day, their hate is just proof that you are exactly who you were meant to be. So walk boldly, stand firm, keep shining. And remember, it does not hate the weak. It only hates the strong. And you, chosen one, are stronger than they will ever understand. The spiritual warfare against the chosen ones. Listen carefully, chosen one. The battles you have faced in your life are not ordinary. The pain, the betrayals, the opposition. It was never just about the people around you. This is spiritual warfare. The hate, the envy, the sudden attacks. They come from forces far beyond what the eye can see. And if you do not understand this, you will waste your energy fighting the wrong battles. The enemy has known who you are since the day you were born, even before you knew yourself. That's why your life has been filled with obstacles, struggles, and attacks. That's why you've been tested more than others. That's why you felt alone, misunderstood, and rejected. Because the enemy has been trying to stop you before you fully awaken. But now, your eyes are opening. Now, you are beginning to see the truth. And today, I'm going to reveal why the chosen ones are the prime targets in spiritual warfare. The battle is not against flesh and blood. You must understand this war is not physical. It is not about the people who dislike you, the family members who betray you, or the strangers who try to block your path. These people are just pawns in a greater game. The real enemy is unseen. It is the forces of darkness that have ruled this world for centuries. Forces that thrive on fear, deception, and control. And you, chosen one, are a disruptor. You are here to wake people up. You are here to bring light into dark places. You are here to expose lies and reveal truth. And that makes you a threat. Because the more people you awaken, the weaker the enemy becomes. That is why they attack you. Not because of who you are in the physical world, but because of who you are in the spiritual realm. Attacks increase when you are close to your breakthrough. Have you ever noticed? Every time you get closer to something great, an opportunity, a blessing, a new level in your life, the attacks intensify. People start acting strange. You suddenly face unexpected obstacles. Your energy feels drained. You experience doubt, confusion, and anxiety. That is not a coincidence. That is spiritual warfare. Because the enemy knows if you cross that threshold, you will become unstoppable. So they send distractions, they send betrayals, they try to isolate you. But here's what they don't realize. The more they attack you, the stronger you become. The trials meant to break you, actually preparing you for your greatest victory. So when the attacks increase, do not fear. It means your breakthrough is near. The enemy uses people as vessels. Not around you is who they seem to be. Some people are being used as spiritual vessels, whether they realize it or not. The forces of darkness work through weak-minded individuals, those who are easily controlled by jealousy, pride, greed, or insecurity. That's why some people turn against you out of nowhere. That's why some friends secretly envy you. That's why some family members try to discourage you. That's why some people spread lies about you. It's not just them, it's the spirit operating through them. And once you understand this, you stop taking things personally. You stop reacting emotionally. You start moving with wisdom. Instead of fighting back with anger, you protect your energy. Instead of seeking revenge, you let divine justice take its course. Instead of feeling discouraged, you recognize that the attacks confirm your purpose. Because the enemy does not attack what is weak, they attack what is powerful. And you, chosen one, are powerful. Your protection is greater than their attacks. Here's something the enemy doesn't want you to know. You are divinely protected. Yes, you have been attacked. Yes, you have been tested. Yes, you have faced darkness. But look at you. You are still standing. Because no weapon formed against you can truly prosper. Every time they tried to destroy you, you rose again. Every time they tried to break you, you became stronger. Every time they tried to silence you, your voice became louder. Because you are covered. There are angels assigned to your life. There is divine favor over your path. There is a force greater than any enemy guiding your steps. That is why, no matter how much they try, they cannot stop you, and they never will. How to fight back in spiritual warfare. Since this is a spiritual war, you cannot fight it with physical weapons. You must fight in the spirit. Stay spiritually grounded. Meditate, pray, and protect your energy and be mindful of who. Everyone deserves access to you. Watch your words and thoughts. Speak power over your life, not fear. Your words create your reality. Keep moving forward. Do not let the attacks make you doubt your path. If anything, let them confirm you are on the right track. Stay in your power. Do not react emotionally to people who are being used against you. See the bigger picture. Walk with faith. Know that you are protected, guided, and supported by forces far greater than any enemy. You were built for this. Understand this. You were chosen for a reason. Your journey is not easy because your purpose is great. The hate you receive is not a curse. It is a confirmation. The battles you fight are not to destroy you. They are to prepare you. So do not fear the war. You were built for this battle, and no matter what comes against you, you will win. Because nothing can stop what has been divinely ordained. You are chosen. You are protected. You are unstoppable. And the enemy knows it. That is why they fight so hard. But their fight is already lost. Signs that you are a target of hate because you are chosen. Chosen one, have you ever wondered why people turn against you for no reason? Why you face opposition, even from those you once trusted? Why it feels like life has placed you in situations where you are constantly being tested, judged, or rejected? Let me tell you something. This is not random. This is not just bad luck. This is spiritual warfare. When you are chosen, you become a target. The world does not embrace those who carry divine energy. It resists them because your light, your spirit, your very existence challenges everything this world stands for. Some of you have spent your whole lives wondering why people treat you differently. But today, you will finally understand. If you resonate with what I'm about to say, this is your confirmation. These are the undeniable signs that you are a target of hate because you are chosen. You have experienced betrayal from those closest to you. Betrayal is a rite of passage for the chosen ones. People you trusted, people you loved, people you would have done anything for. They have turned their backs on you. Maybe it was a friend who suddenly became distant. Maybe it was family members who never truly supported you. Maybe it was a relationship that ended in deception. And no matter how good you were to them, they still found a reason to betray you. Why? Because your spirit is different. You do not operate like them. You do not conform to their low vibrational ways. Your light irritates their darkness, and instead of growing, they choose to turn against you. People misunderstand you, no matter what you do. It seems like no matter how clear your intentions are, people twist your words, misinterpret your actions, or assume the worst about you. You could be silent, and they will call you arrogant. You could be kind. They will say you have an agenda. You could explain yourself, and they will still refuse to understand. This is because you are not meant to be understood by everyone. The way you think, the way you move, the way you see the world, it is not meant for the average mind. The chosen ones are not here to be accepted by the masses. They are here to challenge the norm, to elevate consciousness, to break generational cycles. And those who are still asleep will never fully understand you. People envy you, even when you have done nothing to them. You have seen it with your own eyes. People who once supported you suddenly switch up. People you barely know look at you with envy, as if you have something they wish they had. But here's the thing. Envy is not about what you have. It's about who you are. Even when you had nothing, they still envied you. Even when you were struggling, they still resented you. Even when you were at your lowest, they still watched you with jealousy. Because it's not about material things. It's about your energy. Your presence alone makes them feel small. Your spirit reminds them of their own unfulfilled potential. Your confidence exposes their insecurities. They wish they had your strength. They wish they had your resilience. They wish they had your favor. And because they do not understand how you shine, even in the darkest times, they choose to hate instead of learning from you. You have experienced isolation and loneliness. The path of the chosen one is not crowded. There have been times where you felt completely alone. You have walked through seasons where no one truly understood you, where you felt disconnected from the people around you. This is because chosen ones are set apart. Your energy does not mix with just anyone. Your soul is not meant to be surrounded by low vibrational people. You are being prepared for a greater purpose, and that requires isolation at times. But understand this, your isolation is not punishment. It is preparation. The Most High is protecting you from certain energies. The universe is guiding you to stronger connections, better opportunities, and people who truly align with your spirit. People try to block your blessings or tear you down whenever you are about to receive something great. Something or someone tries to stop it. Maybe it was a job opportunity that suddenly disappeared. Maybe it was a project that faced unexpected setbacks. Maybe it was a person who tried to sabotage you behind your back. This is because your success intimidates them. Your blessings remind them that you are favored, that you are walking in divine alignment. And some people would rather see you fail than see you rise. But here's what they don't understand. What is meant for you cannot be taken. No matter how many obstacles they place in your path, no matter how much they try to delay you, your destiny is protected. What is written in the spiritual realm cannot be erased by man. You feel attacked for no reason, but you keep rising. Despite everything, despite all the hate, all the betrayal, all the setbacks, you are still here. You have been through storms that should have destroyed you. You have walked through fire and came out untouched. You have faced enemies that thought they could break you, but they failed. Because you are protected, you carry divine energy. You walk with spiritual favor. You are covered by forces far greater than anything that comes against you. And that is why, no matter what they do, you always rise. Their hate is proof of your power. Chosen one, do not fear their hate. Do not shrink yourself to make them comfortable. Do not lower your energy just to fit in. You were never meant to blend in. You were meant to stand out. Their hate is proof that you are walking in your purpose. Their envy is confirmation that you are chosen. Their opposition is evidence that you are on the right path. So keep going, keep shining, keep rising, because no amount of hate can stop what is divinely ordained. You are chosen, you are powerful, and no matter how much they try, they cannot stop your destiny. How to handle the hate and rejection.
Hot sauce.
Chosen one, listen closely. Hate and rejection are part of your journey. They are not accidents. They are not punishments. They are confirmations. You see, the world does not resist what is ordinary. It does not challenge those who follow the crowd. But you are different. You carry something rare, something divine. And that is why you have faced so much resistance. But here's the truth you must understand today. Hate and rejection cannot break you unless you allow them to. You were not meant to live in fear of people's opinions. You were not chosen just to be defeated by the small minds of this world. You were chosen to rise above it all. So how do you handle it? How do you stand strong when the world tries to tear you down? How do you keep moving forward when people throw hate and negativity your way? Let me show you. Do not take it personally. It's spiritual, not personal. The first thing the hate you experience is not about you. It is about what you represent. People who live in darkness will always resent those who carry light. People who are trapped in their own insecurities will always envy those who walk in power. And people who are weak will always try to destroy what they cannot control. It's not personal, it's spiritual. You are a mirror to the world around you. Your presence alone exposes people's weaknesses, their unhealed wounds, their fears, and their hidden jealousy. Instead of dealing with their own issues, they direct their energy toward hating you. But do not waste your time trying to convince them of who you are. Do not beg for their understanding. Do not seek their validation. Because no matter what you do, some people will never like you simply because you exist. And that's okay, because you were not sent here to please them. Do not react. Move with wisdom, not emotion. Hate thrives on reaction. When people attack you, they want to see you break. They want to pull you into their negativity. They want you to react with anger, with doubt. Do not give them that power. The moment you engage in their negativity, you lower yourself to their level. The moment you allow their words to affect your energy, you have given them control over you. Instead, move with wisdom. Let them talk. Let them hate. Let them gossip. But do not waste a second of your energy trying to prove yourself to those who are committed to misunderstanding you. You do not need their approval. You do not need their validation. You know who you are. And when you walk in certainty, their opinions become irrelevant. Protect your energy. Not everyone deserves access to you. One of the greatest mistakes a chosen one can make is allowing the wrong people into their life. Not everyone deserves access to your energy. Not everyone deserves a seat at your table. Some people are sent into your life only to distract, drain, or destroy you. You must learn to protect yourself. Be mindful of who you share your plans with. Be careful about who you trust. Watch people's actions, not just their words. If someone constantly brings negativity into your life, let them go. Your energy is sacred. Your mind, your spirit, your peace. These are treasures. Do not waste them on people who do not appreciate them. Stay focused on your purpose. Your mission is greater than their opinions. Distractions come in many forms. Hate, rejection, betrayal. These are all tests to see if you will abandon your path. Do not fall for the trap. Your purpose is greater than their opinions. Your destiny is bigger than their hate. Every minute you spend worrying about what others think is a minute taken away from fulfilling your mission. Stay focused. Keep building. Keep hating. Keep elevating. Because the higher you rise, the less their opinions will matter. Use hate as fuel. Turn their negativity into power. Instead of allowing their hate to weaken you, use it to make you stronger. Let their doubt push you to succeed even more. Let their rejection remind you that you were meant to stand out. Let their hate confirm that you are walking in power. Greatness has always been met with resistance. Every legendary figure in history, every leader, every visionary, every world changer was hated. And yet, they kept going, because their purpose was greater than their pain. And yours is too. Forgive, but do not forget. Move on without bitterness. Hatred and rejection can create wounds if you are not careful. It can make you bitter, resentful, or even make you question yourself. Do not let it. Forgive them, not for their sake, but for yours. Let go of any grudges. Release the pain. Do not carry the weight of their negativity with you. But also, do not forget the lessons. Some people have shown you exactly who they are. Believe them. Do not allow the same snakes to bite you twice. Move forward without anger, but with wisdom. Walk with confidence. You are protected and unstoppable. Above all, walk with certainty. You are not alone. You are divinely protected. You are guided by forces greater than anything that comes against you. No weapon formed against you will prosper. No hate, no rejection, no enemy can stop what has been written for you. You are unstoppable. The opinions of small minds do not define you. The negativity of weak spirits does not limit you. You are chosen. You are powerful. You are walking in divine purpose. And no amount of hate can change that. Keep rising, no matter what hate is the price of being great. Rejection is the test of the strong. If you are facing these things, congratulations. You are on the right path. Do not let the world make you question who you are. Do not let their hate turn you, break you. Keep rising, keep shining, keep walking in power. Because no matter how much they try to stop you, they will never win. You are chosen, and your destiny is untouchable. The hidden blessings behind the hate. Chosen one, what if I told you that the hate you experience is actually a blessing? What if I told you that every rejection, every betrayal, and every attack was working in your favor? You see, the world has taught people to see hate as a curse, as something negative, as something to fear. But what if I told you that the very hate you receive is one of the strongest confirmations that you are on the right path? Most people do not understand this. They take hate personally. They let rejection break them. They allow negativity to stop them from moving forward. But you are chosen. And once you recognize the hidden blessings behind the hate, you will never see it the same way again. Let's go deeper. Hate is a confirmation that you are different. Look around you. The world does not hate those who follow the crowd. It does not attack those who live in mediocrity. It does not resist those who conform. The world only hates those who stand out, and that includes you. The very fact that you are experiencing resistance means that you are different. It means that you carry something rare, something the world does not know how to handle. It means you have a presence, an energy, a spirit that cannot be ignored. Many people spend their entire lives trying to be seen, trying to be recognized, trying to prove themselves. But you do not have to do anything, and the world already notices you. That is a gift. And while the attention may come in the form of hate, it is still proof that you are powerful. Hate builds your strength and resilience. Without opposition, there is no growth. Without struggle, there is no strength. Without resistance, there is no evolution. The hate you face is shaping you into something greater. It is forcing you to become stronger, wiser, and more resilient. Think about it. If life had been easy, would you be as mentally strong as you are today? If everyone had supported you, would you have learned how to stand on your own? If no one had ever doubted you, would you have the same fire inside you to prove them wrong? Every insult, every betrayal, every rejection, it was all training, because you were never meant to be weak. You were meant to be unbreakable. And hate is what refines you, like fire refining gold. Rejection is protection. So many times we question why certain people turn against us, why certain doors close, why certain opportunities slip away. But what if I told you that rejection is divine protection? What if I told you that those people who walked away were never meant to go where you are headed? That those doors that closed were actually leading you away from something that would have destroyed you? Chosen ones often face rejection not because they are not worthy, but because they are being protected from environments, relationships, and opportunities that do not align with their divine destiny. What looks like a loss is actually a redirection. What feels like abandonment is actually divine separation. What seems like failure is actually a setup for something greater. Trust it. Hate pushes you toward your purpose. If no one had ever doubted you, would you have worked so hard to prove yourself? If no one had ever disrespected you, would you have had the same hunger to rise? If no one had ever pushed you away, would you have found the strength to walk your own path? Hate has a way of pushing you into your purpose. When people reject you, it forces you to seek a higher path. When people betray you, it teaches you to rely on yourself. When people underestimate you, it fuels the fire within you to show them exactly who you are. Some of the most successful, powerful, and influential people in history were once hated, rejected, and doubted. But instead of letting it break them, they used it as fuel. And that is exactly what you must do. Let their doubt push you to go harder. Let their rejection remind you that you were meant to stand out. Let their hate be the very thing that propels you to your greatest heights. Hate separates you from the wrong people. Not everyone in your life is meant to stay. Some people are only there for a season. Some people are only there to teach you a lesson. And some people are only there to test your strength. Hate has a way of revealing the truth about people. It shows you who truly supports you and who was only pretending. It exposes those who secretly envy you. It removes those who are never meant to be part of your journey. And while it may be painful at first, understand that this is a blessing, because you do not need fake love. You do not need false loyalty. You do not need people around you who are only there for what they can gain. Let them go, because when the wrong people leave, the right people enter. The hate is proof that you are chosen. Chosen one, after today, you will never again see hate as a bad thing. You will see it as a confirmation, a gift, a blessing in disguise. The hate you experience is proof that you are on the right path. The rejection you face is proof that you are different. The opposition you encounter is proof that you are powerful. So embrace it. Let it strengthen you, not weaken you. Let it build you, not break you. Let it push you, not stop you. Because no matter how much they hate, no matter how much they reject, no matter how much they try to bring you down, you will rise. And one day, those who doubted you will have no choice but to watch you succeed. The destiny of the chosen ones. Chosen one, everything you have been through has been leading you to this moment. The pain, the rejection, the betrayal, the isolation. None of it was random. None of it was in vain. Every challenge, every battle, every storm, it was all part of your preparation. You were never meant to live an ordinary life. You were never meant to follow the path of the masses. From the moment you were born, you were marked for something greater. And now it's time to understand what that truly means, because your destiny is bigger than you realize. You were chosen to lead, not follow. Most people follow the crowd. They do what they are told, believe what they are taught, and live their lives within the limitations society has placed on them. But not you. You were never comfortable with blind obedience. You never fit into the system. You never followed trends just because everyone else did. And that is because you were never meant to be part of the herd. You were meant to lead. You were designed to break barriers, to challenge the norm, to set an example. Your mind is different. Your vision is different. Your path is different. And that is why people have tried so hard to discourage you. Because the moment you fully embrace who you are, you become unstoppable. You were chosen to awaken others. Your journey is not just about you. You are here to awaken others, to guide those who are lost, to shine light in places where there is only darkness. And that is why your experiences have been so intense. Because how can you lead others through their struggles if you have never faced struggles yourself? How can you teach others about strength if you have never had to fight? How can you speak about healing if you have never had to heal? Everything you have endured was meant to equip you with wisdom, experience, and power, so that when the time comes, you can stand before others and say, I have walked through the fire, and I am still here. And they will listen, because true leadership comes not from words, but from experience. You were chosen to break generational curses. Many chosen ones are born into families with deep cycles of pain, trauma, and dysfunction. And that is not a coincidence. You were placed in that family for a reason, because you were sent to break the cycle. The anger, the addiction, the poverty, the fear, the self-doubt, these things have passed down for generations. But with you, it ends. You are the first of your kind. You are the one who sees what others refuse to acknowledge. You are the one who dares to change what others accept as normal. And that is why your path has been so difficult, because breaking generational curses is not easy. It requires strength that most do not have. It requires endurance, wisdom, and resilience. But you were built for this. And because of your courage, the generations that come after you will live differently. Because of your sacrifices, your future family will not have to endure the same pain. Because you chose to rise, the curse is broken. You were chosen to walk in divine favor. The struggles have been great, but so are the blessings. Chosen ones do not live by the rules of this world. While others struggle, you will find a way. While others are lost, you will have direction. While others are trapped, you will experience breakthroughs. Because favor follows you. Have you ever noticed how, no matter how many times you fall, you always find a way to rise? How, no matter how many enemies come against you, you always find protection. That is because you are not walking this path alone. There are forces working in your favor. You are being guided, protected, and strengthened by a power greater than anything in this world. And as long as you stay true to your path, nothing can stop you. You were chosen to leave a legacy. You are not here just to exist. You are here to leave something behind. Your impact will not be forgotten. The things you do in this lifetime will echo beyond your years. Maybe it's the wisdom you share. Maybe it's the lives you touch. Maybe it's the example you set. But make no mistake, you will be remembered. Because people do not